Hello there, I am Mike Enabling. I'm your instructor. I am a professor, an assistant professor to be precise, at the University of Michigan, where I work in the School of Information. I thought I should introduce myself and tell you maybe a few things about myself before we go really into this XR MOOC specialization. So I've been working in this space for about 5 years now, I would say. I've been doing research in this space, specifically in the area of human-computer interaction. And I've been teaching in the residential program at the University of Michigan for 3 years now, 2 AR/VR courses, one focused really on design and one focused on development. This is in many ways an update of the teach out that I've done a few years ago with a few of my colleagues. It was the augmented reality, virtual reality and mixed realities teach out from the University of Michigan. Maybe you've seen me there. It was great to meet some of the learners in that MOOC. And many of you have actually said we wanted to learn more about design and development. So we've heard you and we've added significant content in both of these areas. Right, so I care about XR. You guessed that. It is really important for me that we all understand these technologies. They are making it into our everyday lives. They are there. They're not going to go away. We still have an influence on how to shape those technologies so that we have a better control, right? How these technologies make it into our everyday lives. In any case, it's time for me to pay back and pay it forward. So I hope what you learn here today is something that I had to learn myself, not just today, but over the next few weeks. It's not going to be that fast. Almost tricked you there, right? And I hope that you share that knowledge and that you invite other people to also learn about these things. Not everybody cares about development. Maybe some of us care about design, hopefully even more. And then a lot of us should really care about where this space and these technologies are going. And we should have some critical discussions about this. So, thanks for letting me meet you and joining me in this effort of spreading the knowledge around XR. And I really look forward to seeing you in the course. Hope we get to interact with each other, maybe perhaps even meet in person one day. That would be exciting. Hello and welcome to the XR MOOC. Course overview of the user experience and interaction design for augmented reality, virtual reality and mixed reality course as part of the XR MOOC. In this course, we're going to talk about XR design and how to make that transition from more or less traditional user experience and interaction design principles, methods and tools to XR. And this is a transition I've made myself, and I've taught these topics for many years. And I've done research in this space of XR design and coming up with new ways of enriching paper and making paper immersive so that we can use it to actually prototype AR/VR interfaces without writing code and without implementation. So the topics I'll cover in this course are very, very important to me, and I hope you'll learn a lot. So the way I've structured this course is into 4 big blocks. We're going to have an intro, where we're going to talk about what doing XR involves, finding your process, and really how do you get started. And then we're going to talk about design thinking. Design thinking is this 6-step method coming out of the Stanford Design School. And it's been applied for many years in many different areas. It's often associated with product development. It is really about a mindset of how to approach design. And I want to make that transition to XR, and now there are interesting challenges with XR. For example, not a lot of users have a lot of experience with XR. There are some early adopters, you might be one of them, but it's not like that everybody really experiences XR all day, every day. It's not like with mobile and the web, where we now have an established set of tools, methods, and principles. So with XR, it's actually quite different. And also the process is still something that is constantly evolving. So I think it's a very good thing to look at design thinking and how this may translate to XR. And so then we're going to continue into prototyping, both physically and digitally. And I've divided this into 2 kinds of separate modules because I personally think there's a lot of value in physical prototyping. It's a lot of fun. It allows us to think through user experiences and prototype them out using physical materials like paper, transparency, cardboard, and Play-Doh for the 3D modeling parts, which is actually quite fun. And it really allows us to think through an experience before we implement it in code or before we move digitally. And then we also talk about doing things digitally. And then when we do things digitally, we have a number of options. Since now we're doing AR, VR, we don't just have to do traditional desktop 2D design. We can actually jump right into the headsets and doing it in a way that is called immersive prototyping. And so when we have covered each of these blocks, I'll give you a quiz and we'll assess your learning and we're making sure that we're on track. In addition to the quizzes, you also have options to access additional content as part of the honors track. The honors track really comes with a set of activities and exercises that allow you to practice and exercise the methods and skills. So in this case, I have created an exercise around design thinking. It's actually a two-step exercise focused on critique. And we're doing design critiques of existing interfaces, first based on guidelines, and then going also deeper on ethics. In the second part of the honors track, we're looking more at physical prototyping, and we're coming out of storyboarding and wireframing, and we're going to do paper prototypes. Paper prototypes to me is always one of the most fun activities in any kind of classes that I teach. I think it's a way for the students to really express and explore their creativity. And I hope you'll find them valuable and maybe you'll learn a thing or two of how to make good use of physical materials to really, think about the XR experience and to play it through, walk through it and walk your stakeholders through it before you sit down and really go into coding. Very, very important. A time saver and avoids premature commitment to anything AR, VR. Just because you think you want to do AR, VR doesn't mean that it's the right solution. And so that's something you may be able to eliminate and rule out early in the process. So that's actually really quite important. And then in the last block, the honors track associated with digital prototyping, we're going to have two types of prototypes. We're going to do a digital prototype that is basically just using desktop tools and then allowing us to preview on an AR, VR device. And when we do the immersive prototype, that's really something that I'm still exploring myself, understanding really what's the value of it, what are the kinds of things we should do so you can sketch in 3D and do all kinds of interesting things. And if you're really good and fast at it, it might feel very productive. But I'm still trying to figure out what's the real value in the larger workflow, in the larger process. Now, none of these techniques are designed to replace each other. They are all designed to complement each other. Let's take a look again. As you're doing your storyboarding, which revolves around wireframes and organizes wireframes basically into sequence, and you're deciding on user flow, and then you're jumping into paper prototypes, and then digital prototypes, and then maybe optionally, if you want, an immersive prototype. Now, each of these really tell you more about design. So in each of these steps, you learn more about their requirements, and you're getting closer to what we then call the minimum viable product. In this video, we're going to talk about what doing XR involves. We're not actually doing XR yet, so this is not the video that goes through all the design and development activities that are out there. Now, in this one, I really want to provide an overview, and I want to draw an analogy to filmmaking, because in many ways, I think creating an XR experience is similar to making a movie. Why do I say that? Well, think about it. So, creating a movie is really a creative, complex task. It usually involves lots of people in different roles. So from the director and the person writing the script to the director of photography, so the cameraman. Then you need actors bringing the characters to life. You need somebody who takes care of light, of sound, and then obviously special effects, right? We often go to the movies and we really talk about two things, either great story or great special effects. Now, the best movies get both right. And with XR, it's really the same. So we have a story that we somehow have to convey in VR or in AR, And I'll think about story in a variety of ways, and I'll explain that a little bit more to you. And the other reason why I choose filmmaking as this analogy is because everybody can make movies these days. We can just use our smartphones to record things and then share, and you don't actually have to have formal training. And with XR, it's the same. There's lots of tools out there, so we will increasingly see hobbyists creating XR experiences. Now that is both cool but also dangerous, because it would be better if we really understood XR design, if we were ethically responsible and would really pay attention to, making our users feel comfortable and safe in these XR experiences. And there are lots of examples out there where this is not always the case. So let's take a step back and define a few key terms. And you've heard about these terms before. So I'm going to draw out the reality-virtuality continuum. So I put reality on one side of the spectrum, and then I put virtual reality on the other side of the spectrum. So now if you were to add AR, it would be roughly here, because it is mostly augmenting the physical world. You see mostly the physical world, and then we'll add in some virtual content, superimposed, and so merging with the physical world. Now the more virtual content we add, the more we are entering the space of augmented virtuality. So this is mostly virtual content, and we are incorporating elements from the physical world. So now that is an interesting design dimension that you have here, and it is really a continuum. To refer to this part of the spectrum, we often use the term mixed reality. Mixed reality refers to the inner part of the spectrum, doesn't necessarily include VR, and to most people it's almost like a synonym to AR, but as you can see in this visualization, that would be ignoring all the things we can do in augmented virtuality. So I often use the term XR, and some people refer to XR as extended reality, suggesting it would be something more than all the previous AR, VR, MR things we've seen before. But I just use it as a placeholder, so the X is a wild card for A, M, and VR, so augmented, mixed, and virtual reality. So now that we have established these key terms, what is an XR experience? So I think of XR experiences as incorporating three main elements: environment, 3D characters, and interactions. So when I talk about environment, we really need to distinguish the physical and the virtual environment. So the physical environment is obviously the one in which the user is, and then the virtual environment is the one in which we port the user. In VR, the user is in this completely virtual environment. They may not actually have any relationship really to the physical world in which they are. And in augmented reality, we really want to read the physical environment and meaningfully augment it with virtual content. So these are some of the main differences and challenges also when it comes to AR and VR, and I'm going to expand a little bit on this idea of environment as we move forward in this video. The second main ingredient is 3D characters, and here I have examples of avatars, 3D models, and data. Now 3D models is probably the first thing that came to your mind, but let's talk about avatars quickly. I could be an avatar. So somebody may have carefully captured me using some form of 3D reconstruction or maybe some kind of motion capture to bring me to life, so that I really look like a virtual copy of the real Michael. So that's avatars. So then I said 3D models, and 3D models, it could be that somebody, a 3D artist who has skills in 3D modeling, sat down and carefully modeled me. And then they rigged me, which means they inserted a skeleton so that they can then start to animate me. And then they can define a few key animations, which then look like gestures, and that way bring me to life. So if I were a 3D model, that would be how it's done. Now, I think of 3D modeling really as a separate set of skills that if you have them, it obviously makes you a more complete XR designer. But I do think that XR design, there's so many other issues we need to take care of. We really think about the user experience more than any of the specific content elements. And so this is really not a key set of skills that every XR designer has to have. There's also lots of free 3D models out there, so that's great, and lots of platforms on which we can share 3D models. So we'll introduce you to those. And so you can basically get around doing XR without being a 3D artist. Finally, you may want to visualize or somehow spatially represent data. So for example, through sound. So Data could be some kind of graph that you want to plot in an immersive way to communicate to users interesting, complex concepts. And so I don't actually have a really great example here, but I just wanted to tell you that these 3D characters are not just avatars and 3D models. It could be really something a little bit more abstract. So for example, a graph or 3D sound. 3D sound is more than stereo. So we could have a source somewhere in the scene that emits sound, and that sound would come from that direction, and we would adjust the pitch and the volume accordingly. So these were 3 examples of 3D characters, and there are many more. Let's talk about interactions. The most important thing to distinguish with interactions is there are explicit interactions and implicit interactions. So explicit interactions are those where the user is really aware of them. For example, gestures that they know the system will recognize, or speech commands that the user is aware the system will understand. Implicit interactions are those that are not directly asked of the user. So for example, in AR and VR, we have a lot of implicit camera-based interactions, gaze, head gaze, or eye gaze-based interactions. And these are examples of implicit interactions. So in AR, VR, we really have this interesting interplay of implicit and explicit interactions, and we really need to design for that. That has its own challenges, and one of the main issues currently is that most design tools, so those geared towards non-technical users, are often very limited in the kinds of interactions that they support. So there are toolkits and libraries out there more geared towards programmers that I'll introduce you to in the course focused more on development, to really expand on the vocabulary of interactions that we have available as XR designers. So if we step back a little bit, I mostly talk about content and interactions. And when I say content, I really think about both the 3D models and all the 3D characters in the scene, and also the environment. So basically the physical environment in which the scene takes place, and then the virtual environment. These are more like the background elements, and the 3D characters are really more like the foreground elements. But both are content elements. Okay, so that is how I think about XR experiences, the main ingredients in terms of content and interactions. So now I want to think a little bit more about where the experience takes place, context, and what is really the story of the experience, to come back to this analogy from filmmaking. So when it comes to context, we really need to distinguish AR and VR. So context, the physical environment around the user, really impacts the virtual reality experience. Now, even though you don't really see it, you design this VR environment. And that actually needs to fit in the real world. Let me illustrate this quickly. So you are designing the inner bubble here, the VR world, and it's actually somehow enclosed in reality. Now, the virtual reality, the virtual world may be much larger, physically speaking, than the actual physical room in which you are. And this actually introduces interesting challenges. I'll introduce you to locomotion and ideas of redirected walking, and then common metaphors for travel in VR, for example, teleporting. So we learn about all these things, but it is important to really think about the fact that the virtual environment does normally not perfectly match the physical environment in which the user is, because we are trying to port them into a different world. That is often the idea behind virtual reality. And so this introduces interesting issues, and so context is really important. So when we now think about AR, there's a more direct relationship between context and augmented reality. So the physical world in which you are really drives the AR experience. You design this AR environment, and it actually has to blend with the reality. So it has to merge, it has to not just fit in, but it actually has to complement, add, or remove something from this physical world. And in order to do this meaningfully, you really have to understand it. So on the VR side, we really talk a lot about environmental design, and on the AR side, we really talk a lot about environmental understanding. And here's a key thing that I really want you to consider. So if you're designing for AR, it's not just designing this inner bubble. You're actually designing the experience that includes also the real world around it. So it's not just a matter of putting a 3D model in front of your user and then having no relationship to the real world around you. No, a good AR experience really takes care of this combined, this merged experience. And so that's why I actually highlight both aspects here. Now, keeping with this, let's talk about story. So in VR, the way I think about it is you are actually telling the story at the intersection of the real and the virtual. So what I highlighted here in red, this boundary, is really what you're working with. Think about it this way. The best VR experiences that I've had somehow got this mapping between the physical and the virtual world really right. So for example, I was in some kind of game with a headset and it was collaborative, and then I had to solve a puzzle, and that puzzle involved pushing virtual buttons. Now, as I was pushing these buttons, in most VR experiences, you don't actually have the physical, the haptic feedback, the tangible haptic feedback. But in this case, the physical environment really matched the virtual reality experience. There were actually physical buttons that I was able to press, and so this really was a really cool story. A negative example would be if you had obstacles in the way that are not communicated to the user. So they're like, something is like a chair is in the way or something like that, and you don't see it because you're fully immersed in this VR experience. That would be really, really disruptive. So you're really telling the story at this intersection. Now, in AR, that's different because you're actually telling the story at the union of the reality and the virtual content. So you're actually telling that story that I highlighted here, not just your virtual content and with no relationship to the real world. Unfortunately, there are a lot of AR experiences out there that seem to think it's enough to just bring some kind of virtual element into the physical world, and that's AR. But it's not really AR, right? This augmented reality. So I just thought it would be a good way to think about storytelling that way. So now that we've established this, let's take a look at an example. So in the following, I'd like to share an example, our example of the Lion King 2019 remake. We were studying basically, we were working on a research project in my lab at the same time as The Lion King was about to come out, the 2019 remake. And it was so interesting to us. I mean, I was just awarded a faculty award from Disney, and I promised I'll do something with that research funding. And I was working on this project where the idea was to really allow multiple designers to collaborate, be it in AR or in VR, and collaboratively author, actually using immersive authoring, XR experiences. And so we looked at a couple of examples, and one of the most complex examples that we looked at was The Lion King. And so it was very interesting for us to look at the teaser. The teaser had just come out, and so we analyzed the teaser. And we were basically using that Lion King example as a case study to really learn more about tool support and what is involved in doing XR. And why did we choose The Lion King? Well, The Lion King, don't know if you knew that, but that remake was actually directed and shot in virtual reality. So basically, the cameraman was like in there, in the headset, and chasing down the animals and things like that. And that was how it was recorded. And so it was a very interesting case study, and I'll share it with you because I do think it's good with keeping with this lecture where we want to understand what doing XR actually involves. So this is the Lion King case study, and it's from our paper, which I invite you to read on XR Director. And I want you to pay attention to a few things. I'll actually start at the end, not the beginning of this project. And I'll show you an example of a scene that we shot. We were still experimenting with Rafiki climbing up Pride Rock. And it was a vast virtual environment that we were trying to prototype, obviously with limited means. We didn't have a $250 million budget. And we had two actors here. So we're gonna do this scene where Rafiki climbs up Pride Rock, and the actor, or actors in this case, will be Jane in the VR headset, and then Katie will be our director of photography operating the camera, and this is an AR capable phone, and I'm going to be the director. And I'm going to show you
one of the many takes that we did, so that you get a sense for how we worked on this little project. And again, I mean, we are not Disney and we had a much smaller budget, but I think it still serves the purpose of this lecture. Action! Cut. Action. Cut. Okay, Jane, go back. Katie, I want more movement from you. So why did I share this with you? Well, this is my example of creating an XR experience and using techniques more or less from filmmaking. So if you think about filmmaking one more time, so we have all these various roles that I talked about earlier, and then how do they actually translate to XR designers and developers? Where the director, that is usually the person in charge, and if it's a one-man project, then would be just the XR designer or the XR developer. In a larger, more professional XR experience, you might have a project lead, so that might not be the same kind of designer or developer. But many XR experiences are really just created by almost a single person, and that person would then function in all these different kinds of designer or developer roles that I'll spell out here a little bit. Now, the most interesting part when it comes to differences between filmmaking and XR is that the director of photography, so the person in charge of the camera, is actually the user. And now that introduces a lot of interesting challenges, design challenges. It gives a lot of agency to the users and autonomy, and that's really what we want. That's like one of the main affordances of VR and AR, this idea of being able to explore virtual content in 6 degrees of freedom and really go about and choose your own perspective and all that. But from a design perspective, you really have to make sure that you draw the attention of the user accordingly, that there are the correct visual and maybe audio cues and all these kinds of things. So that's interesting challenges there. And then when it comes to the actors, well, on the XR side, often it is just a designer who composes scenes of 3D models. And if there are no freely available 3D models, or the designers feel like they really need more basic custom 3D models, then usually you can do so and so much without 3D modeling, but then usually you would have to work with a 3D artist who really can create 3D models and rig them and then animate them. And as I said, this is really a set of skills that not necessarily every XR designer has to have. Another way to actually bring characters to life would be through motion capture, and that's actually a profession. So you could do this, basically these actors in a body tracked suit. That's how most of the Marvel movies out there, for example, are being made. That would be not the most cost effective, but very realistic animations that you would actually get out that way. And then thinking about the remaining roles and their responsibilities. So the gaffers are responsible for light, somebody responsible for the audio, mixing sound, and then the special effect designer. On the XR side, that would be mostly probably the XR designer choosing appropriate lighting and materials. So really making sure that the 3D models have the right materials and settings and textures. And that's something we'll explore a little further. And then also incorporating sound. And again, we're working with spatial sound here. So placing sound sources in 3D and making sure that the audio is according to the physical and the virtual environment. The geometry of those, which is a very interesting task to do this well, so that audio would also be like occluded in some sense if there is an obstacle in between. That really adds to a more realistic experience. And then finally, special effects, that's something that there's only so and so much you can do as a designer. I mean, you have particle effects and maybe shaders if you understand that a little bit, but most of the time you'll probably have to do scripting. And so this is more the role of a technically inclined person, so I say XR developer here. So now I'm going to walk you through the steps of basically going to the beginning of this project and just this case study focused on Lion King and how did we actually work. So first, we started with storyboarding and wireframing, and this is something that I think is inherent to any XR project that I do. I usually start on paper and I plan things out. I have an idea and I sketch those out. So brainstorming for me doesn't happen in thin air. It actually happens on paper. In this case, we were picking scenes from the teaser. The teaser was available to us. So that would normally just be in your head and you would try to express it on paper. So the way we use storyboarding and wireframing here is still relatively close to the traditional sense, but we really figured out like what are the camera movements, what kinds of characters are involved, and then how do they move and how do they relate to each other, and what's the story, and then which sequences are we going to pick. So that's how we use storyboarding and wireframing here. And I'll show you a little bit of what my students and I came up with. So here's our example where my students and I worked on this Lion King remake, essentially the remake of the remake, if you will. And we had a $25 budget. So we basically bought lots of physical prototyping materials, Play-Doh. We did have paper and transparency and a lot of the tools. And we repurposed cardboard that became then our stage. And what is really cool in this way is basically a physical storyboarding activity. So it goes beyond paper. It's actually very close to physical prototyping. In fact, you may look at this as a physical prototype rather than a storyboard. But I do think when it comes to AR and VR things, this idea of prototyping and storyboarding physically, like in 3D physical space, is very, very important. So we had a lot of iterations here, and you can see how my students, Jane and Amy, were filming and testing, and there's another person filming, Neil, is filming them, and then Katie was also in the background. So a cool set of students, a little bit of a film crew. They had to make sure that the background is kind of right. This was one of the harder scenes to film, where a lot of tiny little character movements, and pretty cool. And so, yeah, that was that. As we were storyboarding, you could already see more or less the physical prototyping activity, but I showed you the making of the physical prototypes, and now I want to share with you the physical prototypes. So this is really how a user would experience them. And one thing I would invite you to do, if you feel like it, due to copyright reasons, we cannot play anything at Disney here, but I would like you to, if you can access YouTube and could get access to the teaser that was basically the inspiration for our work, and then you're going to the part where James Earl Jones says, "Everything the light touches is our kingdom." And so when you go there, then after that it really starts with this really cool soundtrack. And that's how I have experienced this prototype. And I usually play it to my students in my class. So I'm going to play the resulting physical prototype. And this is now, in some sense, you're experiencing, it was created with physical only, so reality only. No AR, VR yet, but it gives you a first sense of what it might feel like to be in this virtual world that we are prototyping here. All right, and here we go. This is the opening scene. And we're looking at Pride Rock. And then Rafiki is coming up. This was the thing we had previously done with VR, and we're gonna go there again. Simba moving the head, and Rafiki breaking that thing. It was one of the hardest scenes. We had to shoot this in slow motion. You can see this flickering, which is just a light. And then we're placing that on Simba's head and walking to the top and showing baby Simba. And then we have this really cool scene behind where you can see all the animals. I mean, they're a little bit abstract here, but all the animals down there. All right, so this is that example. And these were just the physical prototypes. And then we were also doing the digital prototypes. So we took each of the scenes and we prototyped them digitally with a number of tools, some of which I'll also cover in some of the courses here. So we did involve Unity, We used A-Frame and WebXR. We did some modeling in Blender, but mostly correction. Several of our models actually came from Google Poly and were done with either Google Blocks or Tilt Brush. And so these are all kinds of immersive modeling and immersive authoring tools, so 3D modeling and immersive authoring tools. And so there are actually quite a range of little technologies involved. It does not look as polished. Somebody in our reviews called this crude programmer art, and that's probably what it is compared to Disney. But even this was quite a lot of effort. So let's take a look. So here I'll show our digital prototype with scripted animations. So it's based on the teaser, and Rafiki is going up, and we see Simba, and you see some reflections, and you can see some differences in the quality of the models. This was again one of the hardest scenes to do. A 9-hour animation and scene done by one of my students. And then we're going in on the final look at the scene here. And a little bit static, this shot. And this one I really like, because you can see a few other animals down there. There was a weird transition just now. But that is the digital prototype that we created. And you can see how the camera spins a little bit. That's kind of nice. Yeah, it is a prototype first. It allows you to envision the final experience. Okay, and so from these examples, what have we just seen? So we basically created this Lion King experience, and I made the analogy to filmmaking, and we have done storyboarding, we have done physical prototyping, and we have done the digital prototypes. And at this stage, what you just saw, we could call the minimum viable product, the MVP. And this you would now need to take further and do another few iterations on it. And we are entering the space of actually developing XR experiences. And so when I think of developing XR experiences, I want to distinguish two types of experiences. So one is relatively basic, but even that one involves already a few components. So you have to decide between AR and VR. You usually put some kind of 3D characters in there, maybe an existing 3D model. And you do have to have at least a directional light and ambient light in order to see anything in this scene. So this kind of basic experience, that's like a single XR designer can do this and mostly compose the scene. If we look at a more complex example here, so let's say we're bringing a custom 3D model, maybe it's rigged and it comes with animations, maybe a few additional light sources, and then also sound. And so this I would now call an advanced XR experience. And if you wanted to create something like this, you really need to jump into different roles as an XR designer. So the custom model, you would actually more or less need to be a 3D artist. So creating a 3D model and maybe animations. You can do this in some existing tools. You can do this, for example, partially in Unity, and in Unreal you can do some basic modeling and model editing at least. But you would normally really jump into a different kind of tool, more geared towards 3D artists. And it's really quite different in terms of how XR authoring works. But then as an XR designer, you could still do the lights and make sure that the materials of your 3D models are properly done. And that's where I think most of the issues actually happen when you download and use free 3D models. There's a couple of issues there. They usually come at very different scales. The origin in these models isn't always really set in a uniform way. So it's not center, it's not the vantage point or anything like that, or the bottom center, or all the things that would make sense. No, it's like really somewhere off. So what we had to do, for example, when we composed our scenes that you just saw from free 3D models, we did Pride Rocker ourselves, but a lot of the animals were just like borrowed from Google Poly, and they are for free and you can use those models. But then you still have to pay attention to scale. And the other big thing, the other big issue is really the materials, and that the models have the right settings so that they properly reflect light. And so as an XR designer, you would have to go in and fix a lot of these things. And then sound. So I mean, we had some issues here with sound, so you would want to maybe have all these animals make some sounds. There's a lot of background music and sound, and maybe really the soundtrack would have really added a lot to that experience here. We couldn't do this for copyright reasons, but you could imagine getting a bunch of free sounds, and you could experiment with that as well. And then we did script the animations. I mean, there's different ways and different tools. So the portion with the stick breaking that part, we did that in Unity with the animation editors there. But a lot of the animations you saw that looked very crude, they were actually scripted in A-frame. So basically using a combination of JavaScript and HTML, and it's not the best way to do these kinds of animations. So now that I have established the basic and advanced XR experience, what does it actually mean in terms of content and interactions? So when you break it down, an XR experience really into the content elements, into the core ingredients, we're talking about 3D models and animations, lights and shadows, environment, so the terrain and all these things around, physics, spatial sound, maybe menus and heads-up displays. And as I said, we distinguish explicit and implicit interactions. So explicit interactions like the cursor, so usually the head gaze, or could be the eye gaze as well, some kind of reticle that shows us according to the surface that we're pointing at. It gives us that feedback. A controller, like a VR controller or any kind of hand movement, speech or voice. So these are the speech or voice commands. So these are examples of explicit interactions. And then implicit interactions, a lot of camera-based movement, as I said, but also could be things like the GPS location. So where you are in the world, and that could tell us a time zone, and that could actually impact how we render things, for example. We're going to bring in this idea of fiducial markers. So that is something that happens in a lot of AR experience. Fiducial means like it's visible to the camera. It's some kind of QR code or some kind of version of a marker, usually printed on paper, that we want to track, and that tells the camera basically its relationship to that 3D content and establishes this coordinate system, and that is oftentimes just an implicit interaction. The marker in itself, although I do think there's a lot of value in marker-based prototyping, and normally in the final user experiences, the marker is just something that you have to have there to establish that coordinate system. It doesn't usually play a big role. And then environmental features could also trigger implicitly some kind of interaction. So basically you're bringing a physical object into view, or you're looking at a sofa if you're doing a furniture placement application, for example. These are examples of content and interactions. And now let's look at how, for different types of XR experiences, we're going to distinguish between VR basic and VR advanced or immersive, really. And then we're going to look at marker-based and marker-less AR. What does that mean? How much of this do we actually need to fill in? So in terms of like a basic VR experience you can achieve and accomplish with a few 3D models, often it's just one, and maybe some light and shadows and cursor, so cardboard-based kind of interactions. And then a more immersive VR experience would really, check a few more elements here. So definitely in addition to light and shadows, you really have more of an environment, a virtual environment, and maybe physics in there, and maybe sound, and that sound is spatial. Maybe means of navigation through menus and some kind of heads-up display. You may have more controller-based interaction or hand-based interaction, and maybe access to speech and voice commands. And this additional set of interactions that is supported, if you go back to the basic and then compare it to the more immersive experience on the interaction side, we're really increasing a lot more on the explicit interactions side. Let's look at AR. So in AR, we need to distinguish between marker-based AR and marker-less AR. And I'm not so much focused on handheld versus head-worn, although I must say that most head-worn ones are marker-less, and the handheld ones really depends on whether your smartphone supports things like AR Core, AR Kit, and then we would actually be able to support marker-less AR experiences. Some people think of marker-based as being inferior to marker-less, just because you have to have a marker. And marker-less really means the system computationally finds its own features, so builds its own markers. And that's something we've established in the previous course. But here I'm just going to give you some examples. So let's look at marker-based, which really is almost like a basic VR experience. You usually maybe have some kind of menu on a handheld at least. We may use GPS location, and we definitely need to use the marker, so the fiducial here gets a big check mark. And then a markerless experience, well, you don't have to have the fiducial, but usually you're closer to a more immersive. So these markerless AR experiences are often a lot richer, just because markerless means the platform gives you access to at least a little bit of the environment through surfaces and their normals, so the orientation of the surface. And then if you're working on a more advanced device that has actually spatial mapping and depth sensing and all these kinds of things, you may get a better read on the environment, and then you can do a lot more things like physics. So you can throw virtual objects into the environment, and those kinds of things could actually be done in a markerless AR experience if you have access to these advanced sensors. So this concludes our tour of what doing XR involves. And at this stage, I was looking a little bit both into the design aspects of it, but then we were also, so with the wireframing and the storyboarding, and then doing the physical and the digital prototyping. And then we were also talking a little bit about what goes on when it comes to the development side of things, and breaking down basic and advanced AR, VR experiences, and then also connecting to some of these technologies. Now, this part was really designed to be an overview. We didn't go too deep in each of these aspects, but that's what this course is for. So we're going to really explore each of the aspects, going further on the design side. And then we also have the course more focused on development that really looks at those aspects as well. So I hope you got a good first sense of what doing XR involves just based on this example. I would invite you to take a look at the making of the real Lion King. It's actually going to be a really cool and inspiring example, and maybe something that gets you into the mood for the rest of this course. So a lot of exciting things that will happen and that we'll learn about, and I'm so glad to be able to share this stuff with you.
In this video, we're going to talk about how to get started. And this is really like a question that I get from a lot of people that want to get started in XR and don't know really where to get started, and what are good examples, what are good tools, should I learn this programming language, should I focus on AR or should I focus on VR, and what is this extended reality that you're talking about? So there's a lot of confusion, especially for novices in this space. It's really quite a vast space to navigate. And so the idea of this lecture is to walk you through some of the key challenges that you have and key barriers that I have observed with students, and then ways of navigating around them, including paths to becoming an XR creator. So I've collected a few key barriers to entry that I commonly observe in students, and then also many of which actually applied to myself when I was getting started in this area. So the first really big issue is finding the starting point. It's really unclear how to get started and where to start. Should I pick up a tool like Unity? Is that my way into XR? What if I'm a web developer? How do I transition? Which of the web XR frameworks out there should I be using? Is A-Frame the right tool? Should I go directly learn 3JS? So lots of issues there. The second key issue is really how to make that transition or jump from 2D to 3D. Many of us are actually trained in 2D design. We are very familiar with the methods and tools there, and the question is really, how do I transfer that knowledge and adapt it to 3D design? And so this is a big issue and a challenge for a lot of us, and is also a core focus. We actually have a lecture as part of the XR MOOC that really focuses on making that transition from 2D to 3D, talking about light and materials and all the kinds of things you have to pay attention to that you normally don't really concern yourself with when you're doing 2D design. The third issue and key barrier to entry, I would say, is finding good examples. First of all, it's actually not clear where to find good content and functionality. If you are experienced with web design or mobile development, you probably have your favorite repositories, you have design systems, you understand material design and all kinds of things there, you know what responsive web design is, etc. And so there are lots of examples out there, and it took years to build really good repositories of knowledge and content that is shared. And in the XR space, we are facing this issue at the moment that there's lots of examples scattered out there, but it's really hard to find them. When you go to resources that are more common to developers like Stack Overflow, it's actually quite hard to browse through there and identify whether something is about XR, is it 3D or is it 2D, and so really finding good examples is an issue. And I'll expand on that a little bit because we've done some research in that area as well in later segments of this video. The fourth key barrier to entry is the vast landscape of tools out there. For a novice user, it's really unclear which tool is the best to use for them and what is actually the use case that they're designed for. There's actually a lot of differences between these tools. It's not like every tool can do all kinds of use cases. Often they are actually optimized for specific use cases, like in the construction industry, or more focused on movies and gaming or entertainment, and those focused on education and meeting scenarios. There are tools that allow you to build, for example, these kind of VR social spaces. But it's unclear which of the tools to use. And it's often not an option to jump into this tool that can do it all, like Unity or Unreal that you may have heard of. These are really big, comprehensive tools, and they're overwhelming in the beginning. And many people actually fall into this trap of trying to do it all with this one tool that they know best. And my approach is usually to get a good overview of the tools out there and think in terms of which one is good for what purpose. And getting that clarity is also one of the main things we want to accomplish as part of the XR MOOC. The fifth key barrier to entry is really the current problem of platform fragmentation. This is really something that is not new. We're just repeating the same issues. If you look at mobile, so there's basically Android and then iOS, so Apple devices, and these are the biggest kind of that we have in the market. And we have similar fragmentation in the VR space. So there's Oculus and Vive. And then Microsoft is trying to go for this Windows mixed reality platform that then speaks to various VR devices and also their flagship, the HoloLens AR headset. But basically creating an app that reaches users across all of these platforms and devices is really, really difficult. And it's something that the WebXR standard is trying to address. And then obviously there are cross-platform development tools like Unity, but it's still an issue, and it's really raises a lot of uncertainty among designers and developers which platforms to adopt, and should I go for Apple's ARKit or should I do Google's AR Core, and what does this mean, and how can I actually develop for both platforms? For example, Unity's AR Foundation is something we'll talk about. So lots of technologies, and just like me throwing out all of these examples, if you're not familiar with them yet, that just shows we have more work to do, and we'll learn about all these things in this MOOC. The sixth issue is really, let's say you have made it through the design and development. How do you actually assess whether you have now created a user experience that is actually good? I mean, there are common metrics around usability, such as learnability, memorability, and whether something feels efficient and effective to use. But how does that really concretely translate to an AR or VR interface? And so there are tools out there that allow you to collect data and produce analytics and then visualize it, for example, in the form of heat maps. So you get a sense of what are the objects that users are targeted at with their gaze, eye gaze or head gaze, depending on the technology that you're using, the XR device that you're using. But then if you have these heat maps, it's really unclear to me yet what are the right metrics to really assess. And that's something we'll talk about as well. So let's look at the first issue, the starting point, in a little bit more detail. So students often ask me whether they should learn Unity or Unreal, which one I prefer and which one I think is the best tool. I don't think this is the right question, though. First of all, these tools were actually not really designed to author AR and VR experiences. This is more like an afterthought. These are game engines, and they're increasingly add support. And frankly, it's quite sophisticated and comprehensive support. But when you open those tools for the first time, you'll be overwhelmed by all the language and terminology you have to learn. And you're making this jump into this complex tool and into 3D at the same time. So I'm not sure whether they are the right starting point. And I personally do a lot of my work in WebXR just because I really want to reach across all the platforms. I want to make it very easy and simple to prototype. And I'll show you examples of this throughout the MOOC. But it's not really the answer either. So starting point, I would say, is really taking a step back and thinking about whether you are a designer or you think you are a developer. And depending on how you answer this question, there are actually different things you care about, or you care about the same things differently. So as a designer, you really think about process, methods, authoring tools, design guidelines, usability evaluation techniques. And as a developer, it's almost the same, but a little bit more technical. So you think about development process, development toolkits, what are the right tools, programming tools, and programming languages. How do design guidelines translate to design patterns and design systems? And what does it actually mean architecturally speaking? So what's a good way of making my Unity or Unreal apps more performant? How can I improve rendering? So design patterns also in that sense. And then, while as a designer you think a lot about usability evaluation techniques, as a developer you think about all the things you can track and log to build good logs that you can then analyze. And so this is kind of like the yin and yang. In reality, these things have to come together, but depending on how you see yourself, you may be looking for different aspects, or as I said, for the same things, but with a slightly more technical or less technical perspective. And that's just something to realize as you're entering and trying to navigate that XR space. So here's my way of thinking about how to become an XR creator in that space. So if you have a web development background, there is a direct way which is based on the WebXR standard. And then I'll show a few examples that support that standard. So if you're really heavy on JavaScript side, you could do it with Three.js. If you like declarative HTML, you might go for A-frame. And if you want to have a quick start into AR, for example, marker-based AR, then AR.js may be a library that you want to pick up, and you will quickly achieve some initial results and feel good about it. As a game developer, so let's say you have a previous background in game development and maybe you even understand 3D design and 3D modeling, then you will really already be familiar with Unity and maybe Unreal, and you may really like one or the other tool more. And then the good thing is that most XR platforms and devices are actually supported in Unity and Unreal. Often through the vendors, but then this is increasingly pushed and becomes really part of the Unity and the Unreal engines. So an example of this is AR Foundation, which is a part of Unity now, which allows you to develop against both Google's AR Core and Apple's AR Kit, so smartphone-based AR. I also like the examples of Steam VR, which really is cross-platform VR, so Oculus, Vive, and Windows Mixed Reality. And then on the Windows Mixed Reality side, I really also like Mixed Reality Toolkit by Microsoft, and actually some of my friends from Microsoft who are really working on this. And the Mixed Reality Toolkit really makes it very simple to develop VR and AR headset-based experiences, but they also increasingly provide support for some of the smartphone-based platforms. So if you're a game developer, you really have almost the best access to these tools and the easiest transfer in terms of your existing knowledge. If you have more of a mobile development background and maybe already experience with developing for Android natively or for iOS devices natively, look into AR Core and AR Kit and their SDKs, because you're already familiar with these development environments, and that might be the way for you to go about it. And if you're more of a mobile developer, I also think you will have an easier time developing directly against the Oculus and the Vive SDK. So I put them here as native SDK examples. So now that we've established some of these direct paths depending on your background, let's look at different ways of transitioning into some of the tools. So what I'll do here is I'll paint in a few additional paths, and then I'll also talk about whether I think something is easy or hard. So let's look at an example. So I said as a web developer, you'll probably have an easy time making it into WebXR, and then I would recommend using A-frame. If you're really good with JavaScript, maybe you can jump into Three.js and learn that. And if you want to have a very quick AR experience with markers, you can just use AR.js. So if you're more like a game developer and you're already familiar with Unity Unreal, you should be able to pick up SteamVR and MRTK and also AR Foundation, but for these you do require some programming experience with C# or C++, depending on whether we're talking Unity or Unreal. I would not necessarily recommend jumping directly into these native SDKs. I just think it's not a good choice unless you want to really directly program against the platforms. The one benefit that I see there is that when ARKit or AR Core comes out with new features, these will be initially only supported directly in the native SDKs, and they'll take a while before they're actually being picked up as part of AR Foundation, for example. So if you're more like a mobile developer, you probably already have significant experience with developing natively against Android or iOS, or maybe you're using some kind of cross-platform approach like Apache's Cordova and derivatives. It should be relatively easy for you to pick up AR Core and ARKit and develop on those platforms natively, or jump directly into the Oculus SDK and the Vive SDK and not do this via Unity and Unreal. However, I do think if you have the mobile app development experience, I think you are more on the advanced side as a programmer, and I would make this path actually, let's say, doable or possible. Maybe not easy, but it's definitely a valid path. You would probably spend the majority of your time still trying to figure out Unity and Unreal, and maybe you'll feel this slow you down before you actually get into using some of these SDKs down here, but it is a possibility and you should consider it. So these were the different paths to being or becoming an XR creator, and I really wanted to cover those. But I also talked about this significant issue, and you will face this if you're more of a novice to the XR space, which is making this jump from 2D to 3D. So if you have a web design or mobile development background, you'll be very familiar with 2D coordinate spaces, and you know that this element is a little bit down on the Y and a little bit to the right on the X, and you know how to do this. But now, if you're entering the 3D space, okay, we get it, right? So we have 3 dimensions, so we have X, Y, and Z, but the problem is a little bit of the origin and also scale. Like, what does it mean? We're moving from pixels to new units that in VR and AR usually translate to meters, and the origin of the coordinate system is really not clear. And then we are also bringing in the idea of texturing models and really making sure that the materials are right, and we have light. Without light, you see nothing in your 3D scene. So not only do you have to make that transition to a 3-dimensional space in terms of coordinate systems and also understanding origin and how that varies, because usually the 0, 0, 0 is where the user was at the start of the application. There is no absolute coordinate space like we have in screen space. So you have to make that transition, but then you also have to think about the 3D models and making sure that they come with the right scale and that they have the appropriate materials so that they look good, because you also need light. And light is probably something you've never really thought about when you were doing 2D design, but here light really matters, both the ambient light and the directional light, and really placing that light has significant impact on the kinds of elements that we actually see in this scene. So this is quite a jump, and we'll spend more time making that jump together. So I also talked about good examples and finding good examples. And in my research, I really looked at what are good examples, especially when it comes to learning about AR. So you'll find some examples out there. Many of them are shared by the community. The problem that I see there is that these are usually examples that are crafted for a very specific problem that they had to solve. And so if that is not the problem you're trying to solve, it's hard for you as a novice developer to really extrapolate from that example and then apply it to your own problem. So if you find something more generic out there, so applies to more problems, you have this additional challenge that usually it feels quite abstract and maybe almost too complex. And so it's hard for you, even from this more general example, to tailor it to your specific use case. So it's really a lose-lose scenario. And so what would be a better example? Maybe somewhere in the middle, between the minimal that is too simple and the complete that is not too complex. So we are really aiming for something here. We're looking, this is like the sweet spot. Obviously, Something very specific has its advantages. Something very generic works probably well for experienced developers. Something minimal works well if it's actually the right use case, or it's like really modular and you can assemble your solution from many small examples. So I think that's also good. And then something complete but not too complex is usually also a really good example to learn from. But as a creator of an example, it's really hard for you to find that sweet spot because, as I said, for the more experienced developers, they're looking for something like this because it'll help them more. And for the less experienced designers and developers, it's probably better to have these smaller portions. But then they struggle with making that extrapolation and imagining from this little isolated toy example to really imagine concrete applications and how it might solve their problems. So it's really an interesting issue. And we'll get back to that in the course focused more on development. So I said there are too many tools out there, and in fact I've written about these troubles with current AR and VR tools, and I've classified them into 5 classes. And what you see here is I'm drawing them along the level of fidelity that you can produce with these classes of tools and the skill and resources that are required. And obviously there are tools that are relatively easy to use, but you also can't do too much with them. And then we have an increase in terms of both the complexity or fidelity at least of examples that you can create. But then you also do need more skills and resources, so that is actually makes it harder for you to access those. I put the class 4, which is really about 3D modeling tools here, just I wanted to have them in this landscape. But I think, first of all, they do require a very different set of skills and resources, and they're really not easy to use. If you're more like a web designer or a web developer background, then you really have a hard time operating these tools. And then there are the tools that I talked about, A-Frame, Unity, and Unreal. And I would say they are up there because you can actually really achieve good fidelity in these tools, but you also do need quite a number of skills, and you need time to build those skills, and time is money. So there's also a set of immersive authoring tools out there, for example, Tilt Brush and Google Blocks, that I would put down here. So they're relatively high fidelity because you're working directly in VR with these examples. And the skills and resources required relative to the other things I talked about are probably not as much. But I would say this is very generous of me to say that we can actually reach that level of fidelity here. It's a little bit stretching it. Obviously, in my research, I really want to be here. I want to be able to create the highest fidelity of solutions with the least skills required. So that would really be cool. And yes, I have worked on some of these tools here and I share some of them with you throughout the MOOC, but it's not always clear whether I've actually really reached that goal of being in that quadrant. Probably some of the tools are still a little bit limited in terms of the fidelity that I can reach, but I do think that I succeeded at really limiting the skills and the resources required. But the trade-off is that you cannot prototype all kinds of experiences. So the problem with all of these tools is that they only allow you to do so and so much. Some of the tools might be overkill for smaller projects where you could just use ARJS to do something here, for example. And that's just like building this awareness of this landscape and being able to do this classification and then picking tools within all these different kinds of quadrants, I think is really a key skill that we need to develop as part of this course. So in summary, the trouble with existing XR tools that I see is this massive tool landscape. It's hard to get started for new designers. It's even hard to keep track for experienced developers. Then the problem is that the design processes are really unique patchworks. Every kind of project that I've done required a very specific set of tools. There was not a lot of commonality between projects. So every AR/VR app requires a unique tool chain. Prototyping tools are too limited for most apps, that's what I've found, and then development tools are out of reach for novice, non-technical designers. There is this significant gap both within and between the tools. So the tool chain is really optimized in the upwards direction, as I was just illustrating in the previous graph. So It makes it really hard to design iterations, especially when you have to go back to a previous tool. So let's imagine you prototype something quickly in an immersive authoring tool for AR and for VR, and then you've taken it further in Unity or in Unreal. That's an okay thing to do. But if you then feel like, oh, you want to address some customer feedback, you have to really go back to the immersive prototype, and there is no easy transition between some of these tools. In reality, though, I think we will be able to work around a lot of these issues just over time. We will get more experience by doing more XR projects, develop a flavor and a sense for what's the right kind of tool and when to use which tool. And I really now feel like in my own work and what I see with my students, and that makes me very happy, is that they're really building this toolbox. And they're not trying to do everything with this one tool that I've learned, but they're really quite creative and exploring different kinds of tools throughout every project. And that's also something I'll invite you to do. And you will see more opportunities for this in later parts of this course and also in the other courses. And finally, I talked about this issue of platform fragmentation before, but let me illustrate this slightly differently. So when you're doing VR or AR, you really think in terms of low end to high end. So phone-based VR I would put on the lower end because, and actually that more or less has died. Daydream and Cardboard and even Oculus Go, the 3DOF, the 3 degrees of freedom head-mounted displays, that's something that's been discontinued in favor of 6 degrees of freedom head-mounted displays. And what I haven't even drawn out here is like this idea of building these kinds of big caves, these virtual reality rooms. That usually is not really a target of an app. So if you're building a new VR app, you really want to think about, okay, what are the requirements? And it used to be thinking about 3DOF versus 6DOF, how many controllers, do they even have a controller? Cardboard, for example, doesn't have a controller. And so addressing these issues between these platforms was and is still an issue. Now, it seems to be the trend that phone-based and 3DOF will go away, and 6DOF, so the more advanced headsets, they will remain. And this solves part of the issue, at least on the VR side. So when it comes to AR, and on the lower end of AR, I see smartphone-based AR, so not the headsets. And when it comes to smartphone-based AR, the question is really, should we require the user to use any kind of marker? And could we package this nicely with the app? For example, I've seen cool brochures or business cards that function as markers. And then it actually seems like a cool user experience. You could also design them quite differently and actually place them nicely in the environment. But I think there's this trend towards markerless AR just because we have the more sophisticated smartphones and it will become a standard in the next few years. And so when we look at the more higher end of the spectrum, so we're thinking about headsets, so AR headsets, for example, like the HoloLens, which I've shown you in earlier segments of the course. And, you know, that is really something that we will probably design more for in the future. I think ultimately this is where most of the AR takes place. But right now, when you're creating a new AR app, you really have to decide whether you're going to support smartphone-based AR and then marker-based or markerless, or whether you're targeting the headsets, and these headsets are still quite expensive, so you actually really don't reach too many users, but you can do the really cool examples. And so this platform fragmentation really is an issue at the moment, and it's quite difficult to navigate around it. And the course that is more focused on development will really expand on all these issues and cover them in more detail. So now I've talked through all the key barriers and I've provided quite a few examples and maybe new ways for you to think about it. I wanted to end with a few concrete tips. So here's my advice for you to get started. First, get your hands dirty. The dirtier the better, I say here. So really get your hands on an XR device. It doesn't have to be the most expensive. It could also be repurposing your smartphone as an AR or VR device with some of the smartphone wrappers like Cardboard, or if you still have access to Google Daydream or something close to it like Samsung Gear VR. So you could try out those things. And it's really important, even if they're used and old, it's really important for you to experience it for yourself. And then associated with this, you should also try out some of the apps, and then really think about tools as you're trying to enter this space of creating XR experiences. then you should really start making your first XR app. You should set yourself a small, reachable goal though. It's okay if you want to do a to-do or some kind of reminder app, or in AR, some kind of measurement app. Although we have 1,000 of those apps out there, I do think that it's a good way for us to get started. And the Measure app, for example, is a good way for you to learn about AR and some of the principles there. And so it's important to really do your own first app, not just do tutorials or read blog articles. Really make something. I think that's the best way to get started. But remember, set yourself a small goal. Third, when you're there and you feel like, wow, I'm really getting passionate about AR and VR, then really think about how do you connect to other developers? Learn about the XR communities out there. That's really where a lot of the know-how is. So start following AR, VR blogs. I usually follow a lot of people on Twitter. That's, for me, it's a good way to learn about what's currently being done. All the vendors and associated with those vendors are actually people working at those vendors. And many of them are actually really quite open about what they're working on. And so social media could be a very good way for you to keep up to date as well. And then number 4 would be start reading more about XR research and design. So when I say start reading about it, there's a lot of practitioners sharing their knowledge and experience again in blogs. There are people out there that write more like white papers, doing some kind of market analysis that might be helpful for you when you want to figure out what kinds of platforms you want to target. But I really like the articles created by practitioners. There's a lot of good blog articles out there, which I also share with you throughout the course. And then if you're inclined to reading more academic papers, now the scientific community is not always the most accessible, but I personally obviously get a lot out of the latest, the cutting edge, the bleeding edge research. So I really learn a lot from academic papers. So this is my how to get started. Get your hands dirty. Make your first XR app, make sure it's your own thing, join XR communities, and then start reading about some of the XR research and design. Yes, so this was my how to get started. And it's obviously just one way to get started, but in my experience, this works very well. I've worked with many students over the years, and there is a little bit of truth in some of the things I said. So maybe try it out for yourself and really continue working in this course and learning that way, because I think we'll have a very good way for you to get started and then take it further in your own time after this if you turn out to be an XR creator. When I say XR design, so I really think of 3 big things we need to touch on. We need to talk about the design process, the methods and tools, and then also guidelines and evaluation. And this is how I've structured the course. So design process is really the steps that are important to make it through a project and then come up with a good design. Along the way, I'm going to introduce you to a variety of methods and tools. We're going to build a toolbox. And so the idea is that you have access to a number of techniques and can choose the ones that you are most comfortable with or that you think best fit the project, or based on my experience are very good in early stages of design, and then they kind of fade out and transition out. And then we have access to other techniques targeted at digital prototyping and then later development as well. So we learn about these techniques and we build our toolbox. And then we also learn about design guidelines and best practices and design patterns. And so we're building this understanding of what is good and what is maybe not so good in XR design. But although I must say that this is still evolving and we are still learning a lot along the way as well. So well, I think that the fundamental aspects are covered in this course. I might already be working on some new techniques in my research, and then I hope to share them with you as well as we go. So let's talk about process for a second. When I say design process, really we're going to start from a problem statement, usually, a competitive analysis, and design space analysis. So these are really the key things that help us frame the problem, really understand it better, and then understand the competition. So therefore, basically the state of the art, so what's been done and how well is it done, what are the factors that contribute to good solutions and what are the gaps there, and really trying to find a way into providing a meaningful solution to the problem. So both understanding the problem, but and also really identifying gaps and finding ways of filling those gaps. You will have a variety of options to consider. So we're going to talk about design space analysis, asking the right questions, weighing the options that you have, coming up with criteria that allow you to make good decisions. And so we're going to talk about that. And then we're going to enter the space of prototyping. And there I really emphasize the physical. So I feel like paper prototyping is really where I usually learn a lot and my students have a lot of fun, so maybe that is something that you'll also enjoy. I introduce you to techniques using paper, transparency, Play-Doh, and really making use of physical space, kind of like treating it like a stage to think through the XR experience way before we start developing anything and using any digital tools. We can really do a lot physically, including testing with users, and that I think is a very powerful set of techniques that I'll introduce you to there. And then we're going to talk about digital prototyping as well. So here I said we're going to do both digital and immersive. So digital on the desktop with some more traditional tools that you may be familiar with as a graphic or web or mobile designer. And there are some new versions of these tools available to us that are focused more on AR/VR design. And this is still a space that is rapidly evolving. Lots of issues with current tools as well. And then we're going to explore immersive prototyping, really this idea of jumping directly into the headset or using an AR mobile device and prototyping and experiencing it at the same time. So this idea of concurrent design and testing, which is really the definition of immersive prototyping. And so I think that's going to be fun. And so with all these prototypes, we're going to arrive at what is called the minimum viable product. Think of it as a proof of concept, like the minimum set of features put together in an early version of our, let's call it, product, and that allows us to learn and try it out with users and learn about initial user experiences and how we can improve it. And so this MVP, this proof of concept implementation of our XR experience, that is really what this whole course is targeted at. The course kind of ends at the end of this MVP, which this MVP could really function as a design specification that you can then hand off to developers, or if you're more technically inclined, could start implementing with current programming tools, and that's something we'll cover in a separate course. So this is the process-oriented way of looking at XR design. But if you think more about the concerns and what are the key questions, so here I'm going to give you an intro to XR design in a slightly different way. We're going to think about ways of building empathy with your users. So this is really at the core of design thinking. We're going to talk about ethical and responsible design. Now that's going to be quite a tough lecture to give and one that I'm never really happy with, but I really wanted to give you the right mindset to think about good design, but then also ethically responsible design. And we're going to talk about design guidelines, so best practices and patterns of design. That's something that I think is always evolving, but it's really something that as a designer, you really want to be aware of these design systems out there and really what are the right ways, what's the current state of the art when it comes to XR design. You want to be modern and you want to be consistent with other kinds of XR experiences that users may have tried. And then we're going to talk about design critiques. Now, design critiques, that's something that is heavily practiced in some disciplines like architecture and architectural designs. And I also do this in my design courses. It's really important to learn how to give good feedback and to, critically analyze a product and then make constructive suggestions for improvement. So we're going to practice this. We're going to do design critiques in two different ways. One that is more oriented towards the guidelines that I talked about, and then one that is really focused on ethics. Because I do think that when it comes to XR, we really need to take care of both of these big concerns. So making sure that the current design kind of fits with common design practice and is also really ethically responsible. And finally, I'm going to introduce you to something that I really like to do in my research and that I think is actually a very good way to bring together people that care about the same problem. We're going to talk about design jams. And the way I think about design jams is like a 3-hour block with a design prompt and guidance, and we're bringing together basically target users or stakeholders if you will, that really care about the problem, and we're going to try to solve it collaboratively. And so you can bring in, I often like to bring in students with varying level of experience in terms of like where they are in their degree, but also then a variety of different backgrounds. And so that's one of the things I really like working in the School of Information, because that's where we have access to this diverse pool of students. And then we're also going to talk about design ethics. And with design ethics, we really want to get away from this basic usability-driven question: what's the most effective and efficient design of my solution? And we want to think about what harm could it do? How could it be misused? So kind of like a little bit the dark side of design. And did I accidentally create a weapon? That is something that you should really be thinking about. So with the design options that we have available and the choices that we make, are they meaningful, and are they ethical, and are they responsible? So that's something that I want you to think about. So we're going to introduce you to key ways of thinking about it. This idea of, giving control to users, autonomy, transparency, making them feel in control, and really being aware of all the options that they have, and then safety. And I mean both the physical and the mental safety of our users. So that is something we have to consider. And design ethics is going to be a key topic. We're going to talk more about design guidelines. We're going to learn about those that are platform driven by vendors, and then those that are done by designers, and they are user oriented, so usually done in some kind of user studies, maybe not as thorough as some researchers might do it, but still a very good way to learn about design. I really like those coming from experience. So we've tried this, and maybe we didn't do it super rigorously, but we have made this effort and we have learned from it. So here are the lessons learned, experience-based by practitioners. And then obviously as a researcher, you kind of like want to do this with scientific rigor. And so there are different kinds of concerns. For example, the number of users that you involve in your studies is a bit different when it comes to research. When it comes to like more product-oriented or practitioner-oriented user studies, I think you can really work with just a few users and you will already find a lot of issues. As a researcher, however, you're interested in statistical power, and can we actually really learn, can we make meaningful conclusions from what we have observed? And so that's a little bit of a different approach. And then we're going to learn about design critiques. Design critiques, I'm going to introduce you to this method, which I really like. Also coming out of Stanford, it's the I like, I wish, what if method. And so in the I like is really this idea of starting with something positive. You're looking at a design and there must be something that you like. You just have to say it. And that's a good way of also building empathy with designers, which is very important. And then you can start not attacking, but critiquing, and do this constructively. So we're going to turn into this I wish something were different. And you need to be, constructive, and you need to be concrete. And the way I'd like you to think about it is you really want to make helpful suggestions. So what if you consider this, as opposed to placing this menu into the world? What if it were just on device? Oh, that's not cool. That's not how we do things in AR, VR. Okay, fine. But it might be more usable, or it might be easier for novice users. And so you're going to have interesting debates. And I think this idea of critiquing existing interfaces and learning from them, also helping your friend or your partner or your design team, I think is very good. So one thing that I like about being a professor, for example, is that I teach others. And while I teach others, I also actually learn a lot more about the things I actually don't know or don't understand so well. And as I try to explain them, and sometimes I have to look up things just like everyone else, and then as I explain them, I actually really learn more about it myself. And it's the same with design critiques, okay? So you can look at an existing design, and for me it's very easy to find issues in existing designs. And that's the first skill. But then the hard part is really to make constructive suggestions for improvement. And that's something we have to practice. And that's something that I usually do in my courses throughout. So like every week we're going to look at existing interfaces and critique them, and learn about like common practices of design and what's good and what's bad, and how users might find it. So this is a really important skill. We're also going to talk about evaluation. And so when it comes to evaluation, a lot of, at least researchers, immediately think about usability and somehow proving that our design is a good design and that users found it usable and they're still very efficient, it was an effective way of using it, that maybe they had satisfaction as they're using it and maybe even some fun. But I also wanted to think about usefulness. I can design this best to-do list in AR. It's the most usable, but is it useful? Do our users find it helpful? Do they see a purpose in it? Does it improve their daily lives? And I feel like for a lot of the XR experiences out there, this question of usefulness really raises the bar. And we don't need a million measure apps in AR, right? I mean, it's a cool little thing to implement if you're getting started with XR. So it might be that you want to try this for yourself. But I don't think we need a million solutions in that space, because the problem is really not that big. So in addition to usability and usefulness, we also want to really consider utility. Does our solution really solve the user's problems? And that is something that is really hard to assess. Often it has to do with long-term usage. And that brings me to the fourth aspect of evaluation, user acceptance. Will our users actually continue to use it? Or are they just using it for the purposes of our study, for example? In research, this is really one of the hardest questions to answer. When you have a product and it rolls out and people continue to use it, you might argue that users accept it. And that when they accept it, it's like the ultimate grail, because they may see great utility and usefulness in it, and it should probably also be usable. Now, there have been solutions in the history of interface design where people just didn't have a better option. So it was great utility, great usefulness, but just not really usable. So overall, we're going to cover a wide variety of methods and tools in this course. We're going to learn more about ways of need finding and brainstorming. So this is really in the design thinking category. We're going to learn about low fidelity and high fidelity prototyping, so rapid prototyping techniques and how to transition from the physical to the digital. And then we're going to do digital and immersive authoring and really learning all the methods and tools there, and really also understanding, like, between each of these main steps, what do we actually learn about our design as we go. Obviously, we are increasing the fidelity or the quality, if you will. And each of the methods that I introduce you to, they target different kind of feedback. And that's something we will also think about throughout. And then normally you would also go and develop with, let's call them programming tools, and that I introduce you to in a separate course. And we would also look at building techniques into the interfaces so that we can learn about how users use our interfaces. And so building a form of analytics and continuous kind of like user feedback. And that's something we also talk about, but that is not in the scope of this course. It's just like important to keep that in mind, and will be the subject of the third course in this XR MOOC series. So I just said low fidelity and high fidelity prototyping, and we're really going to learn about a variety of methods. We're going to start with storyboarding and wireframing. We're going to go and enter the physical prototyping space. Really, this is where I usually have a lot of fun, as I said. So we're going to use paper, transparency, cardboard, Play-Doh. And in fact, you're going to use these materials to think through an XR experience without implementing it. And then we're going to take those things and we're going to iterate over and over again. And then we're also changing the medium and going digital. And I think there's a lot of value in taking the designs further this way. And while I often, as a researcher, feel like, hey, there must be a cool way to quickly transition from physical to digital, and in fact, I've worked on this in some of my research, I do think there's also a lot of value in taking a design that we have created physically and then re-implementing it and improving as we go with digital tools. And we're going to also talk about immersive prototyping. I just wanted to say that again because I'm very excited about that. And the idea of this course is really to emphasize prototyping and tell you more about how significant this is. So don't just jump into the programming tools out there. I know that's also very important, and I know everybody wants to be good with Unity and Unreal or WebXR. And I'll really also talk about those platforms, but I've dedicated the third course to that. This course is really a rapid way of thinking through XR experience. And if you do this the right way, you may actually save a lot of time and be much more efficient when it comes to working digitally and programming. So what is the significance of prototyping? Well, I think first of all, it allows you to avoid premature commitment. A lot of us really like AR or VR, and often it's like one or the other, although I'm relatively agnostic. Maybe you have a preference for VR because that's the first thing you saw and you think it's so much cooler. And now you're looking at VR as a hammer and you're trying to find all the nails that you can hit with it. And we want to avoid that, because we really want to look at VR and to critically understand whether it actually is a solution to our problem. And in fact, there are many problems out there where neither AR or VR is actually a solution. And so we want to avoid that, and we can figure that out without having to implement everything. We can just prototype it with physical means, as I said, and then we can come to that conclusion much faster and cheaper. Prototyping also tells you a lot more about the context, so figuring out the environment in which an experience takes place and how much you have to design it for VR and how you could change it in AR. And the story, really, what's the story? What's a good way to communicate that story? How do users understand how they can operate the interface without you telling them every step along the way? What's good environmental design? What are user needs, and what are the required skills and abilities of our users? And all these things you will actually find out more or less implicitly by prototyping things and trying them out with users. And then prototyping also gives a lot of answers. So along the way, you'll find out about interactions and input modalities and what kinds of sensing requirements you will have in terms of, like, do we need hand tracking, for example, or eye tracking, or can we go without it? Display requirements, so should we think about something mounted on the user's head, or is it fine if it's handheld? Or should it be placed somewhere else in the environment as a large display? We're going to actually create a lot of assets along the way, so that's why I really like the physical and the digital prototyping, because you're producing a lot of knowledge, and in addition to that knowledge, also initial assets. And in fact, I've really seen some really cool prototypes where we were kind of like holding onto these paper sketches and basically creating VR experiences around paper assets. So one of my favorite examples here is the Star Trek that I'll show you later, that I've created with one of my students, Katie, and she's a really good designer, and she can really sketch very well. And so we actually produced an entire VR or AR experience just using paper and a specific template. So creating a lot of assets there. And then finally, again, the prototypes allow us to ask about the user needs and then also what are the skills, and the prototypes then also give us answers to these questions. So that's why I think prototyping is very, very important, cannot emphasize it enough, and that is really one of the key messages of this course, and hopefully something that you'll take away with you and incorporate into your own practice. So I really look forward to this course and introducing to all these kinds of things. I hope I haven't missed anything. You know, I've been thinking a lot about what are the key things that I need to convey and how much time do I have. And I've been playing around with topics and things I want to, you know, incorporate. And so if you feel like something is missing or something I should have talked more about, I'm always also happy to hear your feedback on that. And I could imagine future versions of this course as well. So thanks for taking the course, and I really hope that you'll learn a lot and that you actually also have some fun. So I'll see you in later segments of this course. So we've covered a lot of the do's and don'ts based on my experience, and that experience is coming from doing a lot of research in that space and then also teaching a lot of students about XR design and obviously operating a lot of AR, VR applications myself. But while I strongly believe that these are good guidelines, it's just a starting point. It's just based on my experience, and maybe there are people out there that disagree. But overall, as a starting point, I think you can apply those guidelines, look at your designs, and then look at these guidelines as a checklist and see how many do's you have done and how many don'ts you have done, and then think about ways of avoiding the don'ts, which I think might be a good way to improve design. So still thinking about design guidelines, I wanted to look at an example, and I chose a recent experience that I had when I was attending the IEEE Virtual Reality Conference in 2020.
which was supposed to happen in Atlanta, but due to COVID-19 had to move to remote and online. And we're going to look at some of their spaces that they have created, some of the virtual environments that they have created. And I have invited my student here, Shweta, who is going to join me in some of these discussions and explorations as well. And a couple of the things we're going to do is we're going to climb some stairs, which I think leads to interesting issues. We're going to explore the world, going for a walk together, and then you will also see me picking avatars and looking at a lot of text. And then we're going to review some of the design decisions, and I'm going to compile a few more tips and maybe guidelines, if you will, to also avoid those things in the future. So here I'm looking down the venue. This is the stage that they have, and I'm waiting for my student Shweta. There she is, and I see her, and I can see how she is essentially trying to make her way up. So they have designed this stage so that you start in the back where you have a little bit of privacy. In some sense, you don't hear the speakers and can have a chat, and then others won't hear you in that area if they're up here on that stage. So that's good, but you then actually have to climb those stairs, and these stairs are really not accessible no matter whether using a keyboard and mouse like I do here in this example, or a VR headset, which I'll do in some of the other examples in the future. So stairs really is an interesting issue to me, and something we should think about more and potentially avoid as much as possible. And so then I was thinking, okay, let's explore a little bit more of this venue. And I decided, we were attending this conference for a while, and then I said to Shweta, hey, why don't we go for a walk and explore some of their bigger virtual spaces. And so we ended up on this Georgia Tech campus. Now, I haven't actually been to the Georgia Tech campus, so I don't know how much it really resembles reality. But I could imagine that unless they had a major investment, it probably doesn't look like this. So in many ways, they reinvented reality here and that makes sense. I mean, I guess. I mean, the big B and some of these virtual screens floating around. So it's an interesting mix of, like, this is a selfie from Blair, one of the organizers, and a friend who I hope doesn't mind that I'll critique and review this a little bit to look at our guidelines and which of these can apply. And then we were going for a walk, and there were some issues. Again, it's a ramp here, it's not stairs, but I could teleport with my mouse pretty easily, and then Shweta was using a MacBook and didn't have right click, so she couldn't actually navigate that space with mouse and teleport, so I had to walk all the way. And for a novice user, Shweta is not a novice user, but for somebody who explores such a world and VR for their first time, figuring out how to move in a space when it's unclear and that you have this option potentially of teleporting if it's available, that is actually really quite an important step. And obviously, the more experience you have in these spaces, the more of that experience translates between spaces and experiences, and so maybe it won't be so much of an issue later. But onboarding is really quite difficult still. And then this is really, it's an interesting example, because I really don't get a good sense of what the Georgia Tech campus looks like. Apart from a few billboards and text here. And now that text is okay. The way it's placed is actually quite well done. It's on a billboard, it has sufficient contrast, it's not just floating. I'll have another example later that I think is pretty bad. Then we were walking around a little bit more, exploring some of the other spaces, ending up at a campfire, which was really quite an interesting atmosphere. The way you navigate those spaces was interesting. So one of these tiles was actually a portal into a different world. So there's a little bit of inconsistency here in terms of the content that you see on the walls. So some of it is actually video, some of it is text, and some of this can be played, I guess, or not. So it's really quite a lot of stuff going on. And then, as I said, one of those tiles actually functions as a portal into different spaces. So I do like that they illustrate a lot of the content here. and some of the hard work that really went behind creating this experience and this online conference essentially. So why did I pick this example? Because I think it really allows us to review some of the guidelines, this idea of not really copy-pasting reality, offering alternative ways of navigating, making use of established interface metaphors, and limiting the amount of explicit interaction. And I was really stuck on the stairs example and the platform that I was talking about, just because while it was good in terms of physical affordances, I understood that I can get to a different part of this virtual world and I can navigate up and down or further away. It really reintroduced all these known accessibility issues from the physical world, and that's just like a big problem in an experience like this. So when you go to a conference like this, you really want to learn what kinds of things are actually available, what sessions are on. And also here they kind of replicated the real world, which usually you have some kind of handout or some kind of boards. And somebody from the community created this room, essentially putting these program information sheets into the virtual world here. But it's really a lot of text and hard to navigate, to the extent that I'm like almost bumping into it. And it really wasn't that helpful after all. The main purpose was not to have to leave the virtual reality experience. It was a quick fix because a lot of people felt like, oh, I always have to jump back to the virtual reality website, and but I just want this information in VR. So transitioning in and out of VR is still an issue, and it's very disruptive to the user experience. So I get it. But the way we deal with text here is not ideal. So why do I say this? I want to show you two examples. One is in VR and one is in AR. And we're going to talk about the format and the layout of the text. And I'm just using some standard text with as little format and layout as possible. And then I'll show you the different experiences in VR and AR. So my first example is lorem ipsum larem placeholder text in VR, and I just really placed it into the scene, and you can see it in stereoscopic view here, and it's really hard for me to actually view it at any one time. And then this idea of using your hands and fingers as reading aid only partially works with this really big VR controller here. Now that may improve a little bit with hand tracking, but it's still kind of an issue. So here I'm showing you an augmented reality example where I inserted the same text in the studio, and there happens to be this light source that I obviously need to lit the scene and make sure that you can see me on camera. But and this could be just the sun in the real world. It really introduces a lot of issues with reading this text and just seeing it. So really you need to pay attention to the environment, both the virtual and the physical. The distance of the text is kind of okay. I put it at 1 meter away. It shouldn't be further away than 2 meters, is what people say. The scale is still a little big for my taste, but if I scale it down, it really introduces new issues. So text in general, there is no really good solution. It would need to be adaptive, I guess, and know a lot about the user and maybe their prescription and all kinds of things. So just try to avoid it. And again, reading aids here, like using my finger. My finger appears behind the screen just because we don't actually, in this example, have finger-based or a hand occlusion and figure-based occlusion. Now we're getting there and improving some of this, but it's not available on all platforms. And even then, I don't think this part of improving the technology would actually solve the issue. So my last example is avatars. So let's think about the design space that we have in terms of avatars. I showed two examples here. One is with permission from my friend Jeremy Nelson, who appears in his kind of like reconstructed avatar. All he did was upload a photo to Spatial, a meeting kind of software. So that's what you see on the right. And then on the left, you see some of the avatars that are used, for example, in Mozilla hubs, and those are the ones that I chose from when I was actually going to the IEEE VR conference. So when you compare those types of avatars, you definitely see that the ones on the left are more abstract but appear to be more consistent, and the one on the right are more realistic. But there were some issues with the scale and the position of Jeremy. So he appeared in my desk, for example, and I always looked down on him, which normally isn't the case. We are almost the same height, so it was a little disturbing and confusing. Now these things will probably be improved in the future, but sometimes the more abstract avatars are actually just good enough, and we don't necessarily need to recreate the whole reality just because we have all these tracking issues, which are then even worse. The closer you are into reality, the higher your expectations are, and the more disruptive the user experience is if something goes wrong. You know, if this little avatar on the left doesn't move properly, that's weird, but it's okay. But if Jeremy's arms or legs bend in a weird way, you don't want to imagine that. So here I'm going to show an example of where I chose my avatar and I wasn't happy initially. I was going to this conference. It was a little funny because I did spend quite some time on my outfit and choosing. There was one particular character I was looking for. It was kind of like this Iron Man looking metal guy, and I think I found him on the last page, but this was probably the closest. Or it wasn't available. That was also disappointing, that an avatar that I used to use was not available in this specific experience, and so it really, in terms of consistency, was a little disruptive. So these were some of the examples that I put together for you to illustrate some of the guidelines. I didn't have an example for each and every guideline, but take a look at them, explore them in a little bit more detail, and again, as I said, use them as a checklist to understand and identify opportunities for improvement to your XR designs. And again, treat them as a starting point. Maybe you disagree, that's fine. Maybe you have a particular example where this guideline doesn't really apply, so the rule doesn't apply. But I think it's important that we have some kind of guidelines. These are the ones that formed in my head over a few years of working with novice designers, particularly students, and then also based on my own experience, like going to this IEEE VR conference. And I don't want to be too negative. Obviously, it was a cool experience. But as a designer, when you look at some of the artifacts created that way, like the virtual environments that we looked at, and really they didn't have a lot of time. They had to put this together very quickly, and I assume little user testing, and then working with this new medium in VR for conferences is still pretty new. So all that is obviously clear, so I'm not attacking them in that way. It's just a great example to study how much do you want to push the realism and this trade-off between making it like a reality and then all the issues that come with it when you don't actually live up to that expectation, when you actually break the illusions, be it through your design and some shortcomings of it, or maybe issues with the technology like limited tracking or other kinds of issues. So I'm going to leave this video a little bit more open-ended, just because I do think that these guidelines still need to evolve, and at least now we have a way to think about guidelines and how to assess the source of guidelines and when they apply and don't apply. So I'm going to leave you there and think about the stairs, which still I think it is fascinating to me. And if you get to this stage where you start obsessing about some of these design decisions and why things are there, so questioning some of the design decisions, then I think it shows that you're starting to think critically about design, and that is a really good thing, and it would make me proud if that's what I have accomplished today with this lecture. Finding your XR process. Really, how do you create these XR experiences, Michael? I get this question a lot. So I want to walk you through some potential processes and actually the methods that I really believe in as part of this segment. Okay, so if you think about interaction design traditionally,
As a process, it is really starting from requirements, which is essentially need finding, understanding what users want. From that, creating alternative designs. You need something to experiment with, and then you actually again work with users to understand which of these designs play out. You create interactive prototypes that can be tested. They can actually still be in paper. They don't have to be implemented in technology yet, or you create these interactive prototypes with digital tools. You can do that as well. And then you do a more thorough evaluation, potentially finding new requirements, and this whole thing becomes a cycle. Now, you've probably heard of this as a traditional interaction design process. Okay, going a little bit deeper on the interaction design process, we usually talk about 4 steps: framing the problem, exploring the solution space, finding a good solution, and refining the solution. And then as we're going through this process, we actually need to diverge initially, consider lots of alternative options, and then converge. So first we generate options and choices, and then we actually make choices. A final part we often teach about the traditional interaction design process is that it's iterative in nature. Once you've gone through one of these cycles, you may iterate and improve the product. Now, I will argue that in this traditional interaction design process, there is a lot of value that we can actually translate to XR. So now let's translate what we've learned about the interaction design process to the XR process. I think of 4 big steps in this process. Need finding and brainstorming, where you're essentially framing the problem via scenarios and use cases, personas and competitors. And if you don't know what those mean, I'll actually expand on those in later segments. Storyboarding and prototyping, which is a significant second step, requires several iterations creating mockups using paper and digital tools, and then even involving XR devices. The third step is development and testing. This is where you're creating the application using either WebXR, Unity, or Unreal, or some kind of native SDK, building on mobile development platforms or specific VR or AR toolkits and platforms. I'll expand on those in other segments as well. And then finally, deployment and analytics. I think so once the application has been developed and is deployed with users, we need to continue to evaluate how well it's doing. So deploying the application on an XR device is the first step, but then collecting data during usage and analyzing how well the XR application is doing and what could be improved, so identifying opportunities for improvement based on how users interact with the application. That's the goal of the 4th step. And this is really the whole thing, is really the life cycle of an XR application. So now I want to expand a little bit more on prototyping. When I think of prototyping, really, I think of storyboarding, where I create storyboards and sketches to frame the problem and develop the story that I want my users to experience. I think of physical prototyping, so where we may use Play-Doh, paper, cardboard, transparency, anything beyond paper, essentially, to become spatial and explore the opportunities of XR interactions. So these physical prototypes is really something that I believe strongly in. I'll spend some time on it. They allow us to design the concept and explore the interactions before we implement them in any digital tools. Now, obviously, prototyping then finally also includes digital prototyping and with digital tools to test the feasibility and experiment with XR specific features, things that we can only really explore once we have it on the devices. Now, I think all these steps are really important, and we're going to explore them in more depth in future segments. So now a term that I've used previously is fidelity, and I want to explain what I mean by low fidelity and by high fidelity. So when I create a new XR experience, I usually start on paper. I like sketching out things on paper, thinking it through, and there are some templates out there. One of the issues that I have with working on paper is that I'm not very good at working in 3D on paper. Most XR experiences, actually all of them, are 3D, and so it really requires this step. So what I like to do instead, I still stay in physical prototyping world, and I create a diorama. A diorama is really, the way I think about it, is like a miniature kind of prototype of my stage. I can become physical. I use things like Play-Doh and cardboard and transparency to really put together the XR experience and then explore it physically. Now, the fastest way to jump from physical prototyping to digital prototyping, especially for VR, is essentially 360. So
This is a 360 camera that has 2 lenses, and with one click I essentially take a 360 photo. If I use a video recording, I can even move in space. Otherwise, I'm like anchored at this location. This is also one of the main limitations of 360, is that it actually doesn't have depth. So if you now want to create, if you want to transition forward in your experience, increase the fidelity, the next step from here onward is actually going into 3D. For 3D, just making the jump from 360 to 3D, there are lots of tools out there, and I'll introduce you to some of them. But the harder jump is actually into VR and AR. And the way I've positioned VR and AR here is as if the fidelity of AR is higher than VR. What I wanted to express is that I think creating a high fidelity AR experience is actually quite hard. And so I want to explore this along this graph quickly. Okay, we're talking now about the fidelities that I've just talked about, and then we're also talking about the skills required to actually create those experiences at those fidelities. So paper is really on the low end. The diorama, the physical prototype, a little bit higher, just requires a little bit more time. The jump from diorama to 360 is relatively easy. In fact, we could take a 360 inside our physical model and then work from there digitally. From 360 to 3D, there's really not a lot of good tool support out there. It really requires us to build a scene in 3D. And in fact, the jump from physical to 3D, or even from 360 to 3D, is where most of my students actually spend a lot of time on. We really need to explore how to do 3D. And even in these courses here, we really spend a lot more time on thinking through 3D. Once we are in 3D, the jump to VR is still quite a jump, but it's doable. And then to AR, we really need quite a lot of skills. The problems and the differences between VR and AR: in VR, we can control the entire environment and we need to design it. Now that actually requires a little bit of skill, but it's arguably technically even harder to really work in AR, where we need to sense the environment around us and then have our experience fit in nicely. And so this is why I have plotted it out this way. And I think really it's a good overview of the steps in the process, the fidelity you want to achieve, and then the skills you may require for each of the steps. From this placeholder content, I often bring in 3D models. Here is an example of a nicely looking 3D cube. Still relatively easy to model this, but it has at least a nice color shade. And this is an example of more polished content. So I'll start replacing the primitives that I've used before as placeholders and bringing the 3D models that I really want. What I have at that stage is really just the content. And now I need to think about the interactions. So when we think about interactions, we need to distinguish between implicit and explicit interactions. I'll give you an example of something that starts out implicit and then becomes an explicit interaction. So when we use something like Google Cardboard, where we can look around and actually target content and then potentially click it with a button that we have on top of the device, we usually indicate where the user is looking with a cursor. So let's assume here's our cursor, and now the user is targeting this cube. So they move over, they press the button, it performs a click, and we adjust the 3D model and we've registered the click. Now this was a combination of an implicit interaction that actually became, so me targeting the object, and then actually became an explicit interaction as I clicked. So we need to handle both. And this is really a very simple example with just using cardboard, but these are the kinds of things you really need to think about when it comes to increasing the fidelity and then adding interactions to your scene as well. Okay, now what I've done is talk about media, the different kinds of skills involved, and then also have given you examples what this means in terms of how the content evolves and the interaction. The last thing I want to do is actually putting it in a timeline. Here I'm going to give you an example of the XR process, how I often implement it in my classes. So we usually start out with a design concept where we really determine the problem frame and think about whether something is AR or VR. From there, we create a first prototype, usually still quite low fidelity with potentially basic interactions. And really what we need to figure out here is the platforms and the tools that we use for our prototype. This is just a V1, so then we get maybe some initial feedback from users or the instructor in my case, and we work on a second version. Really, what I often do is I scope it down to 2 to 3 key interactions. I think it helps a lot to think about an XR experience in terms of the interactions that we want to support. And what is also interesting, you may have to switch some of the tools sometimes, because if you have to work on a more tricky interaction, it'll dictate which tools you need to use. So after these 1 or 2, maybe even 3 versions of our initial prototypes, we may create something that we can at this stage call a minimum viable product, or MVP, which we can use to run some initial user tests, get some feedback. And from that, what we've done from an initial design concept that we've prototyped out, maybe first on paper, then created a few digital versions, finally tested it with users, what we have now is actually a design specification, potentially in the form of a report, where we can reflect on some of the lessons that we've learned, and we can use this design spec and actually give it to developers to implement it further. Or if we realize we actually have to do a lot of improvements, this was just one design sprint, so we could do another design sprint. So when I think of design sprints, I usually think of 1 week or 2 weeks of work following this process. And iterating through this process multiple times will eventually give you a really cool XR experience. So in the following segments of this course, we actually focus more on prototyping and then development and testing. So development and testing, really what are the 3 big options you have here? If you remember from previously, well, it's the web-based route through WebXR. It is the kind of like game dev route if you want through Unity and Unreal, or you do the hardcore development route. Maybe if you're an experienced mobile developer, that's your thing. You can do native development with the Oculus SDK or the Vive SDK, or also some of the AR solutions out there. So in the following, we'll spend more of our time on WebXR and Unity, and that's it for this course, but I'll provide resources so that you can also learn more about the alternatives. And finally, once we have created our XR experience, we can deploy it with users, and we should really think about analytics. That's what I've thought about. At this stage, I keep it very high level just for us to think through what are the 3 main ways we can do this. Well, 1, we could actually implement custom logging and perform a little bit of log analysis. This is something that a lot of researchers do and is actually practiced by a lot of people, even just for user experience testing and usability testing. You may wonder whether there are some tools out there. Yes, so some of them are built into some of the tools we were using. So for example, Unity has analytics built in. These are platform-based analytics tools that are actually focused more on like how many people are downloading your app and what are they doing with it roughly. They may be too limited to really understand where the issues are with the interactions. For that, there is a new range of more dedicated XR analytics tools, those that would allow you to analyze how users interact when interactions fail. So when, for example, people wanted to interact with content that wasn't really there, when it caused frustration potentially, when users appeared confused. This is, however, an area of active research and only a few tools out there that are still evolving. So I'll provide a few pointers and links for you, but we won't spend too much time on these things as part of the course here. In this video, we're going to talk about XR design thinking. Now, design thinking is actually quite an established method that has been around for many years, coming out of the Stanford Design School, and it's often applied to innovative product development and making user experiences, if you will. But it's really about a mindset. Building empathy with the users, really focusing on the user, and then everything else will follow. That is really the idea. It's more of a, let's say, more of an approach and a way of thinking than its own kind of method or a set of techniques. It actually is associated with common interaction design and user experience design techniques. At least that's the way I think about it. Now, what I want to accomplish here, though, is that we are porting that knowledge from design thinking and applying it to XR. There's a couple of things that are quite different. For example, when it comes to innovation and problem framing. Because XR is really like this technology that could potentially solve a lot of problems,
but it's more like we are throwing the technology at everything. It's like our hammer, as I said previously, our hammer, and now you're trying to find all the nails that you can hit with it. And sometimes you'll be successful, and sometimes you're not. And so design thinking is actually is a specific way of framing a problem by really building empathy with your users. Now, your users will not feel like, oh, I need AR, or no, oh, I need VR. No, AR or VR might be the method or the tool, if not the technology, to potentially solve the problem. Now, I want to be very careful because technology in itself doesn't actually solve any problems, but it might actually be an enabler. And that's how I want us to think about that. So here I'll give you an overview of the design thinking method. In the first step, you'll empathize. You empathize with your users. You're trying everything to find out about their problems, what are their pain points, what is currently working for them, what is currently not working for them. You're getting to learn the context and the setting in which current solutions are applied to really identify shortcomings and gaps and therefore opportunities. And this will help you define the problem. Really, the first few steps, the first 3 steps to be precise, are really about problem framing. They're not so much about solution finding. You're actually trying to understand the problem, not just the symptoms of the problem, but actually the problem. And so there are common techniques there in terms of interviewing and observing and doing focus groups. And there are all kinds of standard, let's say, standard traditional human-computer interaction and user research techniques. And then we are entering the ideation stage. And the ideation stage is usually closely tied with prototyping as well. So ideation really doesn't just happen in your brain or just through discussion. What I'll preach here, more or less, is like that ideation happens through sketching and through storyboarding and through wireframing. So these are some of the common techniques that I really want you to embrace when it comes to the ideation stage. And that then actually helps us transition into prototyping. And so in prototyping, you usually work with paper and building really paper prototypes. I'll show you some examples of this, especially in the XR context. This is really useful. When you have these first prototypes, you can go also from paper to digital, but even just the paper prototypes, you could actually test with users. And keep in mind that the nature of the prototype really also somehow frames the feedback that you will get. So for example, if you have something that looks very low fidelity, initial stage, sketchy if you want, you probably get very different feedback, not so much about the colors, but maybe more about the flow and maybe the organization roughly of your interfaces. And so this is a very important thing to keep in mind. So you don't want your prototypes to look too polished, because it may also, there is this observation that if something looks too finished, it's close to being done, then your testers might be reluctant to provide more feedback because they anticipate a much higher cost involved in making changes. And now that's an interesting aspect as well. And with this testing phase concluded, although testing, to be honest, never really finishes because you go on and implement. Here, when we talk about implementation, I usually think of prototypes as something we're implementing a prototype and we're testing that prototype and then we're doing potentially another iteration. Here, this idea of implementation, really then you're going to use the technologies. In our case, we would actually go and try things out with XR devices directly. Now, I'll introduce you to methods that allow you to actually use XR devices also in the prototyping and ideation stages even. So for example, through immersive prototyping, where you actually create interfaces directly on an XR device and can test it as you're designing, concurrently testing it as you're designing. And so that is a really, really cool thing that you can do that is almost unique to XR. So now that we have established this 6-step method with the empathize, define, ideate, prototype, test, and implement steps, let's look at some of the issues when it comes to XR in each of these steps. Now, I said a common way to empathize is to interview users and to observe users and understand really their challenges and what are the pain points. Now, the problem with XR is that XR is usually not already a solution. So if you're refining an existing XR prototype, yes, then maybe you can observe how users use it. But if you're looking at an existing problem and you're trying to bring in XR as a potentially new solution, you can't really observe the users directly. It's very different from like web-based and mobile-based design, where we often, the users really work with this technology like on a daily basis. XR is really not like that. I mean, I don't know a lot of people that actually use VR on a daily basis and or AR on a daily basis, and then certainly not to achieve anything productive. I mean, we are moving into meeting scenarios and carrying out meetings in XR, so in AR or VR, but we don't really work yet, at least not yet, in these kinds of virtual spaces with virtual offices. And if we did, then the more traditional techniques of observation, interviewing, and really like shadowing and doing kind of like field studies. But the reality here at the moment is that you cannot really observe the issues directly as they happen with XR. So in the definition phase, to me, it's very important that you don't just look at the problem or don't just look at the symptoms of the problem and then trying to, whatever it takes to, to press that problem into an AR or VR solution. Many of us have a preference. So somebody maybe likes VR more than AR, and then they're trying to solve everything with VR or solve everything with AR. For me, it's very important that we keep an open mind. So don't just commit to AR or VR. It might very well be that after going through these initial kind of need-finding strategies, that you figure out that neither AR nor VR is actually a solution. And that would actually be a very good result. It could avoid a lot of cost and save you a lot of time and energy. So as we are moving into the ideation stage, what is very, very important to me here, and I really say this to my students all the time, is that when you ideate and you already have like experience, for example, using devices like HoloLens, and you know of all the technical limitations of these devices, so for example, the frequency with which they scan the environment, although that can be configured, or the accuracy with which they can represent the environment, or the lack of semantics that we have. So it's really hard to detect objects reliably, objects we've never seen before, and then know that the computer knows that this is this or that object. If you walk into a design or an ideation session with these technical constraints in mind, you're really limiting the ideation. You're basically biased, and you really do want to avoid that. I really like working with a diverse set of teams in these ideation settings, where some of the students often that I work with or other kinds of practitioners or other faculty professors, where they have actually limited experience with XR, where they're thinking of it as being something that is magical and super powerful, because it doesn't hold them back in their ideation. And I think that is really, really important when it comes to design thinking for XR. Now, as we're entering the prototyping stage, when I work with students and we have like these design concept ideas, we have ideated, we have already some kind of like storyboards and wireframes, and now maybe we're moving already from paper to digital, then one of the things that there's a tendency to do the basic things, like the things that you know already, to do them digitally. Like, for example, a login screen. I always tease my students, don't do the login screen. First of all login screens look more or less the same. So what's the point of prototyping those digitally? You won't learn a lot more. What you should do instead is really focus on the unknown unknowns, okay? So there might be actually a lot of gaps in your current design idea and your design concept, and you use prototyping to really figure out how to fill those gaps. And that's the best way to approach it. So the prototyping doesn't need to happen in a complete prototype way. It can be more like a horizontal prototype, where it's more like the facade. So you're trying to figure out the whole front end and all the options kind of shown to the user. And if you're taking this approach, then you're less focused on the vertical, on the technology, and more focused on figuring out the entire user-facing parts of the interface, and ultimately fill all the gaps. But really, even then, don't start with the known interface parts and then just do them digitally. I mean, maybe you can do this for warm-up, but what you should really focus on is the things that you don't know yet how they would materialize in the user interface, for example. So focus on those things as you're prototyping your XR experience. So then when it comes to testing, testing is very, very interesting because as we are using XR, we could actually use XR technologies to fill the gaps. So think of an interface that is nearly complete, but then you want something magical to appear and you don't know yet how to prototype it. Now you could do this in a video prototype through some kind of overlays, using some video editing software. But you may also use some more advanced AR or VR tools to really bring in some of these overlays. So I want you to think of XR technologies to also fill the gaps in your XR prototypes. And so this is a very innovative use of using XR technologies to support prototyping and testing. To really, the idea in this testing phase is to simulate an almost complete user experience, to simulate the experience of a working prototype where everything has been implemented. And you can fill these gaps. If you don't have a full prototype implemented, you can fill these gaps using humans as wizards. So this idea of the Wizard of Oz to really fill the gaps. So Wizard of Oz prototyping and testing is a really key idea here that I think also makes a lot of sense in XR. And especially in XR, so for example, one of the things I have done is like jumping into a VR experience, and I was like more or less invisible to the VR user, and I could move things in VR to produce like a virtual, like a heads-up display to them. And they thought that, oh, these screens are animated and they're like moving and this interface is responsive, this personal assistant really understands me. But in fact, I was actually there in the background as a wizard or the computer to really fill in the gaps. And so I think that is a very cool way of simulating a more complete prototype that we then can test that way. So it could be a really intelligent system that we're prototyping that understands all kinds of gestures and speech commands. And in this kind of testing phase, to really simulate the almost final user experience, even though we haven't fully implemented the system yet. Finally, when it comes to implementation, I think one of the common mistakes here is that many of us are very familiar with one tool, so for example Unity or Unreal. Some of us may know both, but then we don't actually consider other options and we try to do everything with these tools because we think Unity or Unreal is the best tool. Now the point I want to make here is that you should use the best suited tool. So for example, an early stage prototype, you really don't have to run and go into Unreal and use all their high-end rendering capabilities. Or Unity, you also don't need to jump into Unity to get started. No, you can choose other kinds of prototyping tools, maybe more like geared towards immersive prototyping. So really have a variety of options and don't be afraid, even though it's not always easy to transition between some of these tools. Having this flexibility in terms of tools and knowing a variety of tools is really actually a strength, and that would enrich also the way you think about the problem, not just like with this one tool, but from multiple different perspectives. So next I'm going to quickly give a high-level overview of the common methods and tools that we would be using. So The first thing we really want to, the first deliverable in some sense we really want to accomplish is the problem statement. And the way we do a problem statement, or we go about a problem statement, is through scenarios and use cases and maybe diary studies. So you're asking users to take notes about their daily lives and reporting back to you what kinds of issues they had, for example, with as they were using your AR or VR prototype. You may be wanting to do some surveys, so a little bit more larger scale, online or in specific user communities. You may want to do face-to-face interviews, or actually put multiple people together in a focus group and putting these different stakeholders together to really frame the problem. So that's the problem statement. And then we really want to understand the user. We want to define who the user really is. A common technique here is to use personas. Now, personas, don't think of personas as these sheets that we fill in, where every persona has like a cute name and maybe some characteristics. Think of personas more like as the meta behind creating these personas. That is actually where the rich information is. So not the sheet that I present to you, but actually the way I've constructed these personas. And if you've done this in the right way, it will be based on facts and data. And I'll talk a little bit more about personas later as well. Another way to define users and really understand who we're designing for and who we're not designing for is task analysis. And if you have already an existing prototype, you could use that to collect the data to some kind of logging and then log analysis. You may want to do user journeys, similar to the diary studies, but in this case, maybe a little bit more visual, where people really think through their daily activities. And you're trying to find out what are the activities and what are the kinds of events and how do they in their day-to-day activities and how do they impact those activities. So user journey maps is something that is very popular in the user experience design community, and that's something that you could also apply to XR. Similarly, stakeholder maps, and there are all kinds of ways of really framing and understanding our users. Next, we really want to understand the competitive landscape. So what are the solutions out there? What are the factors where they are good? What are the good features? What kinds of features are missing? And a common way to get at this competitive analysis is a SWOT analysis. So you're looking at the strengths, the weaknesses, the opportunities, and the threats. And doing this kind of analysis, which is more like coming from a business perspective, but it's often now applied to user experience design and interaction design as well. You could obviously look at existing products and download them and try them out. If you don't have access to some of the tools out there, you may want to base your knowledge on existing reviews out there. So there might have already be an existing user community, and there might be forums associated with the software solution where people complain a lot about something, and so that's a way to look at it. You could look at Stack Overflow or some of these common sources where people report issues and try to help each other. You could also do a more systematic research-based approach, kind of a literature review, and then really look at the things that are described maybe in white papers, in blog posts, or academic papers as well. And that way build your knowledge of, you really want to get the sense of the technology or the solution landscape out there, and really who are the competitors. As you're going about your design and you're drawing from the knowledge that you have generated from the problem statement and really framing the user, and then also understanding the competitors, you're going to do something about design synthesis. So really like getting all the data and facts together and performing what I refer to as design space analysis. And here I'll introduce you to a technique called QOC analysis, so questions, options, and criteria. So questions, options, and criteria. And you're asking questions about the options that you have available, and then you're determining criteria that will help you actually choose the best option if you want. I think this is a very cool way of analyzing a design space, and it's very useful.
If you're more into software engineering or systems, you usually think in terms of functional and non-functional requirements lists. So functional really like about the system and things you can like measure, like system performance, response time, and those kinds of things. And then non-functional requirements as well, so more associated with user characteristics or the soft things that are hard to implement. So to give you an example of scenarios, here are two scenarios that we've used in our work on cross-device augmented reality, and we were basically using these, at the time, more futuristic scenarios. What if a family wanted to place furniture in the living room? What if they could do this collaboratively using different kinds of augmented reality devices? Or what if a bunch of friends wanted to collaboratively play some kind of laser shooting game where they're shooting, inspired from Robo-Raid on the HoloLens, where they're shooting these kinds of bugs from the future. How could we enable that collaboratively? And so we basically did a scenario-based analysis. So we threw these scenarios visually as images at our participants, and then we really asked them to try to solve these scenarios and think through some of the issues, whether they are designers or developers or end users. So we really studied with all these three types of populations and really wanted to understand how they think about these scenarios. And that helped us really drive a lot of the requirements and then build a solution for cross-device augmented reality. It's a paper that I'll share with you if you feel like you'd like to take a look. So when we talk about scenarios, we really need to take into account 5 key elements. So really the setting, so the situation or the state of the system, the context of use, basically the physical environment in which the activity occurs. So then you need to look at the agents or the users. So what are they trying to accomplish as they're performing these activities? You need to think about the goals that they have. So what are their objectives and what are they trying to accomplish? And then what actions do they take to really accomplish their goals? And if there are any kinds of outside events, maybe triggered by the system or somehow by the setting on the environment, really things that happen to the users while doing their activities. And if you bring in these 5 different scenario elements, you'll actually really explore a future scenario of use of your interface in a very comprehensive way. Most scenarios that I read when presented to me are focused on just the user, which is similar to just a persona, or just the setting, but I don't learn enough about the goals and the actions. And if I learn more about the actions, I can also envision already a potential solution and the system behind the scenes. So it's really important to address all these 5 elements as you're doing some kind of scenario-based analysis. Next, I want to talk about personas. Personas are really commonly used to communicate users of our system. And personas in a more traditional sense, as I said, in a user experience design and research sense, personas would really be used to distill all the facts and all the knowledge we have about our users that we have gathered through interviews, observations, any kinds of surveys and other kinds of instruments that you may have implemented to really figure out the issues. But at the core, persona is really used to describe to other designers who we are designing for and who we're not designing for. So common elements of a persona are some kind of descriptive persona name, a photo maybe that shows the user or the context attributes. So it's very important to learn more about the scenario. And then often what helps in a persona is a quote that best represents this persona. And then usually you list the goals, you list their frustrations and needs, if they told you explicitly or based on your interpretation of what they told you. And then also their motivations, incentive, fear, achievement, growth, power. These are kinds of common attributes, kind of that you find in a persona template. And so we need to distinguish different types of personas here.
So commonly we talk about primary and secondary personas. So primary personas really refer to users where we believe that our design completely satisfies their goals and needs, as opposed to secondary users where we think that our design mostly, but not completely, meets their goals and needs. And then we also have this idea of negative personas. And this really helps to communicate to our stakeholders who we are not or not yet designing for. So our design at this stage doesn't actually target any of their goals or needs. So personas is a really common technique in user experience research and design. And what is unique or more special to XR? So I think when we construct personas, more specifically for an XR experience, we need to think about how much experience do these personas actually have. Are they a novice or an expert, XR designer, developer, or user? And then what are good metrics to express their experience? So there could be kind of like self-rated scales, or they tell you how many months of experience they have, or how many times per week or even per day they use an XR experience. And then they should also give you examples of devices and applications that they have used. So I think if you ask for all these kinds of things as background information, and if you specify that for your personas, then this is a very good way to frame and identify who are your primary and your secondary users. So in a lot of my research, I often targeted novice designers to enable them to be able to create XR experiences without being a developer or a programmer. And so that's how I would normally fill in the personas. Now, I do think that developers could be the secondary personas in a lot of my research, because a lot of my work is focused on rapid prototyping. And while my techniques are targeted at more like novice designers or novice XR creators, even experienced XR creators could benefit from some of the techniques. So I would consider them as secondary users. And in a lot of my research, I focus more on designers and developers rather than users or end users. And so an end user, so somebody who uses that design created by the designer that is using my tool, so that end user would be an example of a negative persona in a lot of my work. Doesn't mean that I don't like XR users, it just means that I currently don't really design for them, that my solution is really geared towards XR creators. So talking more about personas and constructing personas, I have a list of do's and don'ts here. So what you should really do is clarify how these personas were created. Are they constructed or are they facts-based? Ideally, you should actually base them on data and facts, but often personas are just used as a tool to communicate to other stakeholders who we are designing for, as I said, and so you should just be very clear and honest about that. And what is very important is that you actually let those personas reflect your diverse target user groups. So don't, if you think in terms of 3 personas, don't make them all the same. In the activities that I usually do with my students when we are constructing personas, I really want them to think about the most unique and very different types of users that they might be designing for, to really explore that space a little bit better. And in addition to primary and secondary personas, we really also should always include negative personas to make it clear to others who we are not designing for. So what you shouldn't do is just make assumptions. You shouldn't stereotype personas. So don't bring in this persona of this old person that can't use computers, for example, or even bring in certain genders and discriminate against them, or race. And even though I teach in a very diverse and inclusive environment, I still see this happen all the time among my students, and I want you to be careful. Finally, don't confuse negative personas with people you don't want to use your solution. No, negative personas are really the people that you're currently not targeting in your design. Doesn't prevent them from using your solution, but maybe in a future iteration of your design, you may target them more specifically and then cater more to their needs and support more of their goals. So what I often use is a kind of template where I list out the competitors on one side and then all the kinds of features or even non-features, bugs on this side, and I call them factors. So you do this as the columns and the competitors as the rows, and the competitors really are the solutions, let's say the XR applications that are out there. And rather than just like putting indicators which of these factors are supported, I usually write how well they are supported and how they are in fact implemented, and this actually differs between solutions. But for the purposes of this presentation, let's just put X's as checks and supports this factor or not. And like with personas, I think of competitors as direct competitors, partial competitors, indirect, parallel, and analogous. So this seems very fine-grained here, but there are actually significant differences between each of these. So direct and partial makes sense. Direct in some sense is really overlapping. This competitor really provides the same features and services and targets the same users. Partial is there is a subset of the features, for example, supported, or they only target a subset of the users that you have identified through your personas. Now, an indirect competitor is somebody who goes about the same problem and so in that sense is similar, but goes about it in a different way. And because they're still targeting the same problem, and even though they go about it in a slightly different way, they are still a competitor. Now a parallel competitor is similar to what you have in mind, but they're not necessarily a direct competitor. And finally, an analogous competitor is actually a non-competitor. This is basically somebody who is basically a solution that is targeting different users and different goals and needs, but there is something in their design that inspires you. And so what I usually do with my students is I really encourage them to think about the direct and the partial competitors, and maybe some indirect and parallel competitors as well, but really find those analogous competitors. Existing interfaces that may address a different problem, but there's something very interesting and inspiring about their design, and that is something that maybe you want to think about adapting and incorporating into your solution, and that is fine, usually. All right, and so then the way you go about these competitors and the competitive analysis, as I said, is through SWOT analysis, where you identify the strengths and weaknesses and opportunities and threats. And now here is a common pitfall that I see among a lot of my students. We're doing this competitive analysis, we're drawing out this whole landscape, and then our solution is trying to do it all and just do everything better. We really like all these factors are important, and so we're trying to build this super solution. And that is really not how you should think about it. What you should do instead is maybe find the gaps. There must be gaps between some of the factors. They don't really cater to the user's needs. They don't really address their goals. And that's where you need to innovate. So don't try to do a dashboard that integrates everything, but instead try to find a more focused solution that really establishes new factors. And that's the niche, and that's what you're gearing your XR solution towards. That's that. We now have looked at the scenarios. I've shown you examples of personas. We've done a competitive analysis, and I will have a separate video and separate modules dedicated towards storyboarding, so that's not covered here. But these four types of input really form what we then call the concept model, or your design concept, and that is really how you think about the solution as the designer. Now keep in mind that that mental model of that system that you are creating The key challenge is to really invoke that mental model also in your users, and in fact most systems fail because users often have a very different mental model, quite different from the concept model that the designer had in mind, so the designer's mental model of the system. But if they match, then you're really doing a very good job. Think about how you think about how an ATM works. Yeah? You're putting in your card, you're asking for money, it's going to give you back your card, and then you're going to get the money. A designer of that ATM might think about it very differently, much more fine-grained, very specific, all kinds of error scenarios. And let's say if that ATM never ate your card, you didn't even know that this was possible. Your mental model is that ATMs are really nice, they always give you money, you've never experienced not having money on the account, or maybe you have. And so think about these different user experiences. So eating your card, or insufficient funds, or maybe some error, there's actually enough money but something went wrong with the bank. And think about all these user experiences, and their mental models of ATMs might be very different from someone who always had enough money, whose card was never eaten, and they never actually had an issue with an ATM. And also think about this, the next time you're going to use the next ATM, once one of these disruptive user experiences has happened to you, you will be very afraid. I have more examples like this. For example, checkout lines, self-checkout lines specifically. I always get very nervous about the machines and those instructions. And so these are really examples where the design concept, if you think about it in principle, might make sense from the designer's perspective, but all these disruptive user experiences lead to very different mental models of these systems, and so there's this interesting clash. And so there is a good way to go about this design synthesis and actually building this concept model. This concept model, or your design concept, is really in some sense the specification that you want to give to a developer. So this is how I think about the system. This is what we need to implement for our XR solution. So a design space analysis, I really like this idea of asking questions, considering the options that we have for any kinds of questions like how to display something. We can display it permanently or appearing. And then really putting out the criteria. When would we use which option, and what does which option actually mean? So weighing these options and then finally actually making a design choice for one of the options. So for example here, appearing. And so there's work on that, and I'll provide the reference about this design space analysis. And this really often happens implicitly among designers. We ask questions all the time, we consider options all the time. So the hard part when it comes to XR is really asking the right questions. How to display things, how to track things, how to travel in VR or in AR, how to manipulate things, and how to collaborate. These are like some of the big questions that I usually come up with or go through when I create a new XR experience. And let's just look at one example here. So how to display, obviously we just had permanent or appearing, but when we think about appearing, it's not just whether something appears on screen or not. In XR, we can also place things in the world, and so in AR that might be somewhere tied to a physical location, or in VR somewhere tied to a virtual location, and may not always be visible to the user, and may only be appearing when the virtual camera moves it into view. We may also have this kind of like compromise solution where once we see it, it follows you around. So as you move the camera, it kind of like travels with you. And so these are some of the options that you are considering, even just for this appearing example, and how to display things in XR. Now, design thinking, as I said, is really about a mindset, building empathy with your users and then trying to define the problem and really innovating in a meaningful way. And that to me is very, very important. In the XR space, the meaningful part often comes too short. I was thinking, what are 4 principles that I could convey to you And so maybe you take them with you and you incorporate them into your design thinking. And so these 4 principles, and they have been, I've been shaped in many different ways, where I've been, studying computer science at ETH Zurich, for example. I went to the Human Computer Interaction Institute at Carnegie Mellon and was teaching there a little bit. And now I've been a professor for several years at the University of Michigan, teaching user experience design and research, and now obviously also AR, VR courses. And so from these various experiences, I have actually incorporated these 4 principles into my design thinking, and maybe this helps you as well. So here's the first principle. The user is not you. If you're a designer, you really have to think about that design from not like what is easy for you and what are the kinds of things you can detect and recognize and what gestures work well from a computational perspective. No, you have to think about it from the user perspective, and this is the primary challenge. So my second principle as a designer is it's really hard to unlearn. And I often have to remind myself, because I tend to forget how hard it is to do, for example, basic web stuff. I mean, I say now basic web stuff because it is hard for me to imagine this initial stuff. Or the first time you open up Unity or Unreal, and how intimidating some of this software can be. And now that I've used these tools for many years, I've learned so much, and it's really hard to unlearn. And so the way I want to illustrate that point is, some of you may have seen this optical illusion before, and maybe you are able to see 2 people in this optical illusion. Most of you will see 1. If you haven't seen this before, you will either see a young lady or an old lady. And that really depends on how much time you give yourself and which elements you focus on in this optical illusion. But let me sketch out the young woman. Basically, this is her chin, her eye, this is her hair, and she's looking over her right shoulder. And now the old woman is, this becomes the nose. You see one eye here and one eye there, and this is then the older lady's chin, and this is her mouth. And so this is the old and the young lady's hair. And so now I've shown both these women to you, and the next time you will see this, I promise you, you will at least remember, oh, there are 2 people in there, and then a second later you will be able to see both again. And it's really hard for you to unlearn. And so it's the same as a designer. So if a user expresses issues to you that seem trivial, or like, why didn't they know that? Keep that in mind. Just because you know that and you have learned that. So the problem with that is that it actually makes it very hard for you to put yourselves into the shoes of a novice user. And that's just something to keep in mind. My third principle is about this difference between how junior and senior designers approach this design. And this is an example that I've borrowed. And a junior designer really usually thinks there is one path, and then they will stick to that path and eventually get to that solution. Now, there is no direct line from the problem to the solution. The dotted line here doesn't actually exist. But we may just like follow this lead, and then we're doing a little bit of iteration, and then really stuck on that idea, and that is really like how you end up with this kind of path. But a more experienced designer would really explore alternate paths, so different designs, and then take some of these more promising designs further, and then explore some of these branches, and maybe even go a step back and figure out an alternative to the alternative, and then finally get to a really good solution. And this is how you should go about design. Be a more senior designer, if you will. My fourth principle, and this is something that I just say from a lot of experience, and when I work with students especially, they always think about prototype is just a prototype, and then what's the product? And so I just say to you, everything is a prototype. Even the latest XR device that you may hold in your hand right now, that is a product, it's advertised as a product, it is still a prototype. we're still very far away from this final vision of XR devices and XR experiences incorporated maybe into our daily lives, enriching our activities. And so just keep that in mind, and don't really try to draw the line between prototype and product. Just be honest. So that's my fourth principle, that everything is a prototype and there is no final product. I use the term final prototype more like as this is the last thing that we'll prototype. It doesn't mean that it's the finished product. And so maybe that's a good way to think about prototyping and product. And also, there's really no difference in terms of the methods and tools that they're using to create prototypes and that they're using to create a product. I think it becomes a product the more you invest in service and advertising. And these are things that you usually don't do with prototypes. And prototypes really you should be okay to let them go, to throw them away. A throwaway prototype is still a good prototype. But a throwaway product, a failed product, is really not what you want. So embrace these different methods and tools that I summarized here in this XR design thinking lecture, and hopefully find good, meaningful designs that eventually would be regarded a useful and applicable product. In this video, we're going to talk about XR design ethics. Now, design ethics is really, really important. We need to really think about that in the space of XR. Ethical and responsible design, you have actually a great responsibility. As you're designing a virtual reality around your users, you have to make sure that they are safe, that they are protected. And that's hard, especially given that you don't know much about the environment in which the users are using your applications. And when it comes to AR as well, you have to really make a lot of trade-offs in terms of how much do you need to know about the environment, the people around the users, about the users themselves, the devices that they're using, the context where they're using this. And so when you have all that information, do you really make use of it? Does it really significantly improve the design of your application? Now, in many cases, you won't have access to all that data just because the technology isn't there yet. And we always feel like, oh yeah, we need all that information. But we should really think about how much information we need in order to provide a compelling design. And our rationale or our goal should be to work with the minimum data rather than trying to, get it all and then see what we can do with it. You really have to figure out how to minimize the risk and how to maximize the safety of your users. And as I was designing this lecture, I was thinking about these following questions. What when users can't tell what's real and what's virtual anymore? What is the role and responsibility of the XR designer? How do we hold XR designers accountable? What happens when users go against your intended design? All these things combined, I was thinking, what are good ethics principles of XR design? This is a space that I'm just thinking about a lot, and there are not so many really good guidelines. So there's not like a list of 10 things to follow and it'll be perfect. No, there's an intuition that you have to develop as a designer. You really have to know the technologies, you really have to understand the design space, and then you have to make really, really good choices in the interest of the users. So I wanted to start with design ethics principles. And quite fundamentally, there are like 3. Autonomy. So the user is in control at all times. Transparency. The user is informed about how to control or be in control and stay in control. And safety. The user is protected from danger, risk, and injury. So autonomy, transparency, and safety. These are like the really high principles. And if you look at existing design guidelines, like from all the main vendors, safety, and that is both the physical but also the psychological safety, those are really values that are held up very highly. It's really emphasized, but it's hard to find concrete guidelines that help you make good decisions. And unfortunately, it is often through misuse of a design that we learn about the negative consequences of our design. And by misuse, I just mean that something maybe you haven't considered in your design process. So we have to think about how we approach design more holistically. So one way to think about design, or responsible design in this case, is to not just focus on how to best use your solution, so improve and optimize the design of your solution so that it's really good for users, and following design patterns, established design patterns, or helping by creating new designs and shaping new design patterns. No, we should also consider how your solution could be misused, so the dark patterns of design. So now the problem with both design patterns and dark patterns is that they're both still really emerging. Now there's not like a list of these patterns and then these dark patterns and be careful. It's not like that. I mean, here's a way to think about it. You need to think holistically. So you need to think about the context, the situations and the conditions in which the users are and in which your experience, that the one that you are designing, will be run by the users. You need to think about the tasks that you want your users to be able to do. What kinds of actions or interactions can they do? What are the kinds of the events that might be generated by the system? And how might users respond to those kinds of events? Then obviously you need to really think about the device cameras, the sensors and the algorithms. Now as a designer, you're designing for a kind of like a device, and you could say that you are actually a user of that device, since you're not necessarily improving the algorithms on these devices and platforms. But you can still be careful and you can still make good decisions in terms of the devices that you build on. So we also need to think about data collection, processing, and management pipelines. Especially as a researcher, you really aim to get as much data as possible. Also, obviously, as a designer working for a business, because information is key. But here, I would really encourage you to think about, do we really need all that data? So frameworks, libraries, and tools that you are using for application development, that is really something that you are making active choices. And so you should, again, know what's going on behind the scenes and make informed decisions. And then obviously the user interface and interaction design. This whole course is really focused on user interface and interaction design. But this is not the only place where we really need to pay attention and make sure that we are, for example, not endangering our users, not promoting weird interactions. And then not only at the user interface, but obviously also at the data level, we really need to think about data ownership, the governance. So really what happens with this data once collected, where it's stored, how it's being processed, and then also, and this is really important, future use of that data. I mean, just because a user might agree to give you the information so that they can run that XR session and place a couple of objects in their living room or kitchen or bedroom, doesn't mean that you should be using that data in the future. You as the designer, vendor, these are things to think about. And there may be many more, but this is actually what I come up with as I think about both the design and the development of a new XR application and a user experience that I think is safe and potentially helpful and useful to users. So what I'd like to do now is actually bring in a different perspective. As a researcher, I often have like new ideas, and some of them might be crazy and a little bit borderline, right? Some of them may involve deception, and that's something that's okay in research as long as you debrief and also get informed consent from users. Now that is something that I'd like to emphasize a little bit. What I really find interesting that in research, in scientific research, at least in North America, which is what I'm most familiar with at the moment, we do have established ethical review processes. But it's really important that you navigate all these things. So to actually so that actually users' rights, so participants, study participants' rights are protected. Well, one way to think about the ethical review process is that it's really a risk assessment. Are they users? Are the users or the participants in this case, are they exposed to risk that is more than what they are usually encountering in daily life? And so it is a very interesting lens that may help us, or maybe you as a designer, also to better understand what could be ethical design. So I'm going to walk you through ethical review, and I'm going to try to apply that process, as far as I understand it, to XR. So when you want to do a new user study, you really have to define the purpose, the procedure, and the duration. So that's really key information. So what is the purpose of any data that we acquire? That's what I would like to ask you here. And then also, what is the procedure for you to collect that data? Really think this through. And then also, how long do we need to collect that data? So is it just one session? Is it every session? And how long do we keep it? And do we intend future use? And do we tell our users? And not in the small print of some kind of really long document about the policy and the terms of use and all that. No, we probably need to think about better ways of integrating and incorporating those kinds of things in the user interface. Well, if you're a little bit more advanced as a designer, you know the consequences of each of these things. But as a user, you may not. And so is the user really making an informed decision? Well, all they want is run your app in most cases. So, but that's not good enough. From an ethical perspective, that's not good enough. It has to be informed consent. So, the other main goal with an ethical review is to really understand whether there are direct benefits to users. And so what you want to do is actually maximize the benefits and limit the trade-offs. So what are the expected benefits to users, and are they direct? So can they perceive them? So what are, and I'm going to inject acceptable trade-offs in realism, comfort, and safety. And are these reasonable? The third aspect of an ethical review is really a demonstrated effort that you're trying to minimize the risks of your participants. So what are the content-induced risks to users? And associated with that is the question of how to limit the data and any entities that collect, process, and manage it. And by entities, I really mean like the algorithms, all the steps in the pipeline, all the kinds of different solutions and service providers that are involved in making you track the gestures and understand the speech commands and all of that. Really, you want to keep that very, very small. As a researcher, I usually say, okay, the only person or people that have access to the research data is me as the investigator and then my research team. And finally, I think, and this is maybe a little bit unique here or a little bit of a different view on ethical review, this idea of agency and autonomy to really empower participants. So how do you enable your users to stay in control? Well, as a designer, for example, you may really strive for this high level of immersion just because you think virtual reality has to be like really realistic. But like, imagine ways for users to control the level of detail, just like you have in any computer game. You can usually control the graphics. So now this was my version of an ethical review of XR. And now I want to switch gears and actually talk about this idea of doing a design ethics review and provide a couple of ideas of how to approach it and think about it. So the first really big thing to think about, and there are 4 in total, in my opinion at least, is context and situation. Where is the XR device being used? Who is around the user? The second important thing is the sensory information and the data that we are collecting. So what does the XR device see? What kind of data is acquired? So these are really important questions that you should be answering for your design. And it may really vary depending on context and situation. So there's an interesting dependency between the first and the second kind of quadrant here. So then we need to think about the processing pipeline. And this is something, as a designer, you may struggle a little bit, maybe because you're using all kinds of solutions that are kind of like a black box to you. But that's where I would encourage you to really learn more about the technology. So what happens on device is a really, really important question to be answered. So what kind of data is collected and then processed on device? And how is that data processed otherwise? If not on device, well, it has to be somewhere online in the cloud. And that means it's going to be transferred to a third party. I mean, from the user's perspective, it's a third party because that's maybe something they didn't know. That party is involved. And so that's a little bit of a risk, isn't it? So what happens in the cloud? Who manages the cloud? What kind of protection is provided? What is the service level agreement? So these are all kinds of things you need to think about. So the fourth big topic of our design ethics review has to be about data ownership and governance. So who owns and manages the data, and how is the user informed about this? And is it explicit or implicit, or do we never tell them? Or have you not thought about it? Okay, so I'll stop teasing you there, but really this is something that we should think about. And really, really important is that this design ethics review happens continuously throughout design, not just at the end when all the decisions have been made. So this is a mindset that you have to apply as you're making design decisions and forming your rationale about those design decisions. My first example is home decoration. This is inspired from the IKEA Place app. And so now we have a family here, they're all using their devices and they're deciding together what kind of furniture to get and where to place it. And the example here is a living room, but it could be all kinds of other rooms. So let's analyze this a little bit, do a little bit of a design ethics review given what we just learned. So the context and situation here, okay, I said it's living room and it's family. So let's just say it's the family and every member of that family agreed that they will all want to come together and use the devices in this interesting way. And then the sensory information and data, well, user, bystanders, and these bystanders are family members. We do see furniture. We may be able to infer something from that furniture. Is it expensive furniture? How much furniture? How old furniture? So that is something that is potentially sensitive information. And then the geometry. Yes, so the app needs to understand the geometry of the environment, and then it can do a basic object detection, mostly in terms of the furniture that it knows. So in this case, probably IKEA furniture that it has like access to as a catalog. So, but lots of things could go wrong here in terms of like other kinds of objects being introduced and then misclassification, etc. So then we're looking at the processing pipeline. So in this example, actually the original was marker-based, but now we have marker-less implementations. So basically the devices do their own scanning of the environment, relatively limited at the moment in terms of scene understanding. Finally, data ownership and governance. So here, obviously, the data ownership might be with the app developer. I don't actually know who developed IKEA Place. Maybe it was IKEA. And then when it comes to the question of how is the user informed, obviously that is through some kind of language, terms of use when you like find that application and download it. And then a little bit through visualization because, for example, it'll render a little bit of a pattern across the surfaces that it detects and it gives you a sense of what the device sees. But don't be fooled. That is just a visualization of the kinds of information that the device is relatively positive about, relatively sure that this is a surface. It still sees many other things that it may not visualize to the user. So keep that in mind, and that's our little this is our first little design ethics review for this scenario. So now I'm going to port us into a different scenario. We're still kind of like in the same realm, people together in a living room, for example, and now they're playing a collaborative game. So one of the big differences in this scenario is that you're not paying as much attention to what kind of things you're looking at. When you're designing and decorating your home, you're really in control of that device. But when you're playing a game and that game makes objects appear there and even places that maybe you didn't want the camera to see, but just to participate in that game, you do this, and obviously your movement is a lot faster, so it makes it a lot harder for devices to really sense things and understand it, but we're getting there. So the other thing I wanted to express in this scenario is now we're actually using very different display technologies. You see a HoloLens user here on the left, some kind of HoloLens is actually HoloLens 1 here. We're using some kind of projection and camera-based system, so a Kinect here, so this is a ProCam setup, and so that a user even without device can participate and see this kinds of experience. And then we see a smartphone user here on the right. So all kinds of very different display technologies, and each of these have very different tracking technologies involved. Now that is interesting. Now I want to bring in another consideration, which is like if these were in different environments, and now each user in their own home are participating in this collaborative game, what does that mean for the data? And now there is no way to handle it locally. Well, this kind of information gathering and processing and coordination among these devices, so to get them into the same coordinate frames and making sure that these devices can collaborate, that already requires some kind of server-side infrastructure, but that server could still be part of the home network. Now in this remote setup, that's different. Now we have to go online, and now we have to process, and now we have to transfer that data between participants, between users, and now that introduces interesting new issues. So for this scenario, I'm not going to do a design ethics review. I just wanted to point out a few differences, and I'm going to do the same for two more variations of a second scenario. So the second scenario, imagine a classroom lecture. So this is now more like a public context. So you're like going to a lecture hall, maybe you're a student or you're going to a conference and there's a speaker up front. And so that speaker wants you to participate in this really cool AR experience where you can see the solar system. And you're using all kinds of devices here, the different users, and they're kind of engaged, so pretty cool. So public space, all kinds of different devices, both handheld and head-worn, could also be kind of marker-based. And now a different variation of this scenario, it's now a team meeting. So you're going with team members into a smaller room. It could be some office space or some public building or even your home. So how would that change how you would use this AR application? So things to consider here are this could be a more private or still a public environment. You may or may not know those users and you don't know what kinds of applications they have installed on these devices. And also you need to think about these different devices coming together here and all that to support a human anatomy application so that we can learn about human anatomy. So all kinds of interesting things to consider here. So the last thing I wanted to throw in is the consideration of design impact. And that's something you have to consider at different stages. So you have to think about it before, during, and after the users are experiencing your experience, so your application. So before, and this could already be in the App Store, if that's the distribution channel, you should really set the expectations of the users for that new reality. So whatever it is that you're porting them into some fancy or scary virtual world, or how you may change, manipulate, modify, diminish, whatever you do to their real world in an augmented reality version of your application. And so you need to prepare them so that they know. And then obviously during the experience, you really need to balance the realism, comfort, and safety. And the trade-off should really be around the realism. And what you want to maximize is safety, comfort, and then maybe realism. You didn't even see that, so maybe realism is there. Finally, you need to think about what happens after they have tried out your experience. So the impact of your experience afterwards, it may actually shape the next kinds of interactions that they encounter in daily life or with another kind of XR experience. And yes, okay, maybe you feel like your responsibility ends there, but you really need to think about that as well. So help users transition back to the old reality. And this could be through some kind of debriefing or even during the experience, asking them to take breaks, to remind them of the real world, because being addicted, while it might be good for revenue, is not really good from a design perspective, especially from an ethical design perspective. Okay, and now I wanted to give 3 examples from my own research. And 2 of these examples are actually about projects that I've worked on, where we had to make a very interesting design ethics decision. And the 3rd example is one where I decided not to pursue it. Just because from an ethical perspective, I really didn't feel this was a good thing to do. The first example is from a mixed reality crisis simulation and triage training app. And I'm not going to show any pictures here, but we really had to design how realistic should we make the injuries. Now, that was an interesting project. We were working with a professional in nursing, also a professor here at the University of Michigan, really understood all that. And she actually helped us create the virtual injuries by using a mannequin and some kind of like blood and then taking realistically looking photographs and sending me all these pictures. Basically, the task that I set the students was like place these injuries so that they appear realistic and anatomically correct. And so I'm not going to actually show any of these materials here, as I said, but I really thought we need trigger warnings, even as I was working with my students, and we really had to make the trade-off between making it super realistic and making it just help inform the triage decision making, which follows a specific protocol. So we were designing 2 levels of injuries, and we allowed users to pick it. And one important consideration here, though, is that if you're a medicine student, the further you are along in your studies, the more things you have seen. And now, with our design, what we could enable is early students in their career, as well as more advanced students who have obviously a higher threshold now, work together, and that app was still supposed to invoke some stress to make it a realistic scenario, because in a disaster you really need to be calm, and that is something you need to train. And if we just show kind of like comic style injuries, you're not going to feel stressed. And so that was a very interesting scenario to navigate. And the second example is from a master thesis recently completed in my lab, and that was with a really cool student who came from Colombia and also wanted to do a little bit of a field study there in a museum of memory. And the idea of this project was to build empathy but avoid re-victimization, as we're using augmented reality to bring some of these stories and the narrative of those stories closer to the users. Now, without going into too much detail, that is a really difficult to do. That is a really difficult thing to do. And in this project, we really worked together with the staff of that Museum of Memory who had significant experience. And the important thing is we didn't want to design this naive AR application where it's just like place images everywhere, make it immersive as much as possible. No, this is really something where you have to understand the technology very well. That's why I was so fascinated by the project, and we had to make very careful decisions. In the end, it was a very complex project, and we are still processing some of these research findings and thinking about how to communicate that research to the community. But I wanted to include it here because obviously it was a recent project and work that my student did, and I was very proud of her and that work, and so I wanted to mention it here. The third project is one that I did not pursue. Student walks into my office, really great student. We both learned from each other that we had lost loved ones, actually deceased family members, and what if we could bring them back? How could we even bring them back? What would it be like to bring back a deceased family member in VR? And that is a project that I was like, wow, okay. I mean, I can probably do this. I mean, I can think about the technology. And is it going to be 360, or is it going to be virtual reality, or is it going to be augmented reality? And what are the consequences of mixing that experience, of bringing back the deceased person and making them appear in real life, so in augmented reality? And yeah, so I didn't want to do this. And I think, and the student understood, and we made the decision together, and I think that is fine. Now, we have not done this, but as I said, somebody else has. And now I feel like somebody else has to live with that decision. And the other way to look at this is like, had we done it, maybe we could have explored that project in a really good way and make very good ethical decisions, and then inform or somehow influence that other project that happened without us. So that's maybe the one regret that I have here. So this last part of the lecture was a little, you know, thinking about things, and I hope that you understand the importance of the topic of ethics. I hope that you forgive that it's not like this checklist. It's not that easy. And so I want to go to my last slide, the things we should keep in mind as we think about design ethics and XR design ethics specifically. So in every decision you have to make, consider the cost-benefit ratio to the users, okay? And especially the cost. So with all design decisions you make, carefully weigh the trade-offs. Don't make critical decisions for users. Enable them to make those. So you should really think about, how do you actually provide for a customization support? How do you communicate customization options to users? And how do you enable and empower your users to make those decisions, rather than you making all the decisions around the immersion and the level of realism and how you blend objects into their environment and the kinds of information and hand gestures and speech and whether you identify all the people around them and what you do with that information. No, you think about how to communicate that to users, and that is actually a really, really difficult design problem. And now we're talking. All right, obviously then you need to stay aware, so always learn. And these ethics considerations must evolve as XR technologies evolve. So in a few months or years from now, we may know better. And maybe I have to really redo that lecture. But this is the best I could do at this stage. Now, think a little bit about my background. I'm a computer scientist. I am trained in human-computer interaction, but more on the ethical side. And if somebody else has a very different opinion about XR design ethics, and I would really like to talk to that person. I'm sure there are both good elements in what I talked about and elements that you could critique, and I'm open to critique. But I hope that I provide at least some kind of thought framework for you to navigate that space, which is a really difficult space. So build these ethics considerations directly into your workflow, adapt both. So really not an afterthought, okay? Directly part of your process, embedded in every decision you make. And then finally, and this is more like speaking to you guys out there developing technology, and then you guys out there designing for this technology, you really have to know the tech. And don't overpromise with what you say your solution can do. Okay, I've been in so many discussions around the things that devices see and how tracking actually works. And while it's very scary, so for example, to use a VR device like that in the background with all the cameras that it has for inside-out tracking, while that may be very, very scary for passers-by, the average person that may not fully grasp the reality of these devices and understand what's going on technically, you have that responsibility to inform the users and the non-users around that device that something is going on. And this idea of like some kind of red blinking light so that you know that we are recording and the device is seeing something, that is the most naive way to approach this topic. So that is not the solution. And the other thing you really have to be clear about, and the other thing I wanted to touch on is like I've seen so many promotional videos that really annoy me just because they don't advertise the product correctly. the device can actually not see anything when you have your hands down here, and the field of view is like this rather than like that, and whatever they suggest and how they have composed that video. And there's also something wrong there from an ethics perspective. And so don't overpromise. And then as a researcher, this is really clear. I will never get my stuff published unless I really talk about the limitations. And in order to talk about the limitations, you have to explore the limitations. So every solution has limitations, and you really need to learn about them, and then you need to be upfront about them. You can't fix them all. Some of these limitations may have to do with the technology that you're choosing, or somewhere deep down in some kind of framework that you're relying on, or some platform. And so it's just important that you know and that you consider this. And so this is where I end with my lecture on XR and design ethics. So this is really a topic that is evolving. A lot of people have talked about it from the user perspective, realism, and all the kinds of side effects, and is it good for some kind of therapy, and what are the long-term use effects, and what are the effects on children. And I wanted to do a lecture that helps us as designers think through this. Now, I probably didn't get this super right, but if I accomplished something, I made you think more about the design decisions that you're making, and also trying to hold them up to some kind of ethics standard, a code of conduct that we really still have to develop together in this field. And I hope that some of my efforts, and then obviously all the other amazing people out there that are working on accessibility and other kinds of issues around privacy and security, that we're all coming together in this, and we're finding really good ethical frameworks that help us think through those things and avoid making mistakes when it comes to design decisions. So XR design guidelines is a really, really important topic. And the problem that we have right now is that XR design is really a moving target. So many new kinds of devices coming out, and some of them are changing really the way we interact. Now that we have hand tracking available and eye tracking as input on both AR and VR devices, it is very interesting where this leads in terms of design evolution. And so I really struggled a little bit when I wanted to put this lecture together here. I was hoping that I can share something practical, and really wanted to have concrete guidelines as much as possible. And I've looked at all the guidelines that are out there, and we're going to review some of them here as well. But the issue is really that there is no perfect guidelines out there. So the moral of the story and the essence of the message here in the end is that you just have to try it out. And you have to think from the perspective of a user, not just design and implement the things that you think are easy as a designer. No, you really have to look at what is meaningful, what is useful, usable, and also consider long-term use, and hopefully develop an intuition over time that allows you to determine whether something is a good or a bad design. But yeah, that's just like my perspective. I've still tried to put together a few guidelines for us to get started, and we can use these guidelines to review each other's designs throughout the course. And but think of it really as a source, a starting point, a source of guidelines that can evolve hopefully over time, and that's really how design works. So we're still in this part of the course where we're more on the design thinking side. So what's the best way to learn about XR design? So I think it's actually studying design guidelines. So what is the knowledge that is out there, and which of these guidelines are really like something we have to adhere to, and which of these we can bend to potentially innovate in design. We need to learn how to critique existing designs, and actually that critique will really involve a lot of constructive criticism and suggestions for improvement. A lot of this should be based on guidelines as much as possible. It should be objective. And finally, we want to be able to create our own design. So I'd say in all of these efforts, it's really important to learn about guidelines. So when we have a look around, there are actually quite a few guidelines out there. And I think we can distinguish them into like 4 types of guidelines or sources. Those by vendors that I think are mostly platform driven. Those by designers. The good thing about those is that they're really user-oriented and they're coming more from a human-computer interaction perspective. Then there are those created by practitioners, so really experience-based, not necessarily with scientific rigor, and that's why I would draw the line to those established by researchers. Usually empirically derived, some kind of lab-based user studies and controlled experiments. And so there are all those guidelines out there, and I'll provide references to some of the promising examples. In this video, I'm gonna review a few of the vendor-based guidelines, and then I'm gonna share some of my own experience and insights. And we're gonna actually go on a little trip as part of a recent experience where I went to a remote conference, IEEE virtual reality conference, and so I thought it's actually quite cool to look at how researchers and designers implement current virtual worlds, for example, to support something like a remote conference attendance. And so we're going to look at that, and that's one of the examples I have here as well. So let's look at a few guidelines first. I picked Oculus guidelines. They're mostly focused on VR. Then I picked some from Google. They're focused on AR core, and so handheld AR. And then I was also looking at other sources, Apple, Microsoft, and then Mozilla. And so the Apple and the Microsoft ones are actually quite good, but for copyright reasons cannot show them here. I'll link them. And I added the Mozilla ones because they are really in the realm of WebXR and this idea of bridging multiple devices and platforms. They're a little bit more technical as well, but I think together, comprehensively, quite a nice set of guidelines driven by vendors and device creators, and then also open standards initiatives and institutions like Mozilla. So the first example we're going to look at is here from the Oculus guidelines. And so I browsed and selected my device first. So let's say I'm going to develop for the Oculus Quest, and they're going to tell you a little bit about how rendering works, how stereoscopic images work, and then it says things like don't occlude the screen with the HUD. That makes a lot of sense. And don't draw HUD elements behind scene elements. So these are some really good tips, and this sometimes happens by accident. And then I think we're entering a very practical portion here where it talks about basically the field of view and how vision works, and both the horizontal, so the horizontal field of view, and the vertical field of view that we have, and where we see best and what's really a good area. And then I think those guidelines focused on hand tracking are really a part where the Oculus guidelines stand out. So let's focus on these a little bit and explore them in more depth. So here you see a concept video of how the App Store might work, where you're exploring one of the games like Beat Saber here, using hand interaction. And then they're talking a little bit about the principles behind hand-based interaction. And they're using terms that I like, obviously, informed by Don Norman. So affordances, signifiers, and feedback, some of the core design principles that we often teach, or at least hear about when it comes to user experience and interaction design. For example, then talking about how to constrain inputs to improve usability, so the degrees of freedom, which can actually be very useful, but sometimes you don't want to move objects along all axes, and talking about some of those things. Also sending this reminder that hands aren't controllers, and so you should design differently for hands if you previously did controller-based VR interaction, then there's quite a few things you need to adapt. And really cool illustrations here. So overall, quite a few helpful tips and very useful illustrations. talking about both their principles and interaction styles, and then also talking about user interface components, really bringing it down from the theory to the practice, and then specifically for the Oculus platform, which I think is pretty useful, even though it is obviously vendor driven and platform driven. Many of these things could still translate to other platforms as well. So our next example is augmented reality guidelines from Google, AR Core. I really like those because really useful illustrations and to the point, telling us a little bit about how AR Core works and how to think about environmental limitations, both in terms of like obstacles that could be there for users and also where the platform has trouble actually detecting and recognizing different types of surfaces. So sometimes to do with lighting or reflection, really that makes it hard. And then a few practical tips regarding how to design an AR experience. Are you designing for tabletop? Are you designing for a room scale or a world scale experience? And then ideas of how to promote interactions and communicate where interactions can take place. So surface detection and visualizing surfaces, and then also adapting to the available play area, talking about how to promote users' exploration and potentially having fun, talking about different types of movement, and how you actually have control a little bit through visual cues. You really have, even though obviously AR and VR are really about agency and giving autonomy to users, as a designer, you still have a lot of influence over how users move and interact. And you can drive that through visual cues and audio cues. And you can also combine these in useful ways to address accessibility issues. And as I said, safety and comfort is really at the core of most guidelines. And what I like here about some of the ones from Google is that they illustrate really to the point. Like, what are the things you want to avoid? Don't have people move backwards, for example. And talking about realism and how to achieve more realism through modeling, texturing, and then material design. Really good tips also for XR designers who don't necessarily have a 3D design and modeling background. Cool examples in comparison. So really quite useful reference here in terms of design guidelines and to the point. Our next example is a specification and some guidelines around WebXR. In this case, authored and edited by Mozilla. And so the WebXR specification is still evolving. And even when you look at this draft, you will still find portions that are unwritten, but really useful illustrations around how tracking works, how headsets for VR work, stereoscopy, and designing for virtual reality and physical risks. So motion sickness or virtual reality sickness, they call it here, and physical risks. And earlier versions of these guidelines had really concrete values in terms of like where you should place, for example, text, and really emphasizing the fact that you shouldn't move the virtual camera unless the user really wants it, and then thinking about fading in and out to or blurring the periphery in order to reduce motion sickness. What I really like about this document here is the approach it takes towards cross-platform and thinking about both AR and VR, and then coming down to basically what's common, which is virtual cameras, and how you manipulate the view, and how you can basically achieve kinds of effects that are similar to filmmaking with good illustrations, so it actually helps us understand a lot of the material better. So I think this is a unique aspect to some of these guidelines. A little technical maybe for the taste of some designers, but overall I'd say pretty good and still evolving guidelines, helpful for cross-platform, web-based, AR and VR. So this is going to be a very useful resource for us in the future as well. So these were just three examples, one from Oculus focused on VR, and one from Google AR Core focused on smartphone-based, handheld AR, markerless in this case. And then also an example from Mozilla, which is really at this intersection of platforms and focused more on the WebXR standard, and as I said, a little bit more technical. So just reviewing these guidelines, we can see a lot of the interesting challenges that there are right now about these guidelines. These were all relatively practical and to the point examples. I've seen a lot more vague guidelines. So here's the trouble that I have with a lot of the XR design guidelines. And again, keep in mind that I showed some really good examples here, so I'm not critiquing those specifically. At the core, we really don't have established best practices. They are actually really rapidly evolving still. XR design is still a moving target, lots to still learn about it. There's a lot of research and design going on in the space. We only have very slowly emerging, if at all, design patterns. And then those patterns really often change with a new OS update. I've seen this with Oculus multiple times, for example. And then we already have major differences between device platforms. So even when you look at VR devices and compare Oculus and Vive guidelines, or when you look at AR guidelines and look at the Apple ones and the Google ones for ARKit and AR Core, you really see quite a big gap and major differences between some of these platforms. So not only between AR and VR as platforms, but also between different vendors and providers. At the core, however, they all agree that obviously designing for comfort and safety is really, really important. So I would say there is a problem still with scoping guidelines. Just in the examples I shared, some of them were quite technical, so the Oculus and the Mozilla ones. The ones from Apple and the ones from Google were a little bit more high level, like keep the user safe and comfortable. That's not, I mean, they then went into some of the detail. So this is more like a principle than a guideline. And so overall, it's a little tricky at the moment to figure out really what's the best way to scope and present guidelines. Many of them are to application or device or vendor specific. So in the absence of a lot of really clear and established guidelines, I would just say that the best guidelines come from learning by doing. And it is really important that you test your designs early and often and learn from your own mistakes. Realize that you made a mistake when you test it with users. And then I think at the core, it's still important to mind the differences between VR and AR. So really designing a virtual world, but still taking care of the physical world, and then augmenting, enhancing the virtual world with AR. And maybe less of a focus on the differences between specific devices and vendors. In the end, we really need to figure out what are the good things to do in VR and what are the good things to do in AR, and what should we really avoid. So keeping with this idea of learning by doing, I wanted to add two more examples here. One is actually taking some of the Google AR design guidelines and putting it into AR, allowing you to explore in situ, basically in front of you, what some of these guidelines actually mean. It's an interesting example of storytelling in AR and for the purpose of learning and educating designers, so I really like it. Here, for example, illustrating nicely the differences between table scale, room scale, and then world scale. Okay. And how to communicate the size or the scale of the experience already in the App Store so that people know before they download and run an app. And then how to deal with the size of objects and how, this is really quite a cute example with his dinosaur that constantly wants your attention. But I mean, it's really hard to keep him in view, him or her. And so they also talk about how to use the size of objects and the fact that parts of them are hidden to encourage users to move around and explore more of the AR experience. They also show how to design a multiplayer AR experience and what to pay attention to. And here I really had to, I just like couldn't really see what they were doing on their smartphones, these two characters. So I had to interfere a little bit and go in there. In the end, turned out they were playing chess and they were exchanging spatial anchors as a form of calibration to agree on a shared coordinate system. And that's something they'll tell you about, and I think it's really quite cool. So it's really a playful way of exploring design guidelines and actually seeing the effect as you're learning about these guidelines. So I really like how they have taken these guidelines that we browsed earlier and looked at on the screen, and now we can learn about it in the world. Now here's the example with this idea of promoting users' movement, allowing them to explore more and creating enticing, captivating, immersive AR experiences just through the size of objects. And this froggy is really quite cute. So another great way to learn about XR design is through some of the examples that are out there. So here we're looking at the hand interactions example as part of the mixed reality toolkit from Microsoft. And so I think it's just great to see an example of all the kinds of widgets and how to design a scene and lay it out in front of the user, and then label each of these widgets and going through all the design options. So these examples are super practical, especially when it comes to digital prototyping and implementation. So even more concrete than some of the previous examples. So this is also focused on hand interactions and really telling you all about the different kinds of ways in which we can use hand interactions to support zoom and scrolling, and then translation of objects, and then hand tracking also to play the piano, although that experience is not as great as it looks because it's really lacking the tangible aspect and haptic feedback. It's great to see those examples of buttons and relatively common user interface widgets like the slider here and the buttons earlier. So it's really great to see how the hand interactions can be configured, and then how, for example, a 3D model like the Earth and Earth's core here can be annotated with labels and what that would look like. And it's really a nice little scene that allows us to explore various examples, including traditional buttons and more Unity user interface examples that would also work, but they really feel quite different. And just seeing them mixed in here also suggests to designers, well, first of all, this is possible, but second of all, the experience is quite different and maybe you should not mix them. Although this is a little bit implicit and probably more based on my experience than explicitly stated in this example. Anyway, it's a great example for us to learn and explore, just like the one I showed earlier, Google's AR Elements that you can run on your smartphone, and this one here runs on HoloLens 2, the Mixed Reality Toolkit hand interactions example. So having those pre-built scenes and examples is just a very good way to learn about AR, VR design. So over the past few years, I've really worked on quite a few AR and VR projects, and I was thinking about what kinds of guidelines could I share with you, my attempt of making it concrete and hopefully useful and less vendor and platform specific and more focused on really the issues that I see in XR design. And I've classified it into the do's and the don'ts, and we're going to go over them. So here they are. Really, it's like a list. You can just explore it, and I'll walk you over each of these issues. So first I talk about offer alternative ways to travel. So what I mean by this is, like, for example, allowing users to travel to places through a menu, or through gaze-based interaction by clicking locations in the world and landmarks, or different kinds of teleportation. But what you should really try to avoid is to move users without their input. So you should really not move them unless they indicated they want to be moved. It would feel really awkward. The other thing that's also weird is if the virtual character is moving and the user is actually sitting, so it really conflicts with proprioception, so our understanding of what our nerves and senses are actually doing. I think you should use interface metaphors as much as possible, but you should also pay attention to using modern interface metaphors. It's really important not to try to reinvent reality. So I know the idea of virtual reality is sometimes to port you into this completely different space, but if that space doesn't adhere to physics and any kinds of things that we know from the real world, what's the point of calling it a virtual reality? Now, you can actually change gravity and all those kinds of aspects, but the basic laws of physics should still apply. It should still feel like a world that is known to us and familiar to us. I think you should also make as much use as possible of physical affordances to really communicate to users how they can pick up an object and whether an object can be moved, rotated, and scaled or not. I think after pickup, obviously providing feedback, but these initial physical affordances are really important to allow users to confidently explore an AR or VR scene. I would caution and advise against this idea of making it a copy of the real world. So an example I share with you later is stairs. So I've really thought a lot about why we have stairs in virtual reality, for example. I mean, we can teleport, we can use a menu to get to places. Why do we have stairs? And I think it has to do with this idea of physical affordances to communicate to us. There is actually a level that you can go up or down, and just helps us read the space and understand the environment. So I get that, but really think about the amount of stairs we need to navigate, and that stairs are actually really not accessible in the virtual world and also not in the physical world, as you know. You should minimize or reduce the amount of required explicit interactions. So a user doesn't really want to have to speak a lot of voice commands, or repeatedly perform a very specific set of gestures. I think the hand interaction example I just showed from the HoloLens Mixed Reality Toolkit 2, I think it's great because there's a lot of implicit camera-based interactions, and then grabbing a slider and then moving it, but being able to going out of that position, so not having to hold it and just continue. I think those are great examples of reducing ergonomic effort on users, so I think that is really important. Also, don't rely on gestures or speech. So I've seen a lot of user interfaces where everything was gesture-based and no way of using speech, or the other way around, where everything was voice-based commands, and then some of the more traditional gestures that you would expect for scaling, rotating, etc. elements didn't work. So the challenge is really to find the balance between explicit and implicit interactions, and then also within the explicit interaction space, the amount of gestures, speech, and multimodal. So I think that's still quite a challenge. So here's a relatively standard one, but I think it's important. Put important elements in the foreground, avoid the periphery. And so many people talk about this. I really just think it's 2D screen-based design. You put everything that's important above the fold. You lose people the more they have to scroll in interfaces. And this applies to AR, VR as well. Really don't have users read a lot of text, and I'm going to come back to that one because I think it's fundamental, and I'll show you examples of how bad this actually is in AR and in VR. Provide visual and audio cues to guide users through tasks. So don't just rely on one sense, really use this mix. I've seen a lot of VR experiences that are really visual and no audio, and audio makes such a big difference. On the AR side, if you're working on a smartphone, users often choose to maybe mute their phones, so maybe not as important. But in general, I think you should aim again for this mix, and having both types of cues really influence how users navigate an interface and operate an interface. And finally, but this one should be relatively clear anyway, but it still happens. I've seen it in a lot of interfaces. So don't remap the controller buttons just because the interface is now in a different mode. It's really difficult for users to relearn all the functions and then remember which mode they're in. And really try to avoid breaking any kinds of design conventions or going against mainstream unless you're really confident about your design choice, in which case I would encourage you to go about it and maybe you revolutionize design that way. But most of the time it really doesn't actually support design and makes it really hard for users as well. So we've covered a lot of the do's and don'ts based on my experience, and that experience is coming from doing a lot of research in that space and then also teaching a lot of students about XR design and obviously operating a lot of AR, VR applications myself. But while I strongly believe that these are good guidelines, it's just a starting point. It's just based on my experience, and maybe there are people out there that disagree. But overall, as a starting point, I think you can apply those guidelines. Look at your designs and then look at these guidelines as a checklist and see how many do's you have done and how many don'ts you have done, and then think about ways of avoiding the don'ts, which I think might be a good way to improve design. So still thinking about design guidelines, I wanted to look at an example. And I chose a recent experience that I had when I was attending the IEEE Virtual Reality Conference in 2020, which was supposed to happen in Atlanta, but due to COVID-19 had to move to remote and online. And we're going to look at some of their spaces that they have created, some of the virtual environments that they have created. And I have invited my student here, Shweta, who is going to join me in some of these discussions and explorations as well. And a couple of the things we're going to do is we're going to climb some stairs, which I think leads to interesting issues. We're going to explore the world, going for a walk together, and then you will also see me picking avatars and looking at a lot of text. And then we're going to review some of the design decisions, and I'm going to compile a few more tips and maybe guidelines, if you will, to also avoid those things in the future. So here I'm looking down the venue. This is the stage that they have, and I'm waiting for my student Shweta. There she is, and I see her, and I can see how she is essentially trying to make her way up. So they have designed this stage so that you start in the back where you have a little bit of privacy. In some sense, you don't hear the speakers and can have a chat, and then others won't hear you in that area if they're up here on that stage. So that's good, but you then actually have to climb those stairs, and these stairs are really not accessible no matter whether using a keyboard and mouse like I do here in this example, or a VR headset, which I'll do in some of the other examples in the future. So stairs really is an interesting issue to me, and something we should think about more and potentially avoid as much as possible. And so then I was thinking, okay, let's explore a little bit more of this venue. And I decided, we were attending this conference for a while, and then I said to Shweta, hey, why don't we go for a walk and explore some of their bigger virtual spaces? And so we ended up on this Georgia Tech campus. Now, I haven't actually been to the Georgia Tech campus, so I don't know how much it really resembles reality. But I could imagine that unless they had a major investment, it probably doesn't look like this. So in many ways, they reinvented reality here and that makes sense. I mean, I guess. I mean, the big B and some of these virtual screens floating around. So it's an interesting mix of, like, this is a selfie from Blair, one of the organizers, and a friend who I hope doesn't mind that I'll critique and review this a little bit to look at our guidelines and which of these can apply. And then we were going for a walk, and there were some issues again. It's a ramp here, it's not stairs, but I could teleport with my mouse pretty easily, and then Shweta was using a MacBook and didn't have right click, so she couldn't actually navigate the space with mouse and teleport, so I had to walk all the way. And
For a novice user, Shweta is not a novice user, but for somebody who explores such a world and VR for their first time, figuring out how to move in a space when it's unclear and that you have this option potentially of teleporting if it's available, that is actually really quite an important step. And obviously, the more experience you have in these spaces, the more of that experience translates between spaces and experiences, and so maybe it won't be so much of an issue later. But onboarding is really quite difficult still. And then this is really, it's an interesting example because I really don't get a good sense of what the Georgia Tech campus looks like. Apart from a few billboards and text here. And now that text is okay. The way it's placed is actually quite well done. It's on a billboard. It has sufficient contrast. It's not just floating. I'll have another example later that I think is pretty bad. Then we were walking around a little bit more, exploring some of the other spaces, ending up at a campfire, which was really quite an interesting atmosphere. The way you navigate those spaces was interesting. So one of these tiles was actually a portal into a different world. So there's a little bit of inconsistency here in terms of the content that you see on the walls. So some of it is actually video, some of it is text, and some of this can be played, I guess, or not. So it's really quite a lot of stuff going on. And then, as I said, one of those tiles actually functions as a portal into different spaces. So I do like that they illustrate a lot of the content here and some of the hard work that really went behind creating this experience and this online conference, essentially. So why did I pick this example? Because I think it really allows us to review some of the guidelines, this idea of not really copy-pasting reality, offering alternative ways of navigating, making use of established interface metaphors, and limiting the amount of explicit interaction. And I was really stuck on the stairs example and the platform that I was talking about, just because while it was good in terms of physical affordances, that I understood that I can get to a different part of this virtual world and I can navigate up and down or further away. It really reintroduced all these known accessibility issues from the physical world, and that's just like a big problem in an experience like this. So when you go to a conference like this, you really want to learn what kinds of things are actually available, what sessions are on. And also here they kind of replicated the real world, which usually you have some kind of handout or some kind of boards. Somebody from the community created this room, essentially putting these program information sheets into the virtual world here. But it's really a lot of text and hard to navigate, to the extent that I'm like almost bumping into it. And it really wasn't that helpful after all. The main purpose was not to have to leave the virtual reality experience. It was a quick fix because a lot of people felt like, oh, I'll always have to jump back to the virtual reality website, and but I just want this information in VR. So transitioning in and out of VR is still an issue, and it's very disruptive to the user experience. So I get it. But the way we deal with text here is not ideal. So why do I say this? I want to show you two examples. One is in VR and one is in AR. And we're going to talk about the format and the layout of the text. And I'm just using some standard text with as little format and layout as possible. And then I'll show you the different experiences in VR and AR. So my first example is lorem ipsum larem placeholder text in VR, and I just really placed it into the scene, and you can see it in stereoscopic view here, and it's really hard for me to actually view it at any one time. And then this idea of using your hands and fingers as reading aid only partially works with this really big VR controller here. Now that may improve a little bit with hand tracking, but it's still kind of an issue. So here I'm showing you an augmented reality example where I inserted the same text in the studio, and there happens to be this light source that I obviously need to lit the scene and make sure that you can see me on camera. But and this could be just the sun in the real world. It really introduces a lot of issues with reading this text and just seeing it. So really, you need to pay attention to the environment, both the virtual and the physical. The distance of the text is kind of okay. I put it at 1 meter away. It shouldn't be further away than 2 meters, is what people say. The scale is still a little big for my taste, but if I scale it down, it really introduces new issues. So text in general, there is no really good solution. It would need to be adaptive, I guess, and know a lot about the user and maybe their prescription and all kinds of things. So just try to avoid it. And again, reading aids here, like using my finger. My finger appears behind the screen just because we don't actually, in this example, have finger-based or a hand occlusion and figure-based occlusion. Now we're getting there and improving some of this, but it's not available on all platforms. And even then, I don't think this part of improving the technology would actually solve the issue. So my last example is avatars. So let's think about the design space that we have in terms of avatars. I show 2 examples here. One is with permission from my friend Jeremy Nelson, who appears in his kind of like reconstructed avatar. All he did was upload a photo to Spatial, a meeting kind of software. So that's what you see on the right. And then on the left, you see some of the avatars that are used, for example, in Mozilla Hubs, and those are the ones that I chose from when I was actually going to the IEEE VR conference. So when you compare those types of avatars, you definitely see that the ones on the left are more abstract but appear to be more consistent, and the one on the right are more realistic. But there were some issues with the scale and the position of Jeremy. So he appeared in my desk, for example, and I always look down on him, which normally isn't the case. We are almost the same height, so it was a little disturbing and confusing. Now these things will probably be improved in the future, but sometimes the more abstract avatars are actually just good enough, and we don't necessarily need to recreate the whole reality just because we have all these tracking issues, which are then even worse. The closer you are into reality, the higher your expectations are, and the more disruptive the user experience is if something goes wrong. You know, if this little avatar on the left doesn't move properly, that's weird, but it's okay. But if Jeremy's arms or legs bend in a weird way, you don't want to imagine that. So here I'm going to show an example of where I chose my avatar and wasn't happy initially. I was going to this conference. It was a little funny because I did spend quite some time on my outfit and choosing. There was one particular character I was looking for. It was kind of like this Iron Man looking metal guy, and I think I found him on the last page, but this was probably the closest, or it wasn't available. That was also disappointing, that an avatar that I used to use was not available in this specific experience, and so it really, in terms of consistency, was a little disruptive. So these were some of the examples that I put together for you to illustrate some of the guidelines. I didn't have an example for each and every guideline, but take a look at them, explore them in a little bit more detail, and again, as I said, use them as a checklist to understand and identify opportunities for improvement to your XR designs. And again, treat them as a starting point. Maybe you disagree, that's fine. Maybe you have a particular example where this guideline doesn't really apply, so the rule doesn't apply. But I think it's important that we have some kind of guidelines. These are the ones that formed in my head over a few years of working with novice designers, particularly students, and then also based on my own experience, like going to this IEEE VR conference. And I don't want to be too negative. Obviously, it was a cool experience. But as a designer, when you look at some of the artifacts created that way, like the virtual environments that we looked at, and really they didn't have a lot of time. They had to put this together very quickly, and I assume little user testing, and then working with this new medium in VR for conferences is still pretty new. So all that is obviously clear, so I'm not attacking them in that way. It's just a great example to study how much do you want to push the realism and this trade-off between making it like a reality and then all the issues that come with it when you don't actually live up to that expectation, when you actually break the illusions, be it through your design and some shortcomings of it, or maybe issues with the technology like limited tracking or other kinds of issues. So I'm going to leave this video a little bit more open-ended, just because I do think that these guidelines still need to evolve, and at least now we have a way to think about guidelines and how to assess the source of guidelines and when they apply and don't apply. So I'm going to leave you there and think about the stairs, which still I think it is fascinating to me. And if you get to this stage where you start obsessing about some of these design decisions and why things are there, so questioning some of the design decisions, then I think it shows that you're starting to think critically about design, and that is a really good thing, and that would make me proud if that's what I have accomplished today with this lecture.
In this video, we're going to talk about XR design jams. Now, design jams are like hackathons, just that they don't last like an entire weekend or whatever you may have heard of hackathons. In my mind, a design jam is like coming together, solving a design task collaboratively over the time span of perhaps like 3 hours. And it's actually really a cool activity. Now, the key idea behind design jams is to bring together stakeholders that might benefit from whatever it is that you're designing. So these stakeholders include some of your target users, but also maybe members of your design team as well. In fact, I've done some of the coolest design jams in my own research and also work as a professor, so in the classroom, when I've actually involved other clients and members of my own research team. So pretty cool. And that's what we're going to learn about today. I'm going to share a few lessons. I'm going to talk about both from the perspective of planning and running a design jam, and then also participating in a design jam. So we're still exploring how to do XR design, and I've already covered design guidelines and critiques. And now we're talking about design jams, and design jams are really about getting your hands dirty, and so creating your own XR designs. That's what we're going to talk about. So, as I said, I've done a lot of design jams in my research in the past. So this is one of the first ones I've done when I joined the University of Michigan. It was around a project called Proto-AR. I really wanted to learn how to make design jams more physical and bring AR, VR into design jams, and actually provide also digital tools that help the students transition more quickly from physical, so from paper to digital, so into a tool called Proto-AR. And I'll link it in the references and resources. If you want, you can read about it. There's a paper about it as well. So, but that's just one project. We've, over the years, used it in many different ones. So this one is 360 Proto, which is essentially a follow-up of Proto-AR. So the idea was to still build this system that would help designers create interactive AR/VR prototypes now using paper. Just paper and specific templates. And so this design jam then, for example, involved paper prototyping and then also AR/VR devices directly. As you can see here, a preview on a Google Cardboard. So basically you just take a picture of your prototype on the left that you see on the left, and then it'll appear in your smartphone when you put it into a Google Cardboard. And we've also used design jams to design more complex systems together with students and also clients. I show here an example where we invited students. Actually, all of these students then ended up working in my research labs. So it's also a very powerful and useful recruiting tool to actually attract new talent to your research or design teams. So let's try to define design jams a little bit. What are the main ingredients? So whenever I design a design jam, I think of the goals. The tasks, so really what do I want my participants to do, what do we want to learn about, what should they deliver. So each of these tasks should somehow lead to a clearly specified deliverable. Which kinds of AR, VR devices are we going to involve? What tools do I provide to my participants? So is it just
physical materials like paper, transparency, cardboard, Play-Doh? Those are tools. Is it specific paper templates? Still tools. Or is it any kind of digital tools and then paired with some kind of devices, for example? Finally, also how much time should we spend? So you should really structure it. Even 3 hours, even though 3 hours sounds like a very long time, this is actually over very quickly. If you do a good design jam, the participants will feel very productive and have a lot of fun. And actually, oftentimes in my classes when I ran design jams, students just didn't want to go home. So that's a cool little side effect as well. So what I thought I'd share is a little bit of a photo story here of a design jam that we've run. So this is the one around Proto-AR that you can read about, as I said. And the way I describe it in the research paper is obviously quite different because the focus of the research was somewhere else. But here you see the typical elements like storyboards, and then we're becoming increasingly physical and mixing in Play-Doh, and then Play-Doh to create 3D models and basically creating 3D scenes. And the task here was to design a furniture placement app similar to IKEA Place. And we also essentially primed the students by showing them existing apps that are similar to what we had in mind. And you get a lot of really cool assets that way, including, for example, really nice furniture. This sofa, even though it's miniature, still has a very special place in our lab. So now I'm going to take the perspective of an organizer of a design jam, and then later I'm going to talk about what it's like more if you're participating in a design jam. So let's talk about planning design jams first. So the first thing I always do is actually I start by thinking about who should participate. Who am I actually designing this design jam for? Obviously you can make it open for everyone, but a focus group approach. So really like being more selective in terms of like what kind of experience do you want your participants to have, how broad and diverse should it be, or should it target specific technical skills or specific domains. That is going to really significantly impact how the whole design jam is going to go and the data and the results that it's going to produce. I also think about what happens before the design jam and then also after the design jam. Obviously, most of my tips will be about the during, so why you're doing the design jam, but it's important to really think about, are there any tasks that participants should do before or even after design jams? So as an example, you might ask participants to fill in a background questionnaire before or after a design jam so that you can focus the design jam time really on the actual prototyping. And if you do it before, it can also be a recruitment tool that way and allow you to select participants. You should really think about the data you want to collect about your participants, and I usually treat design jams part of my research projects, and therefore I get IRB approval. And so it's very important to think about what kind of data you're going to collect and how you're going to protect the rights of your participants, how you're going to de-identify and anonymize data, etc. And while the design jam should feel like a really fun activity, there could still be a relatively strict protocol behind the scenes to make sure that you're doing it in a rigorous way. So then, and now we're getting closer to the event, and how do I actually now make sure that everybody I bring in, if it's a rather diverse pool of participants, how do I make sure that everybody is on the same page? And the way I usually do this is I usually start a design jam off by showing something to participants, giving a demo of some kind of AR or VR technology so that they have at least seen it, or a specific type of AR or VR application, and sometimes really even an authoring tool if you're trying to critique something there. So in your case, if you already have something designed, that could be the starting point of the design jam. And you should really provide references and any kinds of materials to participants so that they can refer back to it, because sometimes not everything is clear in the beginning, and then the questions really come throughout the design jam. So it's important to be able to actually go back and have access to those materials. Speaking of materials, it's very important to organize all the materials that you anticipate participants will need to have them ready for them. So you actually have a lot of influence over how efficiently and effectively participants will be able to participate. and contribute. And so that is really the key here. So from doing a lot of design jams, I realized I really have a lot of influence on how quickly and effectively participants are going to navigate the tasks. And so it's really good to plan upfront and have those materials ready for them. So for example, here are all the materials that we provided to participants for this furniture placement in AR design jam. So there was plain paper, no particular templates, but we encouraged participants to think about the scenarios and sketch out storyboards and wireframes. But again, no particular templates at that point yet. And then after some period in the design jam, we introduced Play-Doh so that participants were more focusing their attention on creating and crafting 3D models using Play-Doh, not actual 3D modeling tools. And that allowed everybody to bring in their childhood fun experience, if you will. And what's really fascinating to observe in that particular design jam was how participants were able to do the 3D modeling in parallel to some of the discussion around how to design this mobile AR app. And most of the discussion was really about user flow and how to transition between screens. And so 3D modeling, if you have ever done it, it is actually a really intense task. It's not something you usually do in parallel to discussing some of the other key things. So that was quite fascinating in this design jam. And it's one of those examples that I'd like to share because it really shows the value of design jams to me. This is something I didn't anticipate in advance. I really had a dedicated time slot for 3D modeling with Play-Doh. And then it just like naturally flew into some of the other activities. And so we just let it happen. So this was already leading into the running design jams a little bit. I'm going to give you a few tips here. So I think it's important to start by giving a problem statement. You really don't want your participants to spend most of their time trying to clarify what it is that you want them to do and what the problem really is. And so the problem framing shouldn't be left to them. It should actually be given to them. I think this will save a lot of time and potentially also frustration among participants. And believe me, I'm speaking from experience here because I've made that mistake before. For example, when I was running the Kai 2019 AR VR prototyping design jam, we were designing a remote conference experience app, thinking about AR and VR. And then most of the discussions were like about the tasks and whether remote attendance is actually something that is meaningful and useful, because the community and the participants were from that community. They were really torn and split whether you should go in person or should attend remotely. And I should have anticipated that beforehand, but I really didn't. And so I feel like I should have said, okay, imagine Kai is going to be remote and this is what we're designing for. Bam, and there you go. And associated with that is this next really important tip, which is having a clear design prompt. Make it short and precise. Definitely leave room for novelty and creativity, but also challenge your participants. And then it's very important throughout the design jam to really use a consistent structure. So for each activity, start with a goal, provide participants with a description of each task that they should be doing, unless the approach that they choose is part of what you're trying to figure out. So maybe then you can leave it a little bit loosely specified, but you should really still clearly specify the deliverables. So in a lot of my design jams, the primary deliverable at the end is some kind of video that talks about the evolution and maybe the final prototypes that came out and maybe also some of the design thinking that went behind it. But what I really hope to see in these videos is some kind of creativity and original thinking and a prototype that helps me imagine what the participants were envisioning. So now that we have specified the problem, gave them a clear prompt, and we have paid attention to a consistent structure throughout, at the end of the design jam, it's also really important to think about what kind of feedback do you want to collect from participants. There should be normally some kind of debriefing. I often do some kind of discussion round in combination maybe with a more individual feedback questionnaire, so that participants can answer questions and also share their experience and maybe make suggestions for improvement. because I often run design jams multiple times with different participants, and so I can improve iteratively basically the design jam as its own little design and design product. Throughout the design jam, I think from a facilitation perspective, it's very important that you don't just do it by yourself. You have a little bit of a team. I often work with students and research assistants, and they help me with timekeeping and also answering questions and taking observational notes. So it's really important to plan this before you actually do it. So maybe do a dry run, and that can be a lot of fun, and you can figure out and iron out some of the issues. And then I said it's important to collect feedback. So I often design a one-page, that's important, feedback questionnaire, and I'll start with the questions that are most relevant to our project, in this case around the research that we were doing, and the demographic stuff I leave for later. You usually want to collect both types of information, but and then the middle portion here is really an opportunity to provide more open-ended feedback. But even with the open-ended feedback, I usually tell my participants how many items of feedback we are roughly looking for, so 2 pros, 2 cons of this experience, for example. So now we're switching perspectives, and now we're thinking about participating in design jams. Here's a few tips that I usually give my students in my classes, because obviously there's a lot of design jams out there, a lot of companies run design jams, and especially in the AR/VR space, and it's sometimes, as I said, used as a recruitment tool as well, so you really want to do well here. And so here I've collected a few tips through my own observations over the years, running lots of design jams, as I said, in research, in my lab, and then also in teaching in the classroom. I'm going to go quickly over each of these principles and almost read them out to you, but I think they should basically stand for themselves. Making a plan is crucial, so really distribute the rules and let them evolve, these rules, okay? Sketch to brainstorm. Don't just brainstorm, sketch. It's very important. I've seen a lot of design jams where basically you just talk, and nothing happens, nothing comes to paper. But paper is such an important medium to communicate ideas, so I really always emphasize this idea of sketching to ideate, not just brainstorming and thinking bubbles, which I cannot really see. Make use of space. So this is be physical, be visual, be creative. Divide the workload. So not everything has to be done in parallel. Try to identify opportunities to divide the labor and then maybe take turns so that nobody gets bored, and really use the facilitator. So one person that really pushes the team, because most design jams are time limited and structured into several sections. So it helps to move forward and actually be efficient as a team. And then the key deliverables is something you should really decide on. So I'll list a few examples here, but not each of them are important. And if you have taken standard user experience design or interaction design classes, you really start with scenarios, personas, competitors. And yes, I've talked about that as well. But I think really just get down to sketching, quickly sort out your storyboards, maybe prototype something physically if you have the time. Do a digital prototype if that is something that would be of benefit and seems doable to you, but really be creative. And then, as I said, in most of my design jams, usually the product is a video. And that video, if you have a little bit of time for editing and cutting, not so much the music, but like really focusing on the details, so cutting off the things that would be distracting. Don't focus on nice video overlays and title slides and all this kind of stuff. No, keep it kind of so that it's like ad hoc. You feel like you're there, you're part of that experience, you see that prototype for yourself, even though it's just a video. So keep it dynamic and don't make it too professional. And then throughout the design jam, one of the really, really important things I cannot emphasize enough is that you should really experiment. Try out alternative design ideas. You can do this through parallel prototyping and then maybe choose some of the best ideas, but don't judge immediately. let everybody see a little bit and come together. So these are some of the best ways I've seen teams organize themselves. And then when it comes to documenting design, you should really think of documenting the evolution. So don't just take the pictures at the end when you're like really proud of what you've accomplished and maybe you've won something and there's reasons to celebrate. Or even if you haven't won, there's always reasons to celebrate. So don't just take pictures at the end. And then this is like from the heart. But because I know that companies increasingly see value in design jams, so for example, at UMich and in my lab specifically, lots of companies approach us and want to work with me and my students. And the only way to really do well in these design jams is to practice, practice, practice. So participate in as many design jams as possible. And then in these design jams, don't treat it so much as a competitive kind of activity. Treat it as something collaborative and fun, and try to feel for the boundaries, or the end of the envelope, if you will, by soliciting feedback from other teams, basically your competitors, or maybe even some of the organizers. I think this can lead to really cool discussions. I usually observe it with students that they seem to be just focused on their teams, and but it's really actually cool to take a break and look around and see what others are working on, because a lot of the value from these design jams and the best results in these design jams don't just come from sticking within your team and sticking to that specific idea of yours, but kind of like seeing what the others are doing and incorporating some of these elements. Even though it feels like cheating, that's boring and that's creative, and so I wouldn't totally discourage it. So in summary, as a participant, here are a few things you could or really should do. So before you get started, make a little bit of a plan. Think about the time that you have, define your approach, maybe the roles in the team, and then also the milestones, your interpretation of the goals and deliverables. Really think about the scenarios, but maybe don't spend too much time writing them. Just like try to agree verbally or implicitly in some way with your team. So be clear on the users, the agents, and what they're doing. And then another thing that I often observe is then a lot of design prompts and design jam activities seem a little vague, and they're subject to interpretation. So rather than getting frustrated about that, you should see it as an opportunity to make decisions. Not assumptions, but decisions. And then clearly articulate why you have designed something this way, because you were designing for this type of persona, or for this type of context, namely physical environment, etc. So make decisions in your scenarios and throughout all the activities. Yes, you could use personas, and if you do, then obviously they would just be used as a tool to communicate who you are designing for, and importantly, who you're not designing for. Storyboards, I think, are really key. For that, and I'll show you in some of the physical prototyping activities, we actually have specific AR/VR templates, and I think it's often a good idea to use some templates, but then don't just fill in those templates, break out of those templates if it's justified by your design ideas, and push that creativity and novelty edge a little bit. Flesh out the most promising ideas, and then really quickly transition into something that is more tangible, like a physical prototype or maybe even a digital prototype. The physical prototypes will allow you to quickly demo the envisioned interface and associated interactions, and the digital prototype will demonstrate feasibility if you're good with the tools. But I wouldn't just always jump into the digital prototyping, because it's often quite unrealistic to get a really robust and useful prototype. I would often favor the physical over the digital, especially in those design jams. So these were just a few concrete ideas and examples of what you could or should be doing. I think you should decide for yourself and with your team which of these you want to prioritize. You usually can't do all of them, but pick those that really help you learn the most about the problem and then also the solution. So the last thing I would like to say, I said I've used design jams a lot in my research, and every design jam has been different. And there is some kind of really creative part about that methodology that I like. It's very different from a lab-based user study or some kind of controlled experiment, and I really like that creative component, both in terms of like what the participants produce, but also how you run it. I think that's a very valuable part, and I think lots of interesting kinds of data usually come out of these design jams. So both the kinds of prototypes that participants have created, we have analyzed a lot of different ways and learned that way, what kinds of gestures, interactions, speech commands, how do they think about multi-modal interaction, how do they think about VR, how do they think about AR, should our prototype really be an AR or a VR prototype? So all these kinds of things you can really get out of these design jams. It's very, very useful. So think of them as a tool, embed them early and throughout the design of your project. I really can't get enough of design jams, and I hope that's a joy and a passion that you will share with me. In this video, we're going to talk about XR design critiques. So critiquing is a very, very important skill. Design critiques or crits are practiced in many areas, including in architecture. It's quite extensive here. For example, at the University of Michigan, can be quite heated discussion, you might say. It is usually a form of constructive criticism, so basically a thorough review, and you take into account design guidelines and your own experience of creating experiences in that sense. So we're going to talk about the critiquing part. I think the best designers are those that have a critical eye and can see issues in design. And seeing issues is actually really, that's easy. That's the easy part. Formulating a constructive critique that includes elements of improvement. So not just like no, but also here is a different way to think about it, or why don't you try this? So I'm going to introduce you to a little bit of that mindset that I adopt, even though I can actually be quite critical, but also with my own work. But I think ultimately the idea is to generate feedback. And so the other part of critique that we don't really talk so much about is, and that actually makes a very good designer as well, is the ability to address feedback and to react and respond to feedback. If you have access to a smartphone that is compatible with Google Cardboard or any derivatives, I'll show you a version of Cardboard that I'm using, which is actually made of plastic. Or you can use the AR mode. So Expeditions actually runs on both iOS and Android phones, so you do need a little bit of a later generation smartphone model here, but we should be able to work with Google Expeditions. So I'm going to do a critique now of Google Expeditions, and then I'm going to choose a few specific expeditions. I'm going to focus on VR. I'm going to talk a little bit about 360, so this ability to switch from VR to 360, which I think is actually a great feature. And then I'm going to talk about an AR exhibition, and these are just examples, but think of Expeditions as an app that can actually download different kinds of expeditions. These expeditions can be created by other vendors, so not just Google. And I think this should provide a playground for us to actually practice critiques. Expeditions as a tool has a relatively limited number of features, but it's interesting how these different expeditions implement it. And there are still better ways to do it, and then some not so good ways. And I'll point out some of the more common design issues that I saw across the board as examples. But let's just jump in and get started. Okay, in this video I'm going to do a quick review of Google Expeditions, and so I'm going to launch it here on my phone, and we're going to use Cardboard. And I don't have Cardboard with me right now, so we're going to use this version of Cardboard, which is a IM Cardboard plastic version of Cardboard, and it's really quite cool. So it's quite mobile, and that's it. And it just goes onto my head like this. So I'm going to start Expeditions. I'm going to put it in there as the phone instructs me to do it, and there we are.
And so now it actually looks really nice. I already have this dinosaur here and a really cool kind of like background image. And so what we're gonna do is we're gonna look at the downloaded tours for a sec. I have all these tours that I have downloaded here, and so quite a few. And the one that I wanted to do is the New York City tour. And so this is New York City, and you can see Manhattan here. And there are a couple of landmarks. So now we're looking at the One World Trade Center, which is the World Trade Center Memorial. And then this is the Woolworth Building. And as you move away, I like how it actually gives you these visual cues that you have to go back there to find the target. And we can continue the tour by looking at bridges. And now we're going to find the Manhattan Bridge and the Brooklyn Bridge that we're looking at. And then, so again, the visual cues are cool. And let us just explore something maybe out of sequence or order. But there don't seem to be too many landmarks in this scene. So let's just go to a different scene. So the way you switch scenes is this way. Now we're looking at Middle Upper Manhattan Island. We can scroll here and read more if you want. And Central Park South. Let's go there. That doesn't work. Okay, that one activated, and for some reason the other one didn't work. So let's see whether we can reach it by going next. Okay, it does work. Now that's a little uncomfortable, like so far down. And I mean, you can lean in, but obviously it's not tracked in 6 degrees of freedom, only 3 degrees of freedom. So you can't actually really. This is weird. This kind of like motion. And then the scene doesn't actually react to it, obviously, is a little uncomfortable. And there are other issues here. Sometimes when this other menu comes up, let's see, when does it? It's unclear how to bring up this menu is really unclear to me. And then it is always in the way somehow. It's interfering. So maybe. Again, I don't know how to bring up this menu, and I just know it happens sometimes. It comes and it seems to happen when you move in a certain way. Anyway, and then you can explore different scenes here, and we get an overview of all the scenes. And we can. I didn't want to click this, so it was an accident. I actually wanted to click this thing, so I have to be careful because I know there is the sunset on the Hudson River one that I wanted to look at and show you. And this is quite a view, isn't it? It is really nice. It's good to have a swivel chair in order to explore this in a safe and fun way. So I wanted to interrupt this critique for a bit, and there was a think aloud, so you could listen to me as I was exploring the app, and I was pointing out some of the confusions I had, and when something was a misclick or I intended something else. So that's actually quite useful. Then this frustration about this menu that doesn't appear, and so I'm going to summarize some of the key issues that I've identified so far. And then we're going to look at a method to actually formulate a critique that starts with the positive and is a little bit more structured. So one thing I've talked about was a little bit of the menus, and that was okay. I mean, there were some issues there with accidentally not hitting this thing and then something else was triggered, but overall it was fine. I talked quite a bit about the menu and scrolling, and I think one of these items didn't work, but okay, that's also okay. And by the way, this is obviously captured in a stereoscopic view, and you could see a little bit of a shift here between the eyes, and that is necessary in order to give you this depth illusion. And then we have the barrel distortion that also adds to this effect of depth. So I was really pointed out quite a few times how I like all the visual cues, like these arrows. They point me towards the direction in which the landmark is that I'm looking for, so I really like that. What was completely absent was any kind of audio cues. I did have it enabled, but I didn't get the narrator to work. There's a narration function in there, so I skipped that part. Maybe it'll work for you. And then I did like the visual targets, and then how the content was placed to it. So, and I pointed out a few more issues, but so let's look at how we can critique better to organize our thoughts a little bit. And so I'm going to introduce you to a template that I often use, and it's actually quite popular. It's used in a lot of design thinking classes, also heavily used in Stanford, where I think it originated, and it's often used in user experience and interaction design classes. So that template is I like, I wish, what if. And it works as follows. You start with what you like about a design, and you really limit it to the top 2 things and really point out something that doesn't feel like you just say something nice to say something nice. No, really pick something that you think that is cool, something that inspired you, something that you would adopt and incorporate into your own practice. I think that makes it a very good way to start a critique. And then you have to transition over into the actual critique, so the criticism portion of the critique. And this is the I wish portion. So what could be improved? Again, focus on 2, don't go forever, don't make it outweigh everything you have talked about when you liked things. Don't use the I like thing to get quickly into the negative. So whenever I go to conferences, it's like, thank you for your presentation, but have you thought about BAM? And so that's like not a good way. This is a standard way of starting a critique, but it's actually quite annoying and it's not really useful. So pick something that you like and then transition over into something that you think needs to be improved. And it's not only because you think that, there should be guidelines or any kind of best practice that you can refer to. Maybe you've read something, maybe there's a scholar who wrote about this, and that gives your critique more credibility, and I think that's important as well. And you should really then come up with ways of improving it, not just saying what needs to be improved, but also suggesting how it can be improved. So that is the what if component, and here I usually still ask for 2. So when I do this in class, and have students present XR interfaces or whatever interfaces to each other. I've done this for many years now. It is often in the form of written feedback, so I have like little paper sheets with just this, asking for 2 likes, so for 2 pros, 2 cons, and 2 suggestions for improvement. And the last part is the one that I think is the most important, but doesn't always receive enough attention. The middle portion always seems to go really well. And the first one I don't think is as strong as I wished it would be. So really, a strong I like, a good I wish, and a really strong what if. That is how you should balance those things. It's really important. Have you tried this? Why don't you try this? I think this could work. And offer some insights and suggestions why you think it might work. Okay, so let's apply this method to the Google Expeditions example that I just showed, and let's try to be quick and like really rapid critique. I like, I wish, what if. So here we go. I like that the visual cues help me find landmarks. This is really good. There was a lack of audio cues, but I didn't say that. I wouldn't say that at this time. I just say I like that the visual cues help me find landmarks. And I also like that the main menu allows me to switch scenes. I think that is a very good way. Now I wish that the affordances and visual feedback and menus were a little bit clearer. So I wished for affordances and visual feedback in menus. I mean, there is something, but it's not enough. And then I also wished there were another way to trigger that main menu. I really just couldn't figure it out. As you could watch me do it, you noticed some of my frustration as well. And so what if? So what if we're going to do the following? We're going to have hot areas around the menu items were marked. So I even suggested that here in a little design improvement, and I think that's a good what if. You could sketch out an improvement, or maybe with a little bit of image manipulation, which I did here, just using some basic overlays. You could suggest how to change the design. And what if the main menu appeared on click and there were no collisions? That would be a great improvement. And the no collisions part, we could maybe figure out where other menus are and make sure that they are not overlapping each other, because that does happen quite a bit, and it can be a little annoying because you don't know which of the menus will actually trigger. It's not always obvious. And keep in mind that we don't actually have a z-axis we can work with. So this is 3 degrees of freedom, so you really just have head rotation. That's all you have. And so you leaning in or out doesn't make a difference. And if this were supported on cardboard, then maybe we could work around the issues with these overlays and the menus. But as it stands, it's an issue, and here are some ways of addressing it. Now I'm going to jump back and continue with a little bit of that example. And I'm going to point out some other features that I think are cool. And I'm not going to do this same I wish, what if method again, but you could imagine doing that yourself. And after the 360 view that I'll introduce you to, I'm also going to show you a few AR examples. And then you could imagine the I wish, what if part. But I think it's just maybe valuable for you to see how I explore the interface and how I critique things as I go. The other thing that this app actually supports, which I think is also pretty cool, is get out of the cardboard VR mode. Let's just put this away for a sec. And then we have a button that essentially gets out of the stereoscopic view and just brings us into a 360 view. And now we can just look around and still enjoy the sunset. And interestingly, so it doesn't work as, it doesn't feel as nice as the VR experience, but it kind of still works. And the nice thing about it is that it remembers states, so you're still in the same scene, you still have the same landmarks activated, and the interactions are still really the same. The text is a little harder to read because everything is a little smaller now. This kind of navigation still works. Still feels awkward to look down onto an object like that, and this transition is how am I supposed to do this transition? Okay, and now I swivel too much, and somebody might feel sick that way. So it's interesting how you navigate these scenes. I would say overall it is a cool experience. There's a lot of expeditions you can explore. I chose the World Cities one here in New York as one example. In the exercise, we're also going to look at the AR version of it, which I think is also pretty cool. Can't do the same expeditions in AR and VR, so I haven't found one that is both available in AR and in VR. But the framework around it, the tool, Expeditions as a tool, or the app around it, is interesting how it works to compare it in AR and in VR. If you only have AR or VR available, so VR, in this case, through a form of cardboard. If you only have one of them available, probably AR is going to be possible for you. Then I would recommend that you explore some of the expeditions and do a design critique of how it is designed, and well, try to apply some of the guidelines, and then also look at it from an ethics perspective. Those are some of the steps we want to do in some of the exercises. So this should be fun, and I hope you learn a lot. And I think there are obviously other applications out there that you could explore as well. But just within Expeditions as an app, there's so many different things we can explore and learn from. So it should be quite cool. So that was the Google Expeditions for VR, and we looked at a cities example, New York here as an example. And that was just one of the expeditions. There are others. I'm now going to switch into AR and show you a little bit how that works. And maybe that's supported on your phone. And please feel free to critique AR or VR experiences. I do think my feedback is a little bit different. It's very much focused on the environment and how it works with placing objects in the physical environment, anchoring, and I noticed quite a few issues around rotation and scaling, which wasn't really supported. Only some kind of translation along the y-axis. That was a little confusing to me. But let's look at this together. It's a think aloud, again, from my perspective. This critique could be reformulated into the I like, I wish, what if method. I would still go and do a think aloud first of any interface that somebody wants you to try out. And then you should summarize your feedback in this I like, I wish, and what if method. We're going to view it in AR. And so here we're going to put it on the floor. This is a skeletal system. And let's look at this guy, pretty big. Yeah, he doesn't look too happy. And just looking at the skull. And that is interesting how it's animated and basically goes apart. Yeah. And then the spine. It's a bit scary, isn't it? And in this case we're going to raise it a little bit, but it should be scaled. Okay. So the AR interactions overall are pretty limited. Expeditions, again, is designed in an interesting way. It's for a classroom use, so you might actually run this in a classroom, so with a set of students and learners. And maybe that is why there is no audio, so that we don't actually have the audio really interfering. That could be a design decision. It was just not really explicitly communicated. And so that's fine. So again, keep in mind that not all of the criticism might be valid here. This is just like based on this one use case of me trying it out in the studio, or you trying it out at home or wherever you are. And consider the fact that it was designed for classroom use, and it actually has a mode where an instructor could use it with a group of students. And that's something to experience as well. And so to close, I would like to highlight a few key points. Again, we should really try to base our critiques on established design guidelines. That makes them more objective, and that's just a very good way to critique. So obviously design guidelines could be based on design principles, so like Norman principles of design, feedback, affordances, mappings, and constraints, whether something follows natural mappings, and whether the affordances, physical affordances, so whether the objects suggest to you how you can interact with them, and constraints as well. You should take into account usability, so learnability, memorability, efficiency, errors, and satisfaction. These are common usability considerations. You should also critique it from the perspective of accessibility and equity. So if an interface uses some of the most advanced features out there that are probably only available on the latest generation headsets, which at this stage are still very expensive, think about whether that is really necessary, and think about the limited reach, because a lot of people may not be able to afford that experience. And that's another thing that I like about Google Expeditions, that it's designed for low-end devices and therefore scales also in the classroom potentially. Think about the audience, so the users, their background, again bring in this idea of personas, and maybe review from that perspective. And then also, to a limited extent, I would say, bring in your personal experience. And finally, you should think about some of the broader concerns that you may have about the experience and the impact that it may have on its users. Here I'm just going to list a few of the common ones. So privacy is a big concern, mental health, physical health, anything that you think has to do with ethical issues. So maybe the degree and the level of realism, and maybe the level of immersion, and whether this could be potentially dangerous. Think about the social impact. Can this experience be used in a classroom or not? Think about those kinds of things. Think about cultural issues that you see in the design. So if I just use sports metaphors from baseball, I would understand nothing. And so it's one of the issues I had when I came to the US, but just a side note here. And any kind of environmental and sustainability concerns. So really be broad also in your review, and address those and bring up those concerns. Just raise them. Can lead to very interesting discussions. Again, welcome to the honors track. This is the XR design critique. This is the exercise that is going to get us started as part of the honors track. So for every exercise, I'll provide a little introduction video. The specific instructions regarding the exercise will be shared through the MOOC, the readings that we have. But this video provides an overview and talks about some of the main steps and why this exercise actually exists. So, design critiques are very important. I'll talk about that in its dedicated lecture. It's a ritual. In fact, in my course, when I teach this residentially, every student has to critique an existing AR/VR app, and it's really cool because when you bring together all these students and they critique these existing apps, everybody learns about existing apps, and also we practice our skills of doing a thoughtful, productive, but also with constructive criticism, a rich critique, something that we can learn from. And so that's what we're trying to exercise here. So I'm going to walk you through the main steps of this exercise. So the task, should you choose to accept it, is to critique an existing expedition-like XR app in 360 VR or AR. So I say this so that we have maximum flexibility. You don't necessarily have to have VR or AR. You can just do it on a smartphone with 360. So, and I say expedition-like XR app. I'm thinking Google Expedition, and I'll tell you a little bit more about Google Expedition in a second. But also, it could be your favorite museum if it has an app, or something for the city, or something that feels like you can go on a tour. I want it to be not too complex an app, but the activity is really to critique it. And if it's too complex, it might probably be one of the main criticisms. So, what I'm thinking in the task should be to record yourself describing the XR experience using Think Aloud. It's very important. So the Think Aloud part is really important. Yeah, you should play around with it, and then you play around with it one more time, and then you record what you're thinking. Even most often the first time impressions are really the ones that are really, really cool to capture in this Think Aloud. But maybe we're not used to this idea of thinking aloud as we're using something. And that's something you have to practice. And I'll show you an example of me doing a Think Aloud while playing around with an existing Google Expedition. I chose the solar system one. I want you to describe the context of your XR experience. So I want you to, well, basically share, when you share the results of your critique, whether you have operated this app in 360, in VR, in AR, have you been in a private or public setting. So if you were, you don't have to be too specific, but I think it may have impact on how you critique the app. Maybe it was not designed for the context in which you used it. And so that's then something that we could also discuss as well. I want you to critique the expedition using the template, the I like, I wish, what if template, okay? So I introduced that in the lecture, and I'm gonna briefly mention it again in the next few slides. I want you to analyze the expedition in terms of guidelines. So really design guidelines first, and I provided some examples of guidelines. I mean, as you know from my lecture, I'm never really happy with all the guidelines we have. We don't have enough guidelines, and those we have are not good enough. So anyway, this is a starting point. I want you to also articulate ethical, social, or privacy concerns one might have. I mean, you might have them, you might not have them. but users could have them, and so I want you to think about that. So the expected results of this activity and this exercise are that you have now provided a balanced critique of positive and negative design aspects. So really start with the positive, remember. You have developed initial ideas for how to change and improve the design. That will be very helpful for you as you're continuing to work on this and go into the next stage, which is storyboarding. And as part of storyboarding, we do brainstorming. And you also have a better sense of what to look for in terms of design guidelines. So that would make me really happy if we achieved all these, if these were really truly the results. So that would be cool. But that's what I'm hoping we get out of this. And if you practice critiques and you really think broadly about some of the concerns, then I think this will be very valuable and might be a lot of fun to also discuss with your peer learners here. So please, we'll have forums available and we can chat. So I said the expedition that I had in mind, the actual app is Google Expeditions. So now Google Expeditions comes in VR and in AR, and it's actually popular in classroom environments. So Google is targeting education scenarios, and I thought this is a good app for us. But I say expedition-like. It could be really anything, but I don't want it to be too complicated. Ideally, it's publicly available so that others can actually also try it out. So you should be clear how you obtained the app if it wasn't Google Expeditions. So here's an example of me running the World Cities Expedition, and I've covered that in the lecture. And here is a video of me trying it out, actually here in the studio, the solar system app. All right, I'm going to do a design crit, an extra design crit of the Google Expeditions, the exploring the solar system, and we're going to start it in AR. So initially, I think this works quite well. Detects the surface okay, and then the problem is that the planet is like really big that we're getting, and any attempt to resize doesn't work. I can just raise it, but I have not figured out a way to resize or rotate. And that is actually something that I would normally expect from an app. Then you can learn more about the sun, and what we're going to do instead is we're going to look at Earth. So Earth is obviously smaller than the sun, but it's still definitely quite big. And same issue, but I do like the inner planets. So that's like kind of cool when they then appear above the keyboard here. So there's Earth, and we can look at some of the detail, maybe even find parts. Well, maybe you can find where you live, and that could be interesting. And tracking works. Tracking is really robust, obviously, so that's kind of nice. And then the moon, again a monster. Boom! And it's just massive. And we have the outer planets. So that's also pretty cool. And so it would be nice to have labels on these. I really like the look of the planets, but like having labels would be very useful. And so that you're actually learning something. I mean, right now it's kind of cool. The asteroid belt, it kind of looks cool and nice, the dwarf planets. But then you would really want to learn a little bit more. And the interactions here are definitely pretty limited. It does look cool though, I must admit that. So I would say I like the look of the planets. That's pretty cool. And I like how, I especially like the inner planets, and I like how they've broken down the solar system. Although it's harder for me to build the relationships between the different kinds of views that I have on the different
planets and the asteroid belt and the moon's normally obviously going around Earth, so would have been nice to see that. I wished I were able to rescale, resize. So this, I just don't understand why I would want to raise it like crazy. It does make sense when I put it on, when I relocate it, but I also can't relocate it. So I don't know how to do that. Can send feedback. Yeah, so what if you were allowing me to scale it once, and then also, like, I think the other thing is the distance. When I then switch, I'm sure it's gonna just be again. Oh, it does keep in mind what I wanted in terms of distance. Oh, it does. It does not rotate and scale. So that's really my biggest complaint here.
And so here is what you just saw, at least a subset of it. And these are all the screens. So this is the download screen, obviously. Then you enter it, you place it. I didn't have a screenshot for the placing part. And then once you have placed it, you have like this card interface down there. And this edge is really, really key. It suggests that there is more. So you swipe to the left and then you get to see Earth. You can swipe up and you get to see some of the information about Earth. And then you swipe to the left again, you bring up this screen and so forth. And this is how the expedition works. And I want you to critique the expedition app, the expedition-like app that you chose. I want you to use the I like, I wish, what if template. So what you like about it, important to start with something positive. And there should be two positives, okay? What could be improved? And here really try to be specific, try to be objective, not subjective. And what could be improved is one thing, but how would you improve it? How could it be improved? This is really the hard part. This is what we're after here. This will help us develop some new ideas as we are going to improve upon the app. So here are some examples. The look of the planets, that's pretty cool. I think that's something I said in the video. How they have broken down the solar system is something that I liked. I could resize and rotate the planets. I really wished I could. And I could better understand the relationships between planets. It was really just not enough. Like the scale was really unclear. I could adjust the scale and rotation using pinch to zoom. Yeah, that was really confusing to me. I remember the going up and down part. That was weird. Like, why does it only change around the Y? And so how would I improve it? Well, using pinch to zoom, for example, which is a very common gesture. And how could I adjust the distance to the planets? And then the other idea is to adjust the distance to the plane using drag and drop. So that was referring to the fact that once the expedition was placed, I basically had to restart the app. I couldn't figure out how to move it to a different plane. Maybe it is somewhere in the app and I just didn't notice, but then we need to improve upon that aspect. That is called bad usability. If people cannot discover what you can do with the app, then yeah, we have a problem. So this was a review based on the design guidelines using the I like, I wish, what if template. The next thing I want you to do is also to perform an ethics review. And I was talking about design ethics review as part of the XR design ethics lecture. And I was describing these 4 main steps or considerations as part of the review. So the context and situation, the sensory information and data, the processing pipeline, as much as you understand it. I mean, clearly you will not have developed the app, but maybe you are developing an intuition for what goes on behind the scenes, or the app informs you. And this informing part in terms of terms and what you consent to, this is also really key that we want to look at for data ownership and governance. So in my example, that would be that I was using the AR version in the studio here. I was actually the only user in the device vicinity. I mean, my bunny was probably in the background, but we don't know. The sensory information, well, it sees mostly me. It sees the furniture. It does see expensive equipment here. Keep in mind that this equipment is on loan from the University of Michigan, so this is not my own equipment. The surface area of the table and the floor. So altogether, you can obviously you can actually make some sense of this information both for tracking and registration, but then also maybe in a negative way. And so that goes more under the ethics part, obviously. The processing pipelines, I think it's a pretty naive application. It does standard surface detection, doesn't do a lot with spatial mesh. In fact, it doesn't have a spatial mesh. There's no scene understanding. It may build anonymous usage statistics. I don't know about that, but it keeps a library. It keeps track of the different kinds of expeditions I was downloading. There is a teacher mode, which I think is a bit more advanced and multi-user, and that has potentially a more complex processing pipeline and actually will raise additional concerns. Expeditions app manages the downloads, as I was just talking about. There's this library tab. So that's the kind of information that I know. I don't know what they collect, and I also don't know, because these expeditions are actually developed independently. So there are some Google ones, but there are also ones developed by others. It would be interesting to understand the expeditions framework a little bit better and understand what kind of data is actually being collected and shared with those third-party vendors. That's it, right? So we're going to learn a lot about ethics by actually thinking it through, but we're also going to do a design critique more broadly, thinking obviously also about the social and ethical concerns, as I was just talking about, but also thinking a lot about the design and design guidelines. And so pay attention to whether you're doing an AR or a VR expedition or something in between, like 360. Share that with us and fellow learners so that we actually understand your critique better. Let us know how and where you used it and what you found confusing. And well, we should get a first indication of the kinds of things you think you would be improving as you keep working in this honest track on the next steps, which would then be storyboarding and wireframing, really brainstorming new ideas and fleshing them out. In this lecture, we're going to talk about brainstorming and problem framing. Now, in the context of extended reality, so AR and VR, this is really something that is dear to me. I'm not really sure that we are getting it right yet. And I think the problem is that we are not always really addressing the problem. Now, in this lecture, we're going to talk about how to find good problems, how to identify a problem. So in this lecture, I'm going to share 7 techniques to help you innovate. The first technique is what I call ideate, implement, inspect, iterate design cycle. Everything starts from an idea, and you really have to ideate. Part of ideation is actually implementing that thing, creating a prototype, and then inspecting it. And not just you as a designer, although that I think that is the first important thing, but you need to test and validate it with users. And then you iterate. I think that through prototyping we can really learn a lot about the actual problem and not just like about our solution. I use ideation for problem framing, and I think that's a really important realization. And so build prototypes to help you understand what the problem really is, test it with users, and then see how they respond, and iterate to improve your understanding of the problem, and then also like you grasping for that solution. Next technique. This is more like a how to think about things technique. The killer app problem is that you're trying to find that killer app and you're trying to take on too much. So rather than trying to invent that whole new thing, you can also look at something existing, and all you need to do is be creative and novel in one aspect. Actually, novelty and creativity is not the same thing. So in my opinion, and I always say this to my students, being novel is this idea of being the first at doing something. And that claim is actually never a really strong claim, because you could be the first person to do a really, really bad thing, to have a really, really bad idea. Just because you're the first to talk about it, to write about it, to implement it, doesn't make it a good thing in itself. And so being creative, however, means that you're like looking at something and you're trying to you maybe look at it differently, or trying to innovate by coming up with one small new thing. And when I talked about design jams, I already talked about this idea of trying to be creative in how you approach the problem, and how you execute the methods, and how you prototype things, how you implement things. I think that is really cool. That is where you want to be creative. But you don't have to be novel in the whole idea. That's very important. So do this one thing and be disruptive there. The next thing that I want to talk about is really how to frame a problem, and how to kind of verify whether you're asking the right questions. So I'm calling this the problem, promise, premise approach. The first question I'm going to ask you about the thing that you're trying to do is, what is the problem tackled by your XR solution? So if there's no problem, then you don't have a solution. So if you have a hard time telling me what the problem is, then you should rethink it. Also, if you think you know what the problem is, what is hard about it? And why is it important? And here I have a little denomination. Why is it important to you? Because this idea of trying to generally say why something is important, I often struggle with this. But I can tell you why some of the research that I'm working on is at least important to me. Because I observe how people struggle, especially students, how students struggle to learn about design. Because in my research on XR and specifically prototyping tools, I have observed how novice designers really struggle with picking up XR concepts and XR technologies. And that's what at least I cared about. And actually, it turns out that this is really a problem, and a lot of people are trying to innovate in that space. Not always having good ideas, but trying to at least innovate in that space. So this agreement on then there is something that is a problem, that is actually an indicator that you're onto something. And so the next question I'm going to ask you, what is the promise of your XR solution? So what are you offering? Where can XR actually help? And what is your value proposition? And so then I want to scrutinize more this idea of why XR. So what is the premise of your XR solution? Really ask yourself critically and carefully, why can XR solve this? And when I say XR, you should actually be a little clearer and say whether augmented reality or virtual reality is the right approach, and then what are your assumptions? Like with every solution, there's always some kind of assumptions. With every design, we make assumptions. Write the intro first. So if you think about an introduction, now I'm talking about a paper, what goes into that? The problem, and that is more like at a general level. The obstacle, now within that problem there is something more specific that you're trying to address. So that is the obstacle, and you should make it crystal clear. What are you talking about in this bigger problem? And then you should introduce the solution. In essence, not like the whole thing. You have the rest of the paper to describe that, but in essence, the 10,000 feet view, what is the solution here? And then comes the hard part, actually articulating your contribution scientifically. So this is where a lot of people struggle. First year PhD students, as well as old experienced professors, really struggle to nail that contribution. A couple of things that I've observed over the years that really annoy me, and so maybe you should try to stay away from those, because I don't think they're really good arguments to make. We are the first to do this. As I said, doesn't mean that this is a good idea, and it's actually not a very strong argument. It's now or never. It's like, please take my paper now. Yeah, I've seen that a lot, and timeliness is something that the scientific community will really know. You know, if you're trying to solve an old problem, I can tell you, we are probably not making the right progress. And this last thing is, this is probably really speaking just to the scientific community, that the fact that you evaluated your solution, that is not a contribution. It's just expected. We are scientists. So obviously we evaluate our solution, so don't claim it as a contribution. Now I'm done with my rant, and we can continue looking at some of the more design-oriented techniques. So in this lecture, I'm going to share 7 techniques to help you innovate. One technique that I really like is this idea of the idea hexagon, introduced by Ramesh Reska in a lot of his motivational talks, and I really like it. And I want to give some examples from the XR space. So the idea hexagon is basically, given an idea X, what is the next good idea from that idea. One way to innovate is to try to extend to the next dimension. Example C gives is from Flickr, which is images, to YouTube, which is videos. The next way to innovate is to fuse the dissimilar. So X plus Y. And I'm going to have an example here in a second. And then the other way to innovate, which is the one that I really like, is doing the exact opposite of what's been done before. And we're going to see in a second whether you like my XR example here or not. And then comes these, given a hammer, find all the nails, and given a nail, find all the hammers. It's a very popular approach, especially in the technical human-computer interaction design community and research community. This idea of like coming up with a new system and then seeing what this new system or solution, what kinds of problems can it actually solve. So having this idea because you think it's cool, because you think it's creative, because you think we kind of need this, and then see what we can do with it, in my opinion, is actually a very good way to innovate and ideate and do research. But not everybody agrees, so that's fine. The last one that's missing here, and this is actually the one that's done all the time when you look at all the new product announcements, etc., is just adding your favorite adjective. Faster, lighter, better. So these are some examples. And now I'm going to translate this to the XR space. Ta-da, here we go. So taking it to the next dimension, my example here is HoloLens. We've seen a lot of VR things. So for example, Oculus came out. A cool headset, and that was just virtual reality, and all the AR stuff up to this point was relatively limited, and then the HoloLens came out, and then the HoloLens ported us into augmented reality. But this idea that a CEO walks up on stage and says, this is a 5-year mission, we're trying to figure it out, and we need you to help us figure it out, that to me was really cool, and I think it's the right approach. And now we're going to look up there. So here for the X plus Y, so fusion of the dissimilar, my example is the Oculus Link. So for this example, I quickly stole, you see from the back, the Oculus, actually an Oculus, the original Oculus, which is tethered. So, right. So then Quest came out, cool. Now we have it all on device, not tethered, standalone, dedicated headset. Pretty cool. And then we're introducing Oculus Link, right? We're going to give you a USB cable. Initially, you had to buy a specific one, a 3.1 USB so C cable. And what it gives you is it turns your, standalone dedicated into a tethered device and turns your Oculus, Quest into a, essentially a Rift S, which had just come out. But this idea of turning the Quest into an Oculus Rift S because for this one, you really have to optimize your stuff to get it to work on mobile. And for this one, you kind of can throw whatever because you just buy a better computer if it doesn't work. I think that was quite disruptive. And it was actually quite upsetting that this Quest can now be turned into an Oculus Rift S because people just bought the Rift S. And now this one seems to be the one that Oculus is pushing forward, which, we'll see where that goes. Now we're going to jump over here. So cardboard, doing exactly the opposite. So the example that I have here is this kind of plastic version of cardboard, but it's still cardboard, okay? This idea of just doing something like this, a device wrapper, or actually giving you cardboard and putting that on your face and putting your phone inside. That was like the opposite from everything else we had explored at the time. So if you have a hammer, like a smartphone, what are all the things, all the nails you can hit with it? And AR and VR are actually things you can hit with it. Well, because we have a hammer and turning this into an AR or VR display just by wrapping something around it, I thought this was pretty cool. Now, my other example is WebXR down here. So, given a nail, find all the hammers. So let's say if we now do AR and VR, what are all the hammers that could benefit from it? And the web is a hammer that gives access as a platform to a lot of different content. And so bringing AR, VR into the web and empowering the web is just going to take it to the next level. And I think That's why I put WebXR here as an example. And finally, coming back to the Oculus Quest, well, here the idea with the Oculus Quest was just like, okay, we've always had it somehow tethered, and initially the first VR headsets were like really heavy and had to be mounted. So the one adjective maybe to be associated with a headset is mobile and portable and pervasive, if you want. So now I want to jump gears a little bit and look more at innovating in interaction design. So the object control design matrix works as follows. So you're putting out a 10 by 10. I don't actually draw a 10 by 10 matrix here, but the idea is you do a 10 by 10 matrix, and then you're thinking about winter and cold. And then you're putting down all the objects you associate with winter, like snowshoes, gloves, hats, boots, ice scraper. So you're putting those here in the rows, and then in the columns, you're putting all kinds of controls that you can imagine, like slider, voice, pressure control, squeeze, shake, dial, whatever comes to mind. And then you're looking at the combinations of these, and you're sketching out, in each of these little quadrants, you're sketching out all the different little funny combinations that you can come up with, like an ice scraper that can be shaken. Now that would be an interesting device. Now we have a combination of objects that we can control in funny ways. And if you sketch those ideas out, this is really an activity you should do in class. I've done this in a lot of interaction design classes. It's actually quite fun. This idea of pushing it out quickly, like doing really a 10 by 10 matrix, like 100 of these ideas, pushes you to be quick. Sketch them out quickly. Ideate quickly. Don't criticize. Don't spend too much time on shaping this perfect idea. No, just go about it. Try out all these different combinations. That is really cool. Like going all the way through, line by line, diagonally. And I think that is why it's really a valuable technique. It will not always work. Like it works really well for like warming up brainstorming. So translating this directly to coming up with innovative XR interface and interaction design ideas, probably not going to work so well. But as a warm-up in a class or in a workshop, I think this is actually really helpful. One last thing that I want to share here is the threshold and seeding considerations in tool design. Now this is something that comes from a paper from 2000 by Brad Myers and colleagues on the past, present, and future of user interface software tools. And I think it's a really cool way to look at tool design. Now whether you have a new tool, now this could be a user interface design tool or some kind of tool that helps you solve a problem. Let's just call it a tool. And then you look at the whole design space of all the things you could do in XR. And then there is your tool. And then your tool is defined by a threshold. Now that is the barrier of entry that you have to overcome in order to use this tool. So basically all the stuff you have to learn to use the tool. And then the ceiling, which is all the things you can do with this tool but no more. It's like the upper bounds. It's like that's it. All right? Learn all this to get in here, use the tool, and then all you can do with the tool is here. And then there could be so many other things for which you probably need a different tool or some combination of tools. And now that is an interesting consideration given that there's so many different kinds of tools out there, especially all these kinds of prototyping tools that essentially all do the same. But it actually allows you to compare some of the solutions out there, some of the tools out there. And I think it's a really good way of examining whether the effort that you have to put in learning something justifies the kinds of things you can do with it, so the ceiling that you will reach. Now, one of the really popular tools out there in the AR/VR space is Unity. Unity has actually quite a high threshold, like a really high learning curve. Okay, depending on your background, you may have an easier time. But the first time I opened up Unity, I was overwhelmed. But the cool thing about Unity is once you have crossed the threshold, you're in this land. And you can start to learn all the things you can do with Unity. And then I would say I wasn't really sure where to put this ceiling. The ceiling is probably relatively high, but nobody knows the whole design space of XR. And I'm not sure whether I can do everything in XR. Now, in my research, I really try to have a much lower threshold. So I really want more people to be able to pick this tool up or my tools up more quickly. And I'll do a trade-off because obviously I can really not reach the same ceiling as Unity. And I don't even have to because I'm not even trying to replace Unity. Unity has its place in the AR/VR space. And my tools are just helping more people transition into tools like Unity, so empowering more designers. And that is really the idea of my research. So for me, it's okay to make that trade-off. And so basically the ceiling is lower of my tools, but that's fine. But there are also lots of little problems in the design space for which Unity isn't really a good solution because it has so much overhead. You really have to learn so much and then solve that thing. No, you just use a different tool. And so that's why this graphic is probably also useful because there are lots of prototyping tools out there similar to mine, although my emphasis has been on physical to digital transition, which I don't think a lot of tools do very well. And so that's my claim here, okay? Just saying, as a researcher, and that's fine. It's been peer-reviewed, so I can say that. Now, this is an interesting area here. So there is this overlap between some of the things you can do with my tools and some of the things you can do with Unity. And then that's probably is the same thing for a lot of tools out there. You can use a lot of tools to do the same things. Now, obviously, we're not trying to be like Unity. I would never try to do that. So I don't want it. My goal is not to be congruent, to actually be like Unity. No, you don't want to be like that tool. You want to make it simpler. Obviously, the coolest thing we could do is like lower the barrier to entry and then have an even higher ceiling as Unity. And that is really unrealistic. Just like how? If it were possible, Unity would do this. No, I think Unity set that threshold in order to enable you to reach this really high ceiling. But that threshold is unfortunately a little high. But by the time you want to solve all these upper problems, you're already quite committed. So it's an okay cost for them. And so these problems here, well, you can do them with whichever tool. I feel like if you already have the knowledge of my tools, you could just continue using my tools and solve the problems in this space. If you already know Unity, and this is the stuff that you want to solve, there's no need to learn my tools. So it's that simple. You can just look at it that way. And I think it's a really cool way to illustrate the power and the use of tools, and really also estimating how much learning is required in order to pick up a tool, and then again, what you can actually do with a tool. And this knowing what you can actually do with a tool, that is the really hard part, because unfortunately, the tool developers, the vendors, are not always very honest about that. And so that's something we need to improve. So this was a little bit of a fun lecture, but it's actually a really, really important one. And I wanted to give it this a little bit of a fun spin so that you don't see that I'm actually dead serious, but I am. So this lecture is really heartfelt and comes from years of experience as a PhD student myself, really trying to learn how this scientific community works, how to come up with good research problems, which especially in the XR space where so many things are going on is really, really hard. And then also from my teaching experience, both in traditional, relatively boring mobile and web design, interaction design classes, to some of the more advanced courses that I'm teaching now, that I'm fortunate to teach now, to both non-technical and really technical, highly skilled designers and developers. Because I want everybody to be able to participate in this XR design space. So I'm going to introduce you to these two piles of good ideas and bad ideas. And you can use them as a checklist, like the things that I say. If that is true about your idea, then maybe it's a good or a bad idea. Well, I don't want to offend you. I could still be wrong. It's just an intuition that I've developed over the years. So if you can say this about your idea, you're adding a significant new feature to an existing solution, that's a cool idea. Do it. You're doing a complete redesign of a solution? Well, actually, that's not a good idea. Let me fix this. So I'm going to go in here. You're doing a redesign of part of an existing solution. Now that is a good idea. Okay, let's look at it. So you're doing a redesign of part of an existing solution. Don't do the full redesign of something existing. Don't redo Amazon. There's probably something good about it. It's quite popular and stuff. So don't. So if you can say this about your idea, then you probably have a good idea. You're picking one particular aspect of a problem and try a different solution. Now, there's a big problem and maybe lots of solutions out there, but then you're trying to focus on this narrow thing and you're trying it slightly differently. That I think is a really good way. And this is similar to what I'm saying here. You're looking at an existing problem through a new lens. Now you're actually like looking at this whole problem and you're recasting it from this different lens. And now you're not coming up with the same solution, but you're coming up with a slightly different solution. And that solution might be novel or at least innovative in some way, especially if that new lens is really a new lens, like nobody has looked at it this way yet. I mean, that lens is not new, but nobody has actually applied that lens to the problem. Then I think it's a very good way to innovate. And this is actually what a lot of researchers do, and it's actually a very good way to make progress. So, looking at the candidates for bad ideas. So if you can say something like this about your problem or your project, then may not be the best idea. You're just adding a small new feature to an existing solution. You probably agree with this, unless you are the designer of that existing solution, in which case you're creating a new version of it, which is fine. You should really not be saying anything like this about your idea. You're trying to make an existing solution much better. Now, I've heard this all the time. So the problem with the much better part, well, in theory, it's a cool idea, but the problem is if you can't say the much better, if you can't quantify, if you can't specify in which way you're making it much better, then it's really a problem. So a good way to specify something like this would be like, I'm making it easier to learn it, or I'm automating this part, which makes it faster to do that part. And then you're trying to do what multiple existing solutions do in one new solution. Oh, yeah, you're doing the dashboard. Trying to wrap around things and then coming up with this whole new thing that brings everything together and makes it better. Not a good idea. First of all, if that is your project and you're like working in a class or something like this, you have only so and so much time. Actually, every project is time limited. So abandon that and refocus and reshape. Finally, you're trying to do what nobody else has done before. Really? Now, I've heard that so many times, and it's probably never ever true. The problem might be that you don't know whether somebody has done it before, so you haven't done your homework. You haven't read the literature, you haven't tried out the tools, you haven't played around with this existing technology. Maybe you didn't know about it. Well, that's fine. So run your ideas by people. It could be professors, could be other designers in your team, could be your users, your future users, or any kind of stakeholders. And that's a good way to shape and reformulate ideas. Now, if your ideas fall into these categories like the good pile or the bad pile, there's always room for improvement. Doesn't mean that if you're here that it's safe and you'll be fine. Doesn't mean that. You could still have introduce issues as you're executing the ideas. You're not really involving users, for example, when you're designing a new product. Now, maybe you had a really cool idea in the beginning, but you could still mess it up as you're trying to implement that idea. And so now these are not fail-safes or guarantees that your product will be successful. But really, if you're in this pile, you should really reframe your problem. A big problem is really about scope most of the time. You're taking on something too big, like the dashboard thing I just talked about. Rescope, make it smaller. Now, that's a good way to innovate as well, because it's easier to come up with new things in a much more constrained and small problem. Don't make it too small, shouldn't be trivial. That's the other thing that I sometimes complain about when I work with students on projects. So, don't make it too small. There should still be room for exploration, creativity, and in some sense, obviously innovation. And that's what this whole lecture was about. So I hope you enjoyed some of these lessons. In this case, I tried to be a little bit more fun than usual, and we cut this slightly differently. It's supposed to be stimulating and inspiring and not as serious, but there are actually really valuable lessons in here. I think these are cool techniques that help me at least try to innovate and come up with the next research problem. And maybe they'll also help you as you're thinking about the next solution for a real problem and a real XR solution in that space. Now that would be amazing. Storyboarding and wireframing. That's what I'm going to talk about in this segment. These are really important early stage design steps. So I laid out the larger XR prototyping process, storyboarding and wireframing, physical prototyping and digital prototyping. We go through each of these steps, but in this segment, I'm just going to focus on the first one, storyboarding and wireframing. So storyboarding and wireframing, here's what we mean by this. So you basically sketch out the interface ideas that you have and organize those sketches into what we call a storyboard. And a cool element of the sketches is usually when they are a little bit more precise than usual, we call them wireframes. They're actually blueprints of the screens and potentially 3D scenes that we'll see later in our AR/VR interfaces. All right, and what I want to show you here is basically this is from one of our design jams where students were explaining to me how they have been thinking through this prototype of an AR furniture placement app. It was inspired by some of the products that IKEA and Wayfair have out there now. So you could choose between different types of furniture and then rotate, for example, the chair here, and also color and get like real previews of the furniture that you pick with specific choices like color and size through a menu. And so this is how the app would work. What I find interesting about the storyboard is obviously it contains a lot of detail. You can really see how the AR interface blends with the 2D menus that you see on the left and at the bottom. And the students did really do a good job thinking this through. So what we just saw is actually just one example of the types of storyboarding techniques that I'd like to cover. So the way I'm going to do this is I'm going to think these different techniques. I'm going to introduce you to a few techniques here, and I'm going to think them through from low fidelity to high fidelity. And I'm also going to think them through in terms of like what I think is easier to do and what I think is harder, requires more practice and potentially technical skill. So the 4 techniques we're going to cover is storyboarding, which you just saw, so traditional storyboarding, which I think is good for organizing sketches into a story, and into a sequence. We're going to talk about 360 photo stories, where you would essentially use a 360 camera to capture physical space around you, and you treat these physical environments that you capture as like prototypes, as mock-ups of your virtual reality environment. So you actually prototype in the physical space, come in with the camera, capture, and create content that you can later use in VR. Pretty powerful. And then I'm going to talk about 360 storyboarding. This is actually something that I've worked on and looked at in detail in a lot of my own research. I believe in some of these techniques. They're a little bit harder to do, but I think they're actually very powerful, especially if combined with some of the tools that I've been working on. And I'm going to show you why this is a good technique for storyboarding and why it allows you to think around the user, which really, spatially thinking around the user is really important for AR and VR interfaces. Finally, I'm going to cover 3D storyboarding. We're like inside a VR headset and you're sketching out essentially the 3D world around you, which I think is a very good way of visualizing in 3D, but it also requires quite a bit of practice. It's the closest to the final prototype if you want, but it's still a storyboard, so keep that in mind. So now I'm going to walk you over each of these techniques in a little bit more detail. So 360 photo, remember, we're going to use a 360 camera. We're going to capture an environment, like for example my lab in this example. The way it looks initially, very distorted, different types. This is accurate angular projection, so different formats in which these cameras actually capture this. But what you can do with it, you can actually map it into a 3D sphere, and that 3D sphere is essentially around the user. And this is how 360 photos and videos that you may have seen on social media, this is how they actually work. You map it back around the user. Okay, so here we are like in my lab, and you've probably seen these experiences before. So this is 360 photo, and
It was obviously captured at this very position. In this case, it was captured by my former postdoc, Max, in the lab. And it actually shows, it's a capture of when we were just starting out in my lab. We didn't have as much equipment as you can see. You may see later portions in this MOOC specialization where we have a lot more stuff in the lab, and you will not even recognize this anymore. But as you can tell, we could use this 360 photo now and actually prototype a virtual reality application for the lab. We have relatively good understanding of the spatial layout of this room. And we may also even use this as a placeholder for the environment and prototype AR experiences without actually being in that physical location. Okay, and if you now put several of these 360 photos together, you can actually build a story, and that way prototype, for example, what it would be like to walk through campus, like at the University of Michigan, or like finding my lab, finding my office, and those kinds of things. And this is a traditional way of thinking of photo stories, but the way I'd like us to think about it is like as a way of storyboarding interactive experiences. Some of them may involve navigation in this traditional sense. They could also be different steps in a sequence in an interaction technique. So we will spend more time with some of these techniques in the activities that I have designed for you. But this would be 360 photo storyboarding. Okay, so here you can see this 360 photo story in sequence. Basically, Max took these photos, and then he was going down the stairs, and you can like experience that from these different perspectives, and you get a sense for, oh, he's actually walking towards the lab. And this is a pretty standard photo story, the way you could think of it. But each of these 360 photos would give us an environment that we can actually prototype for, right? We have relatively good 360 overview. We could do something when people exit the elevators and come to the School of Information, or when they, for example, come over to my lab and we have a lot of visitors in my lab. And this is the photo that I had earlier. And I show you this in a prototyping software that I'll make available to learners. And it's a very good way of creating 360 photo stories and actually prototyping out different kinds of interaction sequences. For example, here are standard navigation tasks, but there could be different steps in a multi-step interface with different changes to the interface. Let's come back to the idea of 360 storyboarding. What you see here is a template, and the way this works, and it's described in more detail, is this is what I would see right in front of me. If I follow some of these grid lines, I'm basically sketching content that appears above the user. Similarly, this would be content that appears 90 degrees to my left, 90 degrees to my right, content that appears at the bottom. It's actually a really powerful template. And in some of our activities, you can explore this template in more depth. I want to show you a couple of examples of what we can actually do with this template. So what we have done is, for example, creating a scenery where we put butterflies in the middle. So the user will be seeing these butterflies, and they have a doggy and a car. And then we add a second layer to it where we actually then show trees, and we're starting to prototype on paper, storyboarding still, out this scene where you're suddenly in this environment. So now we have 3 layers: mountains in the background, the doggy and the butterflies in the foreground, and the trees in the midground. So how do we do this? I just explained all these layers to you. And then what will happen is, if we add these ideas from 360 photos that I talked about earlier, we can map them onto a sphere. And now the user will be navigating inside the sphere as they put on their VR headset. And the way this works then is that they actually just see this experience prototype. It will be actually flattened out in some sense. And I've just have this experience: doggy, butterflies, trees, and mountains. Okay, so now I've composed the scene, and you can see a little bit of parallax. So we're basically spreading out these layers that we have between the foreground, the midground, and the background. And this gives this effect that now we can actually walk towards these butterflies. And we can turn around and can see the doggy and the car, and the trees are there. And so we just composed this from 3 layers of a 360 storyboard. It's actually really quite cool. And you can play around with these parameters, like how far do you want each layer to be separated from the other, so to create a more realistic experience and preview.
I've talked about foreground, midground, and background, and now what we can also do is actually move out some of these spheres that we are mapping these 360 storyboards onto. And so we can create an experience like the Star Trek experience where it's possible for the user to actually walk into the observation deck that is just next door the bridge. And I'm going to show you this as well in a quick example here. What I'm going to do now is walk around, and I'm going to walk into this room over there. So we have to walk around the bridge, a little bit physically constrained here. But the beautiful thing is that this room nicely, the physical room nicely maps into our AR version of it. And like in the room, and I have some see-through effects here. And we can go back into the other room, hop, hop, hop. And there we have space. This is actually the film studio where we're working. And we're back at the captain's chair. All right, I talked a lot about storyboarding. And so in this case, I want to specifically focus on 360 storyboarding. Now, 360 storyboarding, I brought like basically 3 examples here, and I want to briefly show what is required to create those examples. So one of the things you see throughout the course is this scene with the doggy and the butterflies, and then we have a little bit of background, like the trees here, and we have mountains in the background. And I explained how these are different layers, and that we can then kind of like remove the white and layer them and actually have a really cool experience that way. Now, the way we created these is through a 360 grid that I kind of like tried to line here. And you can see that the butterflies are in the center. And I talked about this grid in a lot more detail. So next, I briefly want to talk about what it's like to prototype an existing experience. So if you are familiar with the Star Trek, this is the bridge with the captain's chair, and that's the bridge behind. And then what we also did is we actually created a room that is the observation deck. And when we create this experience in VR, we can actually move these spheres so that they're intersecting. You can actually walk over into this other room. Now, what is very interesting, when we created this experience, this was actually an 8-hour prototyping experiment with Katie, a very talented designer in my lab. And we also used additional tools. So one thing that we were actually really a little concerned about was the amount of movement that is required to really explore the Star Trek and what users would see initially when they start this experience. So this is giving us the range of motion of a user when they are seated in VR. And to be honest, this experience, the Star Trek, we prototyped for both VR and for AR. So the more interesting thing for us was the field of view. So what would a user, especially when they are starting out, I will show you later the final experience to the user, but when they're starting out, what would be the initial field of view and how much of the bridge would they actually see? And so these are some useful templates and tools that I share with you so you can actually prototype some of these experiences and learn about how to do this actually well on paper. One of the issues with paper is that things often appear different in terms of scale, and so you will actually have to experiment a little bit with this. So a good way of prototyping this is actually putting a blank sheet of paper on top of our templates and then see the pattern shine through, and so you can orient yourself around the center and actually start drawing content in the middle, content that would appear, and then content that would appear to the left of the user would appear over here, content that would appear to the right to the user, so 90 degrees to the right, you draw in there, and you can also draw the top and bottom, so you can actually draw 360 around the user. So it's a really powerful template. Finally, one way we often use this is actually, if you want to prototype experiences for my lab at Michigan, we also have a template that is essentially a 360 sketch of my lab. Now, we wanted to try out how difficult it is to prototype rectangular rooms using a 360 template. You can see lots of distortions here, just the way it is. But when you actually view it in 360 on a VR headset, it will be evened out. It's like it goes around the user. It's like wrapping it around their head. And so these, what appears to be distorted, are actually rectangular shapes, and then suddenly they become windows and walls. And this is a very good way of using VR techniques to prototype AR experiences. Finally, once we have created some of these prototypes, we often use cardboard to rapidly preview these kinds of things.
And I'll introduce it to tools where all it takes is like put your phone in there and take a picture this way, and then start previewing the experience in VR. It's something I'll talk about. And then we'll also talk about some of the AR ways of prototyping things, where we make use of markers, fiducial markers that are visible to the camera. And so when we prototype these experiences, we not only work on paper, we often want to actually quickly preview things in VR and in AR. And so the way we often do this is, at least in my classes, we use software that I've developed that can run on our phone. And then all we need to do is actually put the phone inside cardboard, run the software, take a photo of the experience, click, and then preview it in VR. And these are things that I'll actually show you throughout the MOOC. And we can do similar stuff for AR. So I also brought a few paper markers here that are popular, and there is a cardboard version of AR, which is called HoloKit. And so, same idea, phone goes in there, the experience looks a little bit different. You have to make sure that the camera is exposed, otherwise it will not work. So it has to go inside this way. And we run the software, we put it on our heads, and we actually use these markers to tell the phone where the coordinate system of our prototype, and then we can actually preview fairly quickly any of the things we have prototyped here, actually preview that in AR.
So I've talked about storyboarding, I've talked about 360 photo stories, and I've talked about 360 storyboarding. None of them are actually 3D, and so this last technique is storyboarding in 3D. All right, I want to show you 3D sketching. And the way I'm going to do this is I'm actually also explaining to you how we actually created this experience. So what I'm doing right now is actually sketching out the room that I'm in, okay? And it is, as you can tell, it's already a 3D kind of room, but there's nothing interesting in it. So where is Michael in this room? Okay, so this is pretty easy. I'm kind of like here, standing and waving at you. So that's me, okay? And you guys are at the other side of the room, obviously. The camera is roughly here and it's pointing towards me. And you can see it. I'm never sure which is the best perspective for you guys because it's like 3D, but you know, this is kind of like the experience that you get. And how do we do this actually? How can you actually be part of the experience? So the way we record this is there's actually a green screen behind me. Okay, now this is what it looks like. And well, you don't see the green, right? You have this really cool, interesting background behind me from Tilt Brush. And the way we do this is we're using software that is essentially removing the green screen through chroma keying, so it's gone. And we can fill in some really cool stuff in the background. We could actually do anything. We could have a rainbow or other things behind me and create a really interesting experience for you that way. And obviously, while this sounds like movie production, I mean, as you can tell from how I talk about some of these concepts when it comes to XR, it actually seems very related. There's a lot of technologies that blend and blur between movie making, virtual production, and actually AR/VR content creation. Now, this is a 3D sketch, and it's very useful in the early stages of design, but it also is actually could be one of your first assets. You could actually export this into other kind of AR/VR software and process it further so that it can appear in AR or in VR, which it is right now, but we can process it further, as I said, and could really do a really cool experience that way. So I've introduced you to 4 powerful storyboarding techniques, and the extent of wireframing really built into these techniques really depends on the type of storyboard that you're creating. So if you're paying attention to the detail, the traditional storyboards are usually very rich in terms of 2D wireframes, but traditional storyboards are quite limited when it comes to AR/VR scenes which are in 3D. So I've introduced you 2 additional techniques, like the 360 storyboarding technique, which allows you to plan layout around the user. In 360 degrees, but you don't have depth. It's not really 3D. So the last technique I was just talking about, 3D sketches, really allow you to detail the content around the user, plan it out in 3D space. In fact, you know, draw it in 3D, and then you can actually create assets that way and download them and process them further so that they can actually become elements in your final AR/VR experiences.
I want to wrap up with a few tips here. So I would say start with the high-level sketches first, add gradually more detail, but only what matters to the experience. For example, don't focus too much on the physical world around it, only on specific elements that dictate the AR or VR experience. For example, if the room that you're prototyping for has a very particular shape, then you should really pay attention to this. Otherwise, it's just a rectangular environment and you don't have to draw out every wall. What I've noticed a lot is really when I work with my students, there's this implicit notation that comes up where that people use to distinguish between drawing out the physical elements and drawing out the virtual elements, really the overlays. And so what I often see is, like, for example, color being used. So red is virtual and green is physical. And if that is used consistently, it really becomes a good notation that allows you to communicate how these storyboards actually translate to design and later design specifications when you work with developers. Finally, I would communicate the type of devices being supported. I would pay a lot of attention to what kind of experience you have in mind. So keep in mind, we have lots of different types of AR, VR. It could be handheld, it could be hand-worn, and you should really keep that in mind, even at the storyboarding stage. However, at that stage, we are still brainstorming a lot, and storyboarding is a very powerful tool for brainstorming new kinds of experiences you want to create for AR, VR. Physical prototyping. That is really one of the most important lectures to me, and I've actually split it up into 2 lectures here, and I want to introduce you to a few physical prototyping techniques. So physical prototyping is really, in the larger XR prototyping process, it is actually between storyboarding and digital prototyping. And I think personally physical prototyping is very powerful, and it's actually worth spending quite some time on it because it'll save you a lot of time later. If you get the physical prototypes right, you learn a lot about the digital prototypes and you cut some corners there, iterate faster. And that's why I think this is really important in the larger prototyping process. So I'm going to show you a few examples of physical prototypes created in some of my classes and in some of our research. Okay, jumping right in, this is from one of our design jams where I was prototyping an AR furniture placement app with students. You can see that the final experience is supposed to be on a smartphone. There's a menu at the bottom, and the user can choose different options to switch furniture. So in this segment, I'm actually going to talk about a few different kinds of techniques. I'm going to use the same analysis we did before. How do we move from lo-fi to hi-fi? And what are the techniques in terms of their relative difficulty along the easy to hard spectrum? So we just saw this example of paper prototyping, which I think is a very good way of thinking through at least the basic interactions. Might be too limited for some specific AR, VR interaction techniques that you need to prototype. And so I'll also introduce you to 360 paper prototyping, which is basically taking the 360 storyboards that I showed you earlier, taking these ideas further to the next level so that it's actually possible for users to quickly prototype on paper and then experience those prototypes in AR and VR. I'm also going to talk about dioramas. Dioramas are miniature 3D physical prototypes of the AR, VR scenes we want to create, which I think is a very good way of thinking through proxemics. And by proxemics, I mean the spatial relationships between the people, so the users of our AR, VR experience, which could be more than one, and the devices that they use, as well as any kind of physical and virtual objects in our AR, VR experience. And you can prototype all of this physically without having to do anything with digital tools. Finally, we're going to talk about physical prototyping by actually using modeling clay, which I think is a very fast way of modeling quickly in 3D. Personally, I'm not very good with 3D modeling tools. If you have an architecture background, maybe you want to skip this step. But in general, I think in the larger physical prototyping workflow, 3D modeling with clay is really good for creating the main 3D characters and acting out the stories physically before you implement them. So starting from paper prototyping, there is this popular paper from 1994 by Mark Rettig, Prototyping for Tiny Fingers, which introduced this idea of using paper prototypes for testing. So you can actually have multiple screens available. You need to use a few people in different roles. There's obviously a user trying out that experience. There's a facilitator running through the test. And then there's a person called a computer that's a person a human that actually produces the screens by choosing from the different assets that designers have previously prototyped. And then there's a note taker as well. So how does this idea actually translate to AR/VR prototyping? Well, we have worked on this, and in some of my research, which I'm talking about here, a project that we call 360 Proto, we've taken these ideas further. So now we have our user in VR or in AR. We still have a facilitator. That facilitator also has an additional task of actually capturing some of these mock-ups that we produce on paper. We still have the computer person. The computer is still producing the assets, but we're using specific templates that I'll go in a little bit more depth here. These 360 storyboarding templates I talked about earlier to really create 360 paper prototypes. And I'll show you a few examples throughout. You can bring them to life and actually have test users experience paper prototypes essentially in VR or AR. Really quite powerful, and I'm excited about this, so I'm going to show you some of these techniques throughout this segment. If we think of paper prototypes, we can distinguish just traditional paper prototypes, which don't use any specific templates, and 360 paper prototypes, which make both the prototyping experience a little different and also the final user experience, as we will see in some of the videos I'm going to show you now. So if we stick just with paper prototypes, what are they really good for? Well, they bring storyboards to life. And that's actually what we do as we take a storyboard and explain it to other designers. Using a paper prototype, you can do the same with users. You can actually demonstrate interactions in front of the user. The user can perceive this prototype with some imagination, obviously, to understand how these translate to AR, VR interactions. What you can see in the image is how we use, for example, cardboard sticks or toothpicks. In some later examples, you will see how we put Play-Doh figures on toothpicks to really animate the objects relatively seamlessly in front of the user so that they get the sense that this is actually an interactive prototype, even though it's still on paper. So here's an example where one user with a VR controller is pointing at forest animals, and some of the designers around the user are actually animating these animals and respond to the user's interactions. And it's quite an interactive storyboard in the sense that you could have new elements appear, like in a second there will be a froggy triggered by the interaction with the VR controller, and this really helps the user understand how this VR experience is going to unfold as they interact with different elements like these forest animals. Now, if we prototype that same experience with 360, things look a little bit different. You actually have to pay attention to the template and move the elements like these animals accordingly. So you can actually now lay out content in 360 degrees around the users, but pay attention that the grid actually means that, and so you can't just move objects too quickly. You really have to follow the grid lines. Requires a little bit of practice, but is actually a very powerful way of prototyping 360 experiences. You can demonstrate interactions along these grid lines, as I said, and that will actually make, for example, something fly around the user. And you can also use objects of different size to simulate depth. Remember, 360 photo stories and 360 photos, as I mentioned earlier, don't actually have depth. It's not really 3D. And so one way to simulate depth is actually using objects of different size. The way this works is a designer is prototyping a bird flying down, and we are now actually, this owl has now landed on the tree, and we've just replaced essentially the model. Our deer is coming in, and this was an experience of prototype with students. We are not particularly careful with paying attention to the grid lines at this stage. We were still getting familiar with the template. But I'll show you how we can actually take this storyboard to the next level, because the idea is that you can actually capture this and this video and actually play it back in 360. Remember, it follows the 360 format, and we can actually then visualize this paper prototype for VR users. So this is what I'm going to show you quickly. We can compose a scene, putting the 360 grid template on top, and then adding the elements that we actually want users to see. Now you're spacing them out, you can cut them out, you could sketch them, you could draw them as you did with the storyboards, but I think for paper prototyping, I would usually work with paper cutouts. You can animate more easily, you could swap out models. It's actually really powerful. And then you can compose a scene like this way. Okay, and because this is actually still following the 360 template, what we can do now is we can actually take a photo close up of that template. wrap the photo in cardboard, and then experience that in VR. I'm going to illustrate this quickly. Okay, this is a close-up of the paper prototype. We take the picture, we go into VR, and we see it with stereoscopic views. And I'll show you the same in a video. So this is me taking a picture of a previously prototyped experience. I click the button, the phone is already inside cardboard, and I can start previewing, in some sense, pre-visualizing the 3D scene. You can see the grid lines. We could remove this layer of grid lines if you use transparency or other kinds of means. But you have a very quick way of visualizing a paper prototype. Now you can actually have a facilitator or a computer, a human computer, make adjustments to this scene composition. And now, as we can see, the owl has moved a lot closer. If you combine this with live streaming, you can actually simulate interactive 360 storyboards. And this is something you can read about later, where I share some of my work on 360 Proto. What is a little bit tricky is actually creating AR previews this way. And what I'm going to show you now is an idea I've developed in 360 Proto, the research project. We're going to take the 360 template, we're going to map it, we take a photo of it, we're going to map it into a 3D sphere, and our goal is to actually animate a butterfly around the user, or at least have a butterfly stuck in the air, and so that the user can actually walk around, the AR user can walk around and actually experience that butterfly. What I don't do this in this example is actually moving the butterfly, but you will still see a really cool effect here. So how do we prototype this? Well, we can use additional AR techniques like markers, like a physical marker here. We can use a phone to capture that and live stream that. And we can then actually take that picture, remove the background, white becomes green and then actually becomes transparent. We extract the butterfly and we show it at the very location. And the way we do this is we're using the 360 grid again to keep attention to where the object is around the user. And we're replacing that marker with actually our virtual overlay, which in this case is the butterfly. Okay, let's experience this. So this is actually me working with my student, Katie. We are actually now having this butterfly kind of like move in front of our camera, and we're live streaming this to the other phone that you see in the background. And what I'm going to show you in the next step is actually how I'm going to take up the phone and then we have the butterfly there. And because we're using AR techniques with the camera, the smartphone camera needs to be exposed for this to work, we can actually walk around this butterfly. At this stage it is still. Again, if we were live streaming this to the VR or AR user, we would have a really cool experience that way. So this was just the first part of physical prototyping, but I wanted to illustrate to you how you can actually take paper and make it digital. A lot of this is obviously described in more detail in some of my research. I and others have worked on this, and I hope that we will have better tool support in the future. In the meantime, I will give you access to some of the tools that I've created in my research. Physical prototyping 2. This is the second part of my physical prototyping lecture. Because physical prototyping is so important to me, I made 2 lectures out of it. In the previous segments, I've talked about paper prototyping and 360 paper prototyping. And now there are 2 things that I really want to talk about a little bit more, which is working in physical space and with physical modeling tools. So we're going to talk about a diorama, which is good for thinking through proxemics, really the spatial relationships between all the elements of our AR/VR experience. And then if you're not good in 3D modeling, I don't blame you, I'm not good at it either, but I can actually do it with Play-Doh. So I'm going to talk to you a little bit about 3D modeling with clay, which I think is very good for creating the main 3D characters. So the diorama is essentially a 3D physical, often miniature version of a set, like a 3D scene or an AR/VR scene that we run a prototype. It actually allows you to enact that 3D scene in the physical world. You can use multiple designers to help each other and then give that experience to a user. as before, you can actually demonstrate interactions to users. In this case, what often happens when I do this with my students in class, really the students become actors. They really play out the 3D characters in response to user interactions. So it's really cool to see. And a side effect, and actually very useful for learning about this prototype as we move it digitally, you can actually gauge the spatial requirements and understand the relationships between the different physical objects that you're using to prototype that AR/VR experience. I'm going to show you an example from something we've prototyped in my lab. It's again this forest scene that we like. So there we have the owl fly in, and then somebody interacting, and now this owl was replaced by a different object. Now this looks a little weird because we chose this upper angle and we have played around with different types of stages, but the main takeaway here is that it's actually a very good physical representation. All the pieces you had to fill in previously when thinking just on plain paper in 2D or thinking around 360 and using our template from before, actually working in physical space makes things so much easier. So at least that's what my students tell me, and that's what I also personally feel when I translate some of these paper prototypes into dioramas. Obviously, I would like to share a lot of the work I've done with my students in my classes and in my research. So here's a quick selection. We have, for example, prototyped VR gardening experiences using dioramas, or we have talked about this public speaking experience, which actually creates a lot of anxiety. And you can prototype out a TED Talk this way if you want. And some of my students have also prototyped an immersive theater, where you can actually here you see a 3D version of the stage, and later it'll be in VR. And so dioramas are really powerful to actually prototype out these techniques, often in a matter of 45 minutes. You can do this in class with designers of any kind of background, and you don't actually need a lot of technical skills and any digital tools, which I think is actually the cheapest and fastest 3D tool that is out there, physical space. And a diorama might be a very good way to do this. So the last technique I want to add to our portfolio, and you've seen this to some extent in previous videos, is we often use 3D modeling with clay. Here I show a few of the examples created by my students, coming back to this idea of prototyping an AR furniture placement tool. So the way we often use 3D modeling with clay is we actually focus on the main characters of our scene. And then these storyboards we used previously are now becoming physical. And you can actually capture nicely what these 3D characters do. They actually come to life, and they actually are in 3D. They can be moved in 3D, they can be rotated, and you can actually get a sense of the complexity of the 3D models you need to create later on. And you also can demonstrate interactions again in real 3D. It really makes a lot of things easier. However, sometimes with some of the interactions, you really need to coordinate better between designers and users. So this requires a little bit of practice, as we can see in one of the videos I'll show you in a second. So here's an example where we are trying to coordinate between user and designer. The user is performing a rotation gesture, and the designer, in this case, the computer, the human computer, is moving the chair accordingly. So the students have just prototyped this experience quickly and got a sense of the interactions they want to support in their AR furniture placement app. And this is a really cool way of getting a sense for the physical space and actually creating 3D assets that way as well. Great, so I've brought a few physical prototypes here, and what I want to illustrate is how you can actually prototype interesting concepts for both virtual reality and augmented reality using just physical prototypes. So I've prepared 3 scenes here, and there are different ideas behind each of these scenes. I'm going to start with this one. So this one was actually a project that happened in one of my classes. The students were interested in using virtual reality to prototype a standardized test scenario. So a lot of students actually are afraid of standardized tests, usually really big audiences, really big rooms. And so what this prototype allowed them to think through were like the basic interactions, who are the characters, and what would be interesting perspectives. So the experience, if you are in the front where you can always see the door, might be very different to like sitting behind a bunch of other people in this kind of like standardized test scenario. It might create more anxiety. And so VR is a very powerful tool for building empathy. And so this is actually was one of my
favorite projects from some of my students in class. This was also a really, really cool idea. Here the idea was to bring language and culture closer to the audience. In fact, this was about Chinese food and all kinds of really good looking food. In fact, this looks so good, I would really like to eat it. But it is actually made of clay, and so you shouldn't. And so there were additional elements that I don't show here right now. I just focus on Play-Doh and the physical aspects. But there was paper, there was actually Chinese language around it. The idea was to really prototype an experience so that learners can learn about different language and culture. Now, these were two examples of prototypes that allow us, that are new ideas in some sense, that allow us to think through interactions. And these are some of the things we practice in our physical prototyping activities. Now, this is a last scene that obviously, if you are familiar with some of the movies out there, this should remind you of The Lion King. Now, what we've also tried in a lot of our research and also in some of our student projects, we have actually taken existing scenes and recreated them. Here you see Rafiki, and we actually had to do 2 shots of Rafiki, and you may see this in other portions and other segments of this MOOC visualization, where we actually animated Rafiki, especially this one difficult scene where he was like moving the hands apart and breaking this. It's a really nice element in the teaser, and this allowed us to think about character movement and complexity of 3D models, and that's what you learn from doing everything physically. When you start analyzing these physical prototypes, I believe you get a lot of knowledge in terms of requirements. What kinds of user requirements do we have? What kind of display requirements, tracking requirements? What does this mean for our 3D models? How complex is this stuff? Can we download existing ones? Do we have to create our own ones? And so doing this with Play-Doh in a matter of an hour, you can do this in a classroom setting. You can have students think through this very quickly, and I'm a big proponent of physical prototyping.
So in the last 2 segments, Physical Prototyping 1 and Physical Prototyping 2, I've introduced you to a variety of physical prototyping methods. For example, just using paper, then adding the 360 grid onto paper, and then using clay and the dioramas. And what is most fascinating to me is that these physical prototyping methods are largely AR/VR agnostic, unlike digital tools, which are often just really good at AR or VR, if at all. And physical prototyping is really fast and cheap, and it's really allowing you quickly to iterate on designs. However, keep in mind that when you prototype physically for VR, it's really about the immersive experience and this feeling of creating presence. So you should really pay attention in your prototypes to creating this virtual environment. For example, using the 360 grid, because this is the best method that allows you to think spatially around the user. However, for AR, it's really about augmenting experiences and context. So context here is really referring to the physical environment that the user is in. So your AR device would read this environment and then send signals to your interface. So what you need to pay attention to is when you prototype AR experiences, the tiny little things in the physical environment around the user that could trigger certain aspects of your experience. In this video, I'm going to introduce you to the XR storyboard exercise as part of our XR design project. And so we are now in the storyboarding and wireframing stage. So that means we are brainstorming essentially. We want to focus on new features as we think about the expeditions like XR app that you have chosen. And so part of the exercise is really understand the existing flow without thinking about new features, and then also developing one new feature. So that's all I'm asking, and it's important. Don't try to come up with your own complete app. That's really hard for other learners then to provide feedback and help you improve your storyboards and wireframes. So it would be good to ground it in something that is not too complicated. We don't need forever to understand what the problem is you're trying to solve. No, we want to focus on the things that matter when we do storyboarding and wireframing. So really focusing on the key design ingredients, if you will. So here is my exercise cheat sheet. This is what I have in mind. So the task will be to create a storyboard for an expeditions like XR app. So one storyboard, one type of storyboard is fine. You should create probably a few different kinds of storyboards ideally, but let's say you do one storyboard, you should start with 2 to 3 high-level sketches. So capturing the flow of the app. You really want to understand, how does this actually work? How do you transition between states, if not screens? And how does it work? And then you actually start sketching out. You can just sketch out some of the existing screens as well, or scenes, or whatever we should call it. And you should add more detail and distinguish, obviously, in your sketches, the physical and the virtual objects. So, for example, using color coding. You should annotate your sketches with arrows and labels, anything that helps us understand what you've been sketching. Usually a short label is very helpful. For any kind of key elements in there. This really drives the attention. Now, my sketches look ugly most of the time, but that's just because I only sketch what I want you to focus on. No, that's not true. Yes, so we don't judge each other's sketches in terms of aesthetics. The whole purpose of a sketch is to convey an idea. And so you want to only sketch what is necessary, only the resolution that is required, so that you can, get the other person's attention on your idea and help you refine it and improve it. And so it doesn't have to look beautiful. In fact, it's great that my stuff doesn't look good, then you don't feel intimidated by it. And I think that is nice. Wouldn't it be worse if I were like a really good artist? Anyway, so you annotate your sketches. I just covered that. And you should actually then create 2 to 3 alternative wireframes of your new idea with content. I would like to see what we're talking about both in content, but I really care also about the flow and the interactions. How do I get to these new screens and scenes that you have prototyped? And optionally, but I think this would be a really good task, and I say optional because, well, to manage your workload, but also normally in a project you wouldn't actually try out all kinds of different types of storyboards, but I would like you to try out a 360 or a 3D storyboard. So the expected results of this activity and exercise are that you have a better understanding of the overall flow of the app, and you also have more concrete ideas of how to change and improve the design, including a new feature that you think could be cool. And you have a good sense of what your app may feel like in AR, VR, especially if you use a 360 or 3D storyboarding approach. So again, we are going to stick with a expeditions-like AR or VR app, so an XR app. Can also do 360, and it should work on smartphones like this one does, and that way other people can also try it out. So here's the one that I was trying out. This is the solar system. You've seen me do it, you've seen me critique it, and this is, I'm going to show you a few videos of me brainstorming and storyboarding around it, and also then creating a few wireframes. So here you see screenshots from my design critique as I was playing around with the app, and that is really the input here. The function is to create a storyboard, and the input parameter is your existing critique. So your experience of trying out that existing app. And so I've covered all the kinds of screens and states of the app that I could reach and that were in the scope of my critique. And here I'll show you, this is from the lecture. So we have a few different kinds of storyboards. They vary both in terms of the fidelity, as I said, so lower to higher fidelity, and easy to hard. And I'll talk about this, or talked about this in detail in the lecture. And so I'm going to show you examples of each of these types of storyboards. First, traditional storyboard. So here you see a time lapse of me doing the exercise. And I was, I had already sketched out the basic flow. So this was just the flow and then the start, and then I was like developing my own new idea. And while I was actually developing my own new idea, I was also playing around with the existing app from time to time, just to get to really to flesh out some of my ideas, get a better understanding. And some of the things I really wanted to do was actually see multiple planets in relationship to each other. And then I had even more ideas of doing different kinds of day and night. And wouldn't it be cool if Earth, how would Earth look at night? and really was interested in the relationship of the moon around Earth and how it fits into this picture and how far is Earth away from the sun anyway, and then other planets I didn't even care so much about. I was just focused on those 3 planets. In the original app they had more planets, but they didn't actually do much about Earth and moon and sun, like no relationships. And so I was really figuring out what could I do to improve upon some of the things that I think were missing from the app, from the existing expedition. And I understand that this Google Expeditions framework might be a little limited. So all these expeditions work in a very similar fashion. And so maybe there you could see, hey, that was a break, me thinking about what I could do. And then I had this idea of doing different night times and day times and seeing really the zones like on an airplane. When they show you this world map and show you where it is day and where it is night right now. And I thought that could be cool. And yeah, so then usually I do kind of like a walkthrough and illustrate some of the ideas I had in mind. And this is also, obviously in not 500 times speed would be a good way for you to share your results. And I have each of these steps recorded, so you can watch me do a storyboard. I'll share that video with you. You can watch me actually review my own storyboard. That gives you some ideas of maybe what to pay attention to. And also what you can learn from these storyboards. So the reading between the lines is really important when it comes to these activities and exercises. So I'll share those steps and videos with you, so that may help you guide through each of the steps even more. And then I was doing a 360 storyboard. So now we're down here, right? A 360 storyboard I think is harder because you're using a template that you may have to, well, spend some time with and actually understand and get a feel for it. And then I would say it on the fidelity scale, it actually moves you more like here rather than here or here. I do think that fidelity is actually really quite high. It is not as high as a 3D storyboard, but I'll show you and I actually share an app with you so you can actually take pictures of your storyboards and then preview them in AR VR. And I think that helps you cross this line and brings you into this quadrant, the one that we want to be in. Ideally, you want to be here, right? Super high fidelity and super easy. And well, I can't claim that for the 360 storyboarding approach. Obviously, there is my research on 360 Proto, and we've really worked quite a bit on this. But I think it can get you here, maybe, but not much further than that. So this is the template, and this is what you see right in front of you. This is 90 degrees to your left, so over there, 90 degrees to your right, over there. And this is right above you. This is, oops, down there would be right below you. And then it actually also, like, because it stitches on the sides and the top, it really wraps around your head. Like, that's how the 360 template works, right? Think of 360 photos. This is equirectangular format. So I was talking about this in more depth and detail in the lecture. But, you know, sketching like a rectangle, you would actually have to follow these grid lines. Okay, you follow these grid lines, you go down here, and you follow this grid line back, and you just sketched a really big rectangle. It didn't look like a rectangle, but it will look like a rectangle when you then do this transformation. And this is a projection from equirectangular to spherical. And I was just talking about this, so these are the things that are right in front of you, would be here, and left and right. This blue cross, keep that in mind. We even entered all the degrees, and there are templates, and you see me use some of these templates to help me check for the field of view and the range of motion. This is something that I would do in VR. And you see the templates here, so they are like lying up there, the transparencies that we printed out. I'll share those with you as well. I think they're a little bit more advanced and not even necessary, but it's still kind of cool. And so here you see me sketch it out, and I'm doing a storyboard. This is the more interesting one. I didn't really play the other one. And I was playing around in preview. That's really important. And then I was checking for the field of view and the range of motion. Really, how much would the user need to move initially in order to keep things in view? and this assumes a standard VR headset. Now, since I was actually more thinking about AR, this was a little bit more like often a demonstration, just to show you that it exists. And this app is really quite cool that I created, so I'm going to share that with you. It should work on your phone, hopefully. It is research, so don't don't hate me if it doesn't work on your phone. It works well on my phone and on Android phones, on a variety of phones, and we can probably configure it for your phone too. And then in between I sketched out just using the normal, traditional paper, and now I'm moving this sketch to the 360 template, and I should share, I could share that entire video with you. I do think that I was sketching for like 20 or 30 minutes. It's probably a bit long. I was thinking we just look at the time lapse, and and then I was using color. So that color is actually quite important, because as I was talking about in the lecture, you should really mark the virtual content and tell me what's virtual and tell me what's physical. And here I used red as annotations, so red wouldn't be displayed, blue is the virtual content, and black is just the reality. That's a notation that I have established for myself. Like, you don't have to use it exactly like that, or do it exactly like that, but you have to be clear how you were thinking about it. Here is the result. I'll share that video with you, definitely, because rather than watching me sketch forever, this is the one where I'll talk you through some of the results, and that will give you some inspiration. So we're going to share that 360 storyboard video, and you can watch it in full length. I was playing around with a template and really getting a sense for how things work, and then I was applying that template. So here, for example, I show how the template really works and how I applied it to paper, and how I was then sketching out the planets, and then also previewing the planets in VR. I also have a video for you where I'll actually preview the storyboards that I have sketched, and so you can see what this might look like. I hope that you will be able to try out this app and it runs on your phone. This is not a product, this is a research prototype coming out of some research from my lab. It's a simplified version, not as advanced as the one that we actually had in the paper in 360 Proto, where you could live stream and use multiple phones and all that kind of stuff. But even this simplified one is already good enough for us to get an overview or a preview and actually transform paper into a VR interface, especially when you then combine it with cardboard. That is then really cool, because you really get a preview, a VR experience. And here is that example where I then actually put it in cardboard, and then obviously the actual cardboard, use that with the device. Okay, so we've seen the storyboard, we've seen a 360 storyboard. I don't do a 360 photo story, but again, the idea would be I just like do it in the physical world, and then I take 360 photos of it, or any kind of standard photo story you could do as well, but I think you would learn more from a 360 photo story, and I described that in the lecture. What I've done for my own exercise, I have done the 3D storyboard, so I'm going to focus on that. So I have a 11-minute video of me actually going through that storyboarding activity in Tilt Brush, and really I was using Tilt Brush in a way that it's probably not really being used for as a storyboarding tool. Keep in mind that Tilt Brush is not a tool that is for free, so there are other tools out there. I've played around with a few. You see me use few other tools later. Quill, for example, is one that you could use on the Oculus, and there are a number of sketching tools out there, and then it is on you to use them as a storyboarding tool. The way I've done it here is like sketch out different stages or scenes of the app, and I was doing it in VR, but I'm actually sketching an AR experience, and I'm sketching a little crazy here. This was really supposed to be a glowing sun, and first step was like place the app. The second step was to then see the sun, and then I also wanted to really understand the transition between these different steps. And later in the video I then review some of my work, and then I use it like a user, and think it through and think aloud and mark like the interactions that users might do. and then I was picky with the color for some reason, but that's just being me. Anyway, this was supposed to be blue, I guess, and I was looking for the right blue, but come on, Michael, focus on the task. And the task at hand was to really illustrate to you how this might work. And then you see I put a little moon next to Earth there, and then put both around the sun, and I was sketching how they would go around the sun. And I'm quite sure you would be learning quite a bit from doing a 3D storyboard. Again, it doesn't have to be tilt brush. You use something that is for free and available to you, or you make that investment. You could also go pro and do Gravity Sketch, and there are some other tools out there as well. Anyway, we can discuss good tools. The 3D storyboarding is probably one that you would find very exciting. Personally, I think I get a lot out of the 360 storyboarding, just like because I find that template so cool but also challenging. And but every time I do it, I learn something, both about me and my limited sketching skills, and also then obviously about the project that I'm working on. And that is actually what matters. So this is going to be a fun exercise. You can blow it up a little bit by trying out these different kinds of storyboards, or keep it simple and just work on paper, but work through the flow and really figure out your new feature. Hey there, fellow honest track learners. I'm excited to welcome you to this next step, on our path to creating this really cool XR project. Physical prototyping. I don't know, in every course I teach, I always get so excited when it comes to the physical prototyping stage. I mean, we were already quite physical when we were doing the storyboarding previously, but now we're really doing physical prototyping. So that includes paper prototyping, but it also goes beyond paper. And this is what I want you to learn and want you to practice and exercise. So I'll walk you through the steps of this exercise, and I'll come back at the end with a few ideas for how to make use of this activity. So let me walk you through the exercise, and I'll also share a few insights and tips along the way, since keep in mind I've actually been doing this myself in preparation for the MOOC, and so I spent quite some time prototyping, and I'll be happy to share a lot of these videos where it makes sense with you as well. So this is our task. Your task is to create a physical prototype of an Expeditions-like XR app. The same rules as before. I say Expeditions-like, it doesn't have to be Google Expeditions. I say XR, it can be VR, it can be AR, it doesn't have to be both. It can also be just 360. The key point of this activity is really to create a paper prototype of one of the key interactions, right? I mean, there's a lot of stuff you probably want a paper prototype, and that includes the content and all of that, and I understand that. But we really want to focus our attention on the interactions. We really need to make more progress when it comes to that. But we're also going to do content. So we modeled 2 to 3 main 3D characters with clay. This will be fun. And we want to create a diorama with the 3D characters to define the story. Now, diorama doesn't have to be like the one that I'm going to show you. It can be just like in 3D it can still be on paper, but then think pop-out book. So it has to come out really into the physical world. We don't just want a paper prototype. We actually want to be more physical than that. And so bring some cardboard and do that. Record a video and narrate the interactions. That I think is a really, really, really important part. That brings your physical prototype to life and also allows you to share it with other learners. Optionally, you can create a 360 paper prototype to define the context. So 360 paper prototype would mean to use my template and follow some of the instructions. This makes a lot of sense, especially when you've done a 360 storyboard. Like to keep refining that storyboard and turn it into a 360 paper prototype, really wireframing it out and thinking about some of the transitions and interactions, and then actually start really playing with it, so moving the characters around on the grid. That is really cool. But as before, you don't have to do each and every type of physical prototype. You can just do a paper prototype, although I would like you to really play around with Play-Doh and create a diorama. the expected results from this activity, because these different types of prototypes also increase fidelity. I mean, you're still kind of low to medium fidelity, but you can increase fidelity just by changing the tools that they're using to create the XR prototype. So you will get a better sense of the problem, the context, and the story. And that's really, really important. These are the key ingredients that I introduced you to, and this really matters for XR, actually for any kind of user interface, but a story is particularly important in XR. We want to identify the key elements, so the environment, the 3D characters, and this also helps you drive requirements in terms of assets for digital prototyping and development later on. We really want to learn about the interactions. These physical prototypes will allow you to play around with the materials, try out different compositions, different scene compositions, different transitions, different animations, just by moving things around. All the things you would have to program digitally, you can now do in the physical world. And so that's so exciting. Get a feel for technical requirements and then also digital prototyping needs. I would say these are the expected results. This is why we do physical prototypes. When you share your physical prototype video, that's really cool. That would be a major accomplishment. What would be even better is you reflect upon that experience. Just you going through it in your mind again, reflecting. I usually have that activity with my students in the residential courses. We do the physical prototypes and then we write half a page, just thinking it through, like a little diary entry, thinking it through. What did I actually learn? And we critique both the method, like what was limited, what was hard to do. I was doing VR, but I was just using paper, and I was using a 360, but then how does 360 translate to AR? And that's something that is something that I've been thinking a lot about as part of my research. And it would be cool if you raised similar questions and maybe we can engage in some interesting discussions around it. Don't hate the 360 template. It will just require some time. There are easier tools out there. You don't have to jump right in. You can also do an immersive prototype. So keep in mind, this is supposed to be physical. So don't jump into the digital tool yet. That is kind of not allowed. Ideally, you would do with physical materials. I want you to get that experience. I think it's a pretty important one. And it allows you to think without all the technical constraints that you usually have to face and solve and work around when you do digital prototyping or later on development. So that's why physical prototyping is so important. So as before, I'm doing the solar system, so I'll share a few of the things. I had obviously the knowledge from the design critique. I also had my storyboard. I did a standard storyboard. I was playing around with the app. I was going through the flow and I was developing my own new idea on storyboard. I was actually then on paper and doing a normal storyboard, a traditional paper storyboard. And then I was doing this 360 storyboard, like sketching out. I got a few new ideas about light and shadows and what are the interactive objects. So that's something that I paid attention to. I previewed it. So I have all that experience, and that experience is important. We are taking that experience forward in our physical prototype here. And then I was doing a 3D storyboard using Tilt Brush. You can use other tools, I said, that's fine. In some sense, so this is an immersive authoring tool, so it's clearly digital, and we were doing that for the storyboarding. So now we're moving back to physical. Michael, is that really what you want? Yes, that's what I want. We're not moving back to physical. Don't think of it like in that way. Think of it in terms of a tool. The physical tools are the ones that we have around us in the physical world. So you're quite familiar with them. We can do so many things with paper, and that's something I want you to think about. So rather than you thinking, well, this is a step back from Tilt Brush, you think this is a step forward. It's paper. It's so much more versatile and flexible. Obviously, yeah, you won't have that stereoscopic view and this really, really key sense of a preview, but I'll also show you again how you can preview some of your prototypes using some of the tools that I have developed in my research, and you get versions of that. You get access to versions of that. So here is our landscape from the lecture on physical prototyping. I was talking about paper prototyping and 360 paper prototyping a lot, so that's like one thing that we're going to try. And then along the way, we're also going to do 3D models that we can then put in a diorama, and that will be cool as well. So let's get started with the paper prototype. I'll show you what I have done as I was working on the exercise. So here is me sketching out, well, screens first. So clearly the traditional 2D UI artist in me, that I am not, to be honest. But anyway, I was just like thinking this might be how you also may want to start on paper. And I was starting from the smartphone. It was an AR experience. I was sketching out a few of the screens, and this paper prototype was really just like the first step. All right, sketching out the different kinds of transitions. Now it goes beyond wireframes. I start coloring things. I'll actually turn it into screens. This is still relatively wireframey, but then I would actually cut it out. Could think of doing device stencils. I think what I did is actually I took screenshots of these and then just used my phone to play with the different transitions between these screens and states. That's something one can do. And it's very easy. So you don't have to be, so I say physical prototype, doesn't mean that you're not allowed to use anything digital. In fact, you should capture it at some stage. And so the paper is fine, but then using your phone as a tool is even better. Here, I was then actually highlighting the interactive areas. I was thinking, hey, maybe one can just like, the user can just click all these things that are kind of like blue, this highlighted blue, and then I was working on the moon, I think. And so also the rings on which the planets orbit around the sun, I was thinking would be cool if you could just click them and then go back or transition from Earth to sun and vice versa. So I'm going to show you my 360 paper prototype. Here's another time lapse. And so then I was, you probably thought, wow, Michael, this didn't look so bad. Why are you destroying it now? Well, you got to move on. So learn about the work by doing the next step. So I learned about the project and I was like, okay, this is me just trying to make it rounder. Believe me, this sun, no matter what I tried, it never became really round. In any case, I was then using toothpicks and I just needed more flexibility, putting up a little bit of a phone stand here, and then this is my plane where the AR objects will appear, and now I simulate these AR objects with physical properties on toothpicks, physical props on toothpicks, and then I can actually try out different transitions and how does the relationship between these planets work and what's the right scale. So I have like two sizes of the Earth. I have a third Earth somewhere. This is the moon. That looks like a mushroom, one of my students said, and so she's not wrong. And yeah, I was just playing with this. Then I was moving to the 360 template. So you can also use the 360 template, but you don't have depth. So I was talking a lot about how you don't have depth and how you can simulate depth with different sized objects and how you can do different kinds of, orbiting and different kinds of transitions just using the template. The template is really quite cool, especially if you keep taking pictures and previewing things in AR or VR with the two versions of the capture tool that I'll share with you. Hope it works on your phones, capturing at different stages. And this is kind of like what I wanted to show you. I have a more detailed video that I'll share with you in full length if you want, where I really try it out. If you don't go through the whole step of creating this 360 storyboard, maybe by watching this video you can learn a little bit more about how this may work. So I'll share this video with you. I'm not going to comment on it now, but it will be available. And then I can preview, right? That's the whole point. This template allows us, it's an accurate angular format, so we can actually convert it to spherical and then put it on a sphere in a 3D scene and then preview it in VR and also in AR. This implementation that I share with you right now at the stage when I was still developing the MOOC only has support for VR and 360. So 360 you can do, and then virtual reality. This is the 360 one. And at some stage I should be also showing how to do the virtual reality. You just click the virtual reality button and put it in a cardboard. And well, also here I'll share a longer video with you. I actually cut all this together, and I think you'll learn quite a bit from just watching these videos as well. I wish more people used this template. I do think it helps me think a lot through environment and also then a little bit of the interactions. And you get such an interesting sense or actually so many surprises when it comes to scale. Then I wasn't really happy with how I was commenting on my objects that I was drawing. Like my sun looked like a pizza or ice cream, and I felt like I wanted to eat it. So then I was like, hey, what else could I use? I could use a little bit higher fidelity, if you will, higher quality cutouts. So I got cutouts of Earth, Sun, and the Moon, and I was playing around with them at different kinds of resolutions. This is totally allowed. You can print out, you don't have to sketch everything. This template is very flexible. You can put things on it. You just have to pay attention to the scale and where you place things, but this is the point. So the 360 paper prototype can be really cool, and I'll play around with that as well. I'll share that video with you so you'll have the full overview. I was then also doing Play-Doh or some kind of clay modeling here, and yeah, I look like I'm making sandwiches or baking, but what I'm actually producing here is Earth. So yes, no, not what you're thinking. No, I'm not making Earth. No, I'm just doing my own little Earth here with clay. And I'm doing 2 different sizes of Earth because I know that I'll need them for close-ups. I need a bigger one, and then in relationship to the sun, I really need to do a smaller one. But then I can't make it too small because how tiny is the moon going to be? And so that's the thing, right? In the physical world, we have certain limitations when it comes to resolution and the scale and size of objects. And it is so interesting when you then learn about how these translate to VR and AR. The scale is probably the one thing that we never get right. Here I'm making a sandwich. No, it is actually a night version. It's supposed to be a night version of Earth. And then I was playing around with these texture sheets that I bought. Really cool. So these texture sheets actually give a pattern to the models, the props, and you will see in later videos they actually really stand out, especially when you use a digital camera. You can see every one of these little, little dents that I actually essentially made into the objects. I was playing around with toothpicks. The toothpicks is my way, but you can also use other ways to stabilize and mount the objects, and there's a number of different things you can do. Here's the sun that I'm making and shaping, and I'm trying to mix. I'm not sure I always got the colors right. At some stage I feel like I had to check. It actually doesn't have to look like the paper version. That was just me trying to match it because I knew I was going to produce videos for you. But really, I mean, it could look different. It should look like a sun, but it looks more like a pizza ball or something. And then once you have the clay, you can obviously really explore interesting things. So this is the video that I'm going to share with you again, because it is a major step here, and I think it nicely illustrates the advantages of using clay and physical prototyping and having these as well, the 3D models of your scenes. And I was playing around with different kinds of compositions and animations, because I could then really move these objects. I show a later portion at the end. I was playing around with different kinds of compositions. I remember I also put together like the Earth, the Sun, and the Moon. Yeah, I mean, this probably looks weird, but this is what you will look like when you then are supposed to take your video of your physical prototype. And so it's really important. I was just running it all the time, and I was using a little bit of basic video editing later on to cut it, so we didn't have to share. This is now bringing in all the objects, and I was going through. But the portion that I was looking for is this one, because it does really show nicely how you can then bring. The camera wasn't always playing nicely with me. It wasn't, the autofocus was a bit weird, but this depth of field effect is something that I fell in love with. And if I knew better how to do shaders in 3D, then I would probably come up with that. I would probably implement a solution with the depth of field effect. In any case, I was then doing the diorama. So this is a 6-minute video that I'm happy to share with you. I really set it up quite nicely. I was proud to put this all together, and I will just go very briefly over what I did. So I was bringing back all my materials. This diorama is in some way the culmination of these initial physical prototyping steps. I actually did this last. And as I was doing the diorama, I was then also bringing in some of my tools again to have some AR previews. So that's what I'll show later. I'm just going to jump ahead a little bit. Here, for example, is what you see in the video is how I take some of my objects that were placed on paper and how I can then actually preview that in AR. Now they're really floating above my little table here, and I thought that was so cool. So I'm going to share all this with you. I was also playing around with different backgrounds, and there is a part in the video that I find even more interesting. Now that is cool, but at the end I actually show this part is really cool because I'll mix the physical and the digital here. So I have like two virtual copies in AR, and then I was bringing in a physical moon, and I was commenting on how obviously occlusion doesn't work because the camera has a hard time seeing these objects that are so close to the camera, and it doesn't actually have body segmentation implemented AR core at this stage at least. And in any case, it would just see a toothpick and a little moon. But yeah, so you'll see me go through all these exercises and steps of the exercise. I actually had fun. I hope you have fun. I hope you do a subset of this and you feel like you learned something. This is the physical part, and with a few tools to allow us to preview things in AR and VR. And then we're going to jump into the digital world after this. We're still using authoring tools, no programming yet, because that's what we're going to leave for the next course. But we are going to get to our final prototype that we can then actually also peer review. And yeah, we're going to talk about peer review as well. So we're still talking about designing XR experiences, but we're moving into digital prototyping space. And what I'm going to do in this segment is really focus on, well, how do we take, for example, our storyboards that we created on paper or our physical prototypes? How do we take them to the next level in terms of fidelity? How do we take it into digital? And I'm going to talk about a few techniques in digital prototyping up to the point of actually doing it in immersive authoring using AR and VR devices. So let's watch a quick video of what I'm talking about. He is now moving around the object and capturing the Play-Doh figure. The information will be live streamed back to the editor, where the video is available immediately. He has now access to an additional resource in the Collect pane, which he can preview in the Capture pane on the right and could actually recapture if necessary. In this case, the designer is, however, satisfied, and all he needs to do is actually drag and drop the Play-Doh model capture into his AR scene. He's enabling the marker tracking and inserting the object. He's enabling the marker tracking, and he can immediately preview the object above the marker. He disabled the digital marker representation, and now he's showcasing how Proto-AR renders perspective frames depending on camera movement. This gives him a first sense of the AR interface he wanted to create with Proto-AR, in this case in less than 2 minutes. Now this is just one way of prototyping things, and it's something that I've come up in research, and it's not exactly the kinds of tools that you have available as a product. So more generally speaking, what does the XR tools landscape look like? As a little bit of a reminder, we obviously have digital and immersive authoring. So we have existing tools here, and I just give some examples. Keep in mind that some of these examples are current examples, and we don't know yet whether the tool that I list here is still around tomorrow. So we have digital and immersive authoring, we have web-based development. So this is this whole idea of building on the WebXR specification. And then we have tools like A-Frame that I've talked about earlier.
we can do a kind of cross-platform development approach, where popular choices are Unity and Unreal. These are these game engines that I talked about earlier, that are usually combined with some kind of AR, VR software development kit or SDK from popular vendors like Oculus, Vive, Microsoft. You can also specifically target devices and do native development. So this is the fourth approach, the fourth big category of tools. You could choose a particular SDK, like the Cardboard, Oculus, or Vive SDK, to develop for these specific types of platforms and devices. So this is the overall landscape. And as you can tell, some of them actually require programming. Some of these tools, like Unity, Unreal, with these software development kits or native development, actually do require quite a lot of experience and programming background. So what are these approaches good for? I think the digital and immersive authoring tools that I want to introduce you to are good for storyboarding, but then there are there's limited support for interactions. So you can do a few things, but you will very quickly realize there's not so much you can do after initial prototyping. So after that, you need to choose one of these three possible paths: through the web, cross-platform, or native. So the web-based approach, I think, is very good for XR apps that have some basic interactions. Sometimes it still feels a little unfinished with current WebXR approaches. If you compare it to a Unity or Unreal experience, so these would be in the cross-platform development approach. These are actually good for full-fledged XR apps. They're really visually stunning. Sometimes you can really create really nicely looking experiences there. But I also think the cost is pretty high. Learning these tools usually comes with a very high learning curve. Depending on the path and the background, remember I talked about paths to being an XR creator. If you have a game dev background, Unity and Unreal feel very natural to you. But if you're like me and coming more like from a web dev background, it'll be a little harder for you to pick up those tools quickly. Finally, the native development approach is actually good for, again, full-fledged XR apps and exploiting platform-specific or device-specific features even. So in some sense, it's like the best experience you can create. But the issue is that you're kind of like locked in with a particular device, platform, or vendor, and that limits the experience. It limits the numbers of users that you can reach. So now let's really talk about just digital and immersive authoring. So digital prototyping, I want to do it the same way as I did it for physical prototyping. Again, we're thinking about low fidelity to high fidelity, and keep in mind that digital prototyping should be closer to high fidelity. It's like the experience should be closer to the final thing that we imagine. And then again, there are methods that I want to tell you about that are, some of them are easier and some of them are harder. So how does it actually work for digital prototyping? So digital authoring, which is a specific set of tools that allow you to create things through visual authoring. It's like using an editor, click and play in some sense, and then you can run these experiences often directly on an AR device, for example. I'll show you some of these tools. Immersive authoring is actually, it really means that you're working in AR or in VR. So the way you interact with the content at this level is quite different. You're really immersed in VR or in AR, and the tools need to translate a little bit. So imagine that with immersive authoring, you're really going inside VR or AR, so you're putting on your headset, and then obviously the interactions change, right? You need to think about, oh, the user doesn't actually see the real world anymore. How do they interact with the objects in physical space? And so immersive authoring is really, but you're really testing as you're designing it. So it's actually quite an interesting way of prototyping, and I'll show you some of the tools in that space. In both cases, with digital authoring and immersive authoring, you're really subject to the limitations of what you can prototype with these tools. So if you're moving into the other ones that I talked about, the other approaches, web-based development, cross-platform development with Unity or Unreal, or native development specifically for some of the software development kits for some of the AR/VR devices that we have out there, then you're moving slowly, but definitely into that space where it becomes a lot harder to do, but you also can create a lot richer experiences. So you're moving towards high fidelity, but also it is hard. Now, I wouldn't actually say that all of this is digital prototyping. When I use the word digital prototyping, I want to draw the boundary here around from digital authoring tools, these click and play tools, through immersive authoring, doing things in AR or VR as opposed to just 3D on a laptop or desktop. And then web-based development, and just scratching a little bit of cross-platform here, because I think the Unity and the Unreal editor As long as you do not have to write your own scripts for interactions, I still think of them as a tool for prototyping. So I still, that's what I wanted to illustrate by drawing the circle and the boundaries that way. Okay, now let's zoom into this circle of prototyping tools, and I want to start with digital authoring tools for VR. And unlike what you might expect, I've selected Amazon Sumerian and Unity, but just the Unity editor part of it. I don't refer to Unity as the bigger game engine and the whole platform with C# and scripting and all that. Just as a visual authoring tool, I think it is a very popular choice. A lot of people prototype directly in Unity. So what does it mean? What can you do with these digital authoring tools? Well, most of them support visual authoring, so using a mouse and a keyboard and navigating with, first-person shooter kinds of experiences with WASD and those kinds of things. I'll give you an intro to that later. But they support visual authoring of 3D scene graphs, so essentially hierarchies of 3D objects. And then they also do support VR previews. So often it's just a matter of quickly connecting your VR device or going through some deployment method to actually quickly deploy it to this Quest here, and then previewing that thing that you just created and being happy if you did it right. But the workflow is really like using the desktop, putting on a VR or AR device and testing it that way. I'm alluding to other tools here. Immersive authoring would give you the advantage that you do everything in AR, VR. But just staying with digital authoring tools, so you can do basic interactions. Without programming, you have usually access to basic interactions like the user looking at things or the user clicking things with a VR controller or touching things on their phone. Those things are usually available in these tools. You can also do some more advanced interactions, but this is hard. Sometimes you may add specific toolkits to it. Like, for example, Unity has the XR Interactions toolkit, or Microsoft is working on the Mixed Reality toolkit. There is also a Virtual Reality toolkit, VRTK. So if you add these kinds of libraries to it, you may get away without having to write a lot of your code. But to do advanced interactions, there's usually no way around writing code. So the next group of tools is digital authoring tools for AR. So how does AR differ? Well, there's a different set of tools out here, and they differ in that they actually support visual authoring of either marker-based or markerless AR apps. We'll learn more about what that means, but in the marker-based scenario, all you would do is actually use one of the markers that they usually have and hold it up in front of the camera, and then use this for tracking. So the way I would interact with it is using my phone against the marker and then prototyping this way. So you can do this with the default markers that are provided, like the astronaut I just showed you, or you can also create custom markers in later stages of the prototyping experience. I would often just use default markers to begin with because they track really well, the SDKs work well with them. And then custom markers is something when you want to advance into the prototyping stage and maybe building something more like a minimum viable product that gives it a specific theme. The last characteristic of digital authoring tools for AR is that they typically enable augmented reality previews, either through some kind of software that you download onto your computer or have like inbuilt into the prototyping tool, like in the case of Lens Studio here. So we call this an emulator. Or some kind of sending it to device. Usually requires to connect the AR device, maybe a smartphone via USB, to the computer and quickly deploy to it for testing. So as I was talking about these digital authoring tools, I was also pointing out some of their limitations and what makes it cumbersome when it comes to actually working with AR, VR. You often have to deploy it to device to actually get a preview because existing emulators or existing previews are often not good enough. So this is where immersive authoring tools really have an advantage and play an important role. Again, I would distinguish between immersive authoring tools for VR and AR. Here I show you two for VR. So the two examples I wanted to give here is Google Blocks and Oculus Quill. So they are both immersive authoring tools for VR. Imagine that I've done these prototypes, these digital prototypes that you see here. I've done them while I was in a VR headset.
And in one case, I was working with primitive shapes, and I was working on a chair in Google Blocks. You may not be able to see it, but that was the idea. I tried to create a 3D model because I needed it for my furniture placement application, and I wanted to do it immersively in VR, even though the final experience may be in AR. These immersive authoring tools for VR are a good way of prototyping 3D objects that finally end up in an AR or a VR experience. It really doesn't matter, but you're using VR to prototype. And at the bottom, you see Oculus Quill, which is more like a 3D sketching tool for VR. It's similar to Tilt Brush, which you have seen in other segments of this specialization. And what is interesting about Quill is that they actually move the entire authoring environment, kind of like it reminds you of Flash or Macromedia Director, if you've ever worked with these tools, where you can do keyframe-based animations. And you can actually do the same in VR, and that's something I still have to learn a little bit more. It's actually quite tedious to use the tools in VR. But in principle, these immersive authoring tools for VR enable visual authoring, but in 3D, right? You do it in VR. So that's quite different from digital authoring in itself. How is it different? Well, they make it possible to edit while at the same time you're previewing it in VR. So the whole time you are in VR, and that is quite a different experience. I would say that the overall tool support of existing immersive authoring tools is really with a focus on 3D modeling. There is support for animation and some kind of scripting in some of these tools, but really, since you're doing it in VR, you really don't want to have a keyboard and write code. And stepwise animation, even if it's keyframe based and intelligent in some sense, is still relatively tedious. So I think these tools are best used for doing some kind of 3D modeling and pre-visualization, for example, of the 3D models you have later or the environment that the user will be using. And that's where these tools are really good. They typically actually support export to common 3D model formats, so this is actually quite useful. In fact, Google Blocks here that you can see, actually you can share directly to Google Poly, and in that case you can find lots of 3D models online that other people have created with these immersive authoring tools. You can see them as inspiration or like to push yourselves a little bit. There are really people who are really skilled with it. Sketchfab is an online platform where people actually share the 3D models for free, some of which may have been created with some of these immersive authoring tools. Often, however, they actually use professional 3D modeling software. And Google Sketch or 3D Warehouse is the other kind of platform that is often used for sharing these kinds of models. Okay, let's look at immersive authoring tools for AR. So there is a set of tools emerging, for example, Apple's Reality Composer that you can run directly on your iPad, or Adobe Aero. So what you do with many of them is you use your tablet as your viewfinder, a tablet that has AR capabilities. And then you can also do immersive authoring. You're not as immersed as in VR, but you can actually make use of physical space and walk around and zoom these objects here that I show you on the left. I did the same example in both of these. I just actually placed a 3D model in my office. And so Apple's Reality Composer is one example. Adobe Aero is another. So what do these tools actually do? Well, they enable visual authoring of 3D content in augmented reality. They make it possible for you to edit these experiences as you are creating them, and you're previewing them at the same time. So you don't actually have to do something on a laptop or desktop and then deploy to your device. No, you're working directly on these AR devices. And in this case, you also design specifically usually for the environment that you're in. So the examples I showed here on the left, while not particularly tied to the specific environment, I just place cubes in there. Often when you do immersive authoring with these kinds of tools, you really want to do it in the environment that you're designing for when you're using these tools for AR. The existing tools provide relatively basic support for interactive behaviors. Any kind of advanced fancy gestures or any kind of, oh, let's just use this speech command or whatnot, those kinds of things would still require programming. There's often not support for that. But you do have location-based triggers. So for example, as you're going towards an object or clicking a virtual object or bringing some kind of marker into the view, all of these kinds of things would be supported, usually without programming. Some of these tools also actually support exporting to WebXR.
so that you can actually then continue editing the experiences you have prototyped this way in a tool like A-Frame, which we're using in this MOOC specializations. So here I'm showing Apple Reality Composer. I have a very simple scene and just have an object, a cube in there that I can author digitally, so I can rotate and scale actually both the world but also the object. So rotation, and basically have access to all the transform tools here, scaling as well. But so this is just digitally, but what I actually want to do is immersive authoring. So I'm actually going to go into AR, so scanning the environment very quickly. That places the object in the world, and now I can look at it and author it immersively. So here basically I'm going to change the way it looks to matte, to maybe some kind of interesting reflections as the properties. I'm going to go down quickly to let you see this a little bit better, how this might look, or we're going to go for this kind of car paint look or aluminium, and can basically play around until we're happy with it. Not too much we can do with this simple 3D object. There are other ways of actually bringing in other kinds of 3D models, but I just wanted to show very quickly how we can do immersive authoring on an iPad and AR as well. So this was a quick overview of the first set of tools in digital prototyping, specifically as it relates to digital authoring tools and immersive authoring tools. And in another video, I'll look into more detail into A-Frame and Unity as some of the other tools you may be using for digital prototyping as well. Digital prototyping 2. We are still in the designing XR experiences segment, and I have talked about digital prototyping space already, where we're starting from digital authoring tools into immersive authoring tools where you work directly in AR or VR rather than on a desktop computer. And then I said there is also web-based development, cross-platform development, and native development, which usually require programming, and but people who are experienced with these tools would still consider them, at least portions of it, as digital prototyping. So I want to talk about two specific tools here that we're actually using in this MOOC specialization. A-Frame as the example of web-based development, which we are using, is based on the WebXR standard. And A-Frame is really a tool that I want you to play a little bit around with. You may actually like it if you have a web dev or web design background. Unity is, like Unreal, a very powerful tool. Usually requires some time to actually learn it. Unity comes with an editor where you can do a lot of things just like clicking and playing, and they actually do have good documentation. You can do quite a few things in Unity without actually having to program. And so that's why I've selected these two tools as examples that still fall into what I would call digital prototyping for AR and VR. So let's start with A-Frame. A-Frame is based on Three.js and WebGL. This is the technology stack that actually is important information to some people out there. What it means is, like, within the HTML5 web standard, we actually have a new element that is called the canvas. That canvas is essentially like a graphics context that you can render 2D content into or 3D content. And when we talk about WebGL, we actually usually mean 3D content, rendering 3D content into the web. A-Frame also gives you a new set of HTML tags. All of these tags actually start with a dash, like a scene, a box, a cylinder, lots of tags that are then translated to specific entities. We call them entities in 3D. So you can actually create 3D scenes, but you're writing HTML code. A-Frame has an inspector. This is not an editor. Keep that in mind. So it allows you to inspect the scene and look under the hood and find out where the light is and why this animation isn't working, for example. A-Frame has asset management. In this case, you bring in typical resources from the web, like images, videos, and then also sounds. But then A-Frame also has a set for asset 3D model loaders. And this is a good way of bringing in common 3D model file formats.
And I list out two more features of A-Frame. One is the ECS architecture. ECS stands for Entity Component System, and that's something that we'll look into more detail later. It's really relevant for programming. Just keep in mind for now that you will find lots of components out there, the ECS, the Entity Component Systems, lots of open source components out there that you can plug into your A-Frame code. They give you access to VR controllers, they give you access to certain kinds of 3D models and certain behaviors. So it's a very plug and play kind of architecture. And that's what I'd like you to think of A-Frame at the moment. And it actually supports cross-platform, both AR and VR, so cross-platform XR.
Here I have an example of a 360 photo that my former postdoc Max actually took in the lab, and I can just like zoom into different areas of this photo. So it looks a little more normal. There we have, for example, the clock, and there we actually have some sketches. We were working on Proto-AR, XD-AR, and 360 MR at the time, and 360 MR then was called 360 Anywhere, and these all became papers. So if you look at this photo, it is actually a 360 photo of the lab. So you can see some of these distortions. It's basically an equirectangular map, an equirectangular format. And this photo was taken with the 360 camera, a Theta V from Ricoh. And it actually has two fisheye lenses, and then it stitches, at the end, it stitches basically the photo together. And I'm going to show you how we can use this photo for prototyping digitally with A-Frame and with Unity. Right, here we have the A-Frame scene. So I'm using the 360 photo from before, and I'm mapping it onto the sky. That allows me to basically look around already. And then I'm also mapping it onto the sphere here as part of my example. So I'm trying to create this virtual reality where there's this interesting, curiously looking sphere here. And so the way I've done it is I've basically uploaded this photo that we took, this 360 photo, and I linked it as an asset. So I'm using CodePen here, and it shows the code on the left, basically the body of our HTML document. And then I'm using A-Frame. So define my A scene, link the asset, define the sphere, and define the sky. In both cases, I'm linking the lab as a texture. So basically my 360 photo becomes a texture of both the sky in the background and then our 3D object here in the foreground. The last thing I did was actually playing around with the material. So really making sure that this looks like interesting by playing a little bit around with the matterness and the roughness. So I can adjust actually some of these here and actually preview it immediately in there. And matterness and roughness is always something that I think as a concept it's clear, but so basically they determine how metalness, how metallic an object is and how rough it is, and that then actually gives you a different kind of reflection here. So the light will be reflected differently. So I understand that as a concept, but it's really hard to really get it right. And so let's say I'm like cool with this, so I'm going to preview this in VR quickly. So I have my Oculus Rift S here. I'm just going to put it on my head, and so I'm working in Firefox, and I can see a preview. So I'm kind of happy with the composition of the scene. Maybe that sphere could be a little bit more at a different location, but that's something we can fix later. And I can also adjust other parameters in the inspector. So I can just go in here into the scene, edit my sphere a little bit, maybe give it a bit more space so the code becomes less relevant right now because I'm using the inspector. And I'm going to go to the material and play a little bit just with the metalness and then also with the roughness. There's a lot of things we can play around with. Maybe I'm like happy with this and I'll leave it like that. And go back to the scene, and I could copy paste these values now into the document here on the left if I'm truly happy, but I can continue iterating, previewing in VR, going through that whole process until I'm like really happy with how things look in VR. And so I have a combination of digital and immersive prototyping here using A-Frame.
So Unity has been out there for a while now. It's actually growing out of the game development community. Unity was originally a game engine, and it still is, but it has grown as a platform with significant support for XR, both AR and VR. So as a result, Unity nowadays has integrated support for many XR platforms. For example, Vuforia which is a marker-based AR library, is now actually part of Unity and ships with Unity. But you can also add lots of other SDKs into Unity, and there is increasing support inside Unity, built into Unity, so that you have to install less on top of Unity. One of the things that I particularly like about Unity is its powerful 3D scene editor. There's actually a lot of things you can do in this editor. You get immediate previews, and I'll show you just the basics in a few seconds. But imagine that you can actually create real experiences and edit them in 3D on a laptop or on a desktop. So you often get a sense of what it may look like in AR or VR, although most often you still need to deploy to these devices to actually figure it out, or use like an emulator. So Unity also provides increasing support for kinds of emulators and has asset management and actually an asset store, which is different from other tools I've talked about so far, where you have to one is the tool and the other is you try to find 3D models on the web. With Unity, you actually do a lot through their assets store. And you can actually download libraries and add packages to Unity or find 3D models. And like I said with A-Frame, Unity basically supports all kinds of AR/VR devices out there. Many vendors, if not all the vendors, provide a Unity SDK that you can download so you can develop against their platform and hardware using Unity.
All right, and here we have the same scene in Unity. Basically working with a few objects. I have started out with the 360 photo, imported it, and created a sphere, and then mapped that material, mapped that photo onto the sphere, and that generates this material. Now this material, I can play around with this a little bit more as I adjust some of the parameters, like the metalness, or this is more interesting, the smoothness. The smoothness gives this interesting effect of the light source being reflected. So that's that light, and we can actually rotate that to change a little bit where the light essentially hits the sphere, and can create a more interesting looking effect this way. Now, one thing that I'm not exactly happy yet is the position relative to the camera. So I can either move the camera a little bit to the right or move the sphere a little bit to the left, which I think that's what I'm going to do. I'm going to move it a little bit to the left. So now if I press play, we're using an XR rig already, so the camera has already been converted to the XR rig using Unity's XR plugin. So I just press play, and I have the Oculus on my head, the Rift S I'm using here, looking at the sphere, and I kind of like the position, and it gives a relatively good reflection of max, and it's just interesting where it's floating. So I'm kind of happy with the result. And we also mapped that 360 photo also into the environment. So we basically changed the rendering settings here. So a couple of ways I could do this, but I chose to do it this way. I basically replaced the normal skybox, which is this one, with our 360 photo, and that gave me that effect. And well, not a big effect, but one thing we could do is we could further edit this material as well. So for example, if I'm not exactly happy with the current rotation, I could rotate this a little bit differently. So I can change the default rotation, but then I would also need to adjust the settings on the sphere. So basically also rotate the sphere. I could make it a little bit brighter if I wanted. So maybe that's cool. And I'm gonna try it one last time in VR and start prototyping this way. And I'm fairly happy with what it looks like now. It's maybe a little overexposed, but that's fine. We could continue to play with this. The point of this last part is that we can actually, while we are prototyping for VR here, using VR techniques, basically you could be anywhere, and then we port you into the lab. You might as well be in the lab, and we're actually prototyping effectively an AR scene. And well, you can do this while being in the lab, or you can do this anywhere based on a 360 photo that you previously took of the location. And I think that is a very powerful way of prototyping XR applications very quickly. And if you're good and skilled in Unity, which we'll dedicate a larger part of the development-oriented course as part of this XR MOOC, we're going to dedicate that to being better at Unity, essentially. Then you can create those prototypes very quickly, and I consider the Unity editor a powerful tool for prototyping as well. When I say evaluation, I really think in terms of three big things, and depending on who you are, it may just be one of them. So I'll give you a little bit of an overview of what evaluation can actually mean. Usability test, user study, or play test. And so how do these differ? Well, they differ in terms of metrics that you're looking at. So for usability testing, you think in terms of usability metrics, so efficiency, effectiveness, satisfaction. For user studies, you may actually have this idea of showing an effect. So maybe determining whether the participants, so your subjects in a user study, whether they feel or get this feeling of presence, and whether they feel immersed. So there are presence and immersion questionnaires, for example, that might be the instruments that you would be using in those types of studies. Or you might have a hypothesis somehow embodied in your prototype, and now you are testing whether you can find support, some kind of evidence support for your hypothesis. Or you might just be interested in doing some kind of benchmarking. Maybe you've come up with a cool new interaction technique in the XR space, and so now you're doing some kind of performance or user performance benchmarking. As a game designer and developer, you approach this probably a little bit differently. One of the things you really care about is gameplay. Do the participants, well, actually, do your players have fun? In fact, you don't talk about users, you probably just talk about players. But they're all the same. So if I use the term user, participant, subject, or player, it's all the same. The people that are trying out our XR experience. You pay a lot of attention to fun. You want to find out weaknesses in gameplay, whether something gets boring after some time. The questions that you ask are a little bit different as opposed to the other two, which I'll really detail. In this video, I'm going to talk more about usability testing and user studies. Finally, and this may also be depending on whether you're approaching this more from a marketing perspective, user retention, whether the users would be willing to continue using your experience, your product, your title, or whatever you call it, your application, whether they would come back, whether they would continue to use it. And that is usually a function of whether they can see some kind of value in it and whether it's engaging and fun. So this value might be productive or might be entertaining. So these are the things that we are trying to figure out. How well are we doing along all these different kinds of metrics and criteria? So speaking of criteria, I think at the highest level we can distinguish 4 different sets of criteria and then associated questions. One big one is usability, as I said. So how well can our users use that interface? Really important question. And then we're talking about efficiency, effectiveness, and satisfaction usually. And there are other usability metrics that I'll talk about later as well. Usefulness. This is a very different question. Whether or not something is usable is very different from whether it's actually useful. Do our users find it helpful? Now, there could be this most helpful, most useful tool, but it's just really difficult to use. So usability is poor, but it's really high on the usefulness. And then if you get the usefulness right, you will probably still have users. But if you don't have anything useful, but it's super well designed in terms of usability, it mostly becomes something that us as designers would look at and study. It's not necessarily something that speaks to the users. Utility. Whether the users see real value. Does it actually solve their problem? That is really an important question, and that question you cannot figure out and answer with usability testing. There has to be more to it. Usually this is a question of some kind of longer term use, and there are longitudinal studies to explore this in more depth. But utility and usefulness are really higher goals, higher ambitions that are harder to evaluate. And then finally, user acceptance. Will the users actually continue to use the product? Will they come back? Will they see value? Do they use it on a daily basis? How frequent? Does usage become a trend? Is usage just some kind of novelty effect? And that novelty effect is something that especially researchers need to be very concerned about. Your users seeing XR for the first time might be like, yeah, I'm totally going to use this again. This is great. I mean, I didn't know that you could do this. But now that they know this, and let's say they buy the product and then they have it, will they actually really continue to use it? And that is a function of whether that product now provides utility, is useful, and is usable. So ultimately, user acceptance is really the combination of all those evaluation criteria and questions. Now I'm going to talk about 4 selected evaluation methods, and these are more closely aligned towards user studies and usability testing. And usability testing is actually one of them. But we'll start with system walkthroughs. These you can do based on storyboards, so really in the early stages of design, or digital prototypes. So when you have something implemented in a digital kind of platform or tool. Paper prototype testing. So this is really that can happen in the phase between storyboarding and digital prototypes. Still very early. And I'll show you some cool things you can do this way. And you need to improvise a little bit. You need a facilitator and you need a person functioning as a computer, as we say here. There's this idea of the Wizard of Oz, this idea of a human simulating system functionality that is not implemented yet. And we can simulate that to some extent with paper prototypes, but this may also play a role later when it comes to digital prototypes. There is this idea of heuristic evaluation, and this is something based on the design guidelines that we talked about, and then you becoming more and more knowledgeable in the field of XR design. Heuristic evaluation is something that is usually done by experts considering established design principles and guidelines, and then also their own experience actually from designing lots of XR things and also testing. And then usability testing is the one big field and method. Well, it is both a method and it's a whole field because a lot of people have studied how to improve usability testing. Basically, the way I'd like to think about it here is like you have something digital or maybe even immersive. So that means you can actually go into AR, VR, you have that kind of prototype ready, and now you're going to do some kind of usability testing. It's a little bit different from paper prototype testing. I mean, you can figure out questions to do with usability, even with a paper prototype, especially when it comes to like terminology and user flow through an application. But whether or not something is truly usable in XR, so in AR or VR, that is something you can only figure out when you actually have a digital or immersive prototype. All right, so these are 4 big methods: system walkthrough, 2 usability testing. So depending on how much we have, and the one thing that you noticed in my selection of the methods is that they really depend a little bit on the stage of design. Some of the things that make a lot of sense early on, and then you would choose different methods if you have more design artifacts. So if you have a complete system to test. And I'm going to show you one example here. A system walkthrough is something you can do almost at any time. You can do it based on the storyboard, or you can do it based on the thing that you have implemented. And you do this system walkthrough to help users think through the system. And, well, not maybe users, but other experts. I get a critique and kind of opinion that way, without them actually doing a user test, a usability test. Okay? It's a walkthrough. And often this is done as a cognitive walkthrough. So you're thinking in terms of the tasks that users might want to do, and then how would they be able to use your system. So let me show you an example based on my own work. So here I'll walk you through some of the key features of Proto AR. So you can create screen mockups on paper, then you can do some annotations and prepare it for capture. Then you would just use your phones, capture those screens. Well, the paper actually becomes screens. And then also capture 3D objects, well, using some kind of, we call the 360 capture technique. And now what we've just done is digitizing a Play-Doh object and previewing it in AR. Pretty cool, actually. So this was a 30-second video summary of one of my research projects published in 2018 in the ACM Chi conference. The project was called Proto AR, and I've mentioned it before, and you may have read the paper already, so that's pretty cool. And yeah, so In fact, as part of one of the early evaluations in this project, we actually did a system walkthrough. I didn't have the full thing implemented and ready yet. I invited students to design jams in my lab. I often like to work with students. Obviously, these are all master's students focusing on HCI, so human-computer interaction, and user experience and interaction design. So pretty knowledgeable. And so I had them critique what I had. And the one thing that I don't always get right in my own research is the usability of the projects, just because I have larger goals. I'm interested in other issues than usability, whether something is pixel perfectly aligned and makes sense, whether it follows Gestalt principles and all those kinds of things. I usually get that feedback, and it's always fascinating to me how, and actually really cool, how the students destroy some of my own work. And obviously in my mind, I'm thinking, yeah, but that's not really the main concern here. But okay, that's fine. So you get this kind of feedback as part of a system walkthrough. Maybe you had a few questions. I mean, in 30 seconds, I went over a project that took half a year to build, and then to do, we used this to do significant research about it. And now I just walked you through it in 60 seconds. Well, that was the key idea. And a system walkthrough can be very quick, but it can also be like task-based. And you show the system step by step by step. And then you have your critiques. Let's just watch it again and look at what I actually did. So I selected a few key scenes from the project. Here I show some of the key interactions. Actually, one interaction allows you to capture paper and then bring it into the system. The second interaction allows you to capture a physical object. And we don't do photogrammetry or all kinds of 3D reconstruction that you imagine. No, we're doing a much simpler technique here. And then the third technique is we can actually preview that captured object in AR. And that's really key. So I structured the system walkthrough around 3 key interactions. These are really the important things, and also actually formed the contributions of the paper. And Play-Doh played a really important part. This idea of quickly, physically prototyping mobile AR experiences and then showing how to actually transition from the physical, so both from paper, which become 2D screens, and then paper sketches, which become 2D screens, and then Play-Doh, which become actually 3D models, and then Play-Doh props modeled physically, which then actually become 3D models. Those kinds of transitions to make those really quickly, digitization really quickly, I think that was the key, and that was also a little novel, I would say, if not at least creative. So that was a system walkthrough, and the system walkthrough helps you get initial feedback. Again, in the early stages of design, you can also use it later. But let's look at another method that we can do before we have the final real thing. And I really like paper prototypes. So let's look at paper prototype testing. I'm going to play a second video here, and let's look at it together. So we talked about paper prototyping before, and here I show basically how this technique works. We're using a specific type of 360 template here. There's a 360 grid and some kind of marker embedded in the paper that is then scanned by the phone. And then we're streaming from that phone to a VR user. We're capturing that content live to a VR user or to an AR user. And we're removing the paper background, and so this is basically the 360 proto project described in my Kaipe. So this is from the 360 proto project that my student Katie Medier and I were working on, and it also considers the role of a computer, so a person that actually helps assemble content here on our little surface. And keep in mind, anything and everything we place on this grid appears in 360 around the VR user or around the AR user. And so that's pretty cool. And so we can actually prototype quite a few things this way, paper prototype testing. Now the first thing that I'm going to show you that doesn't actually involve a lot of live streaming and interactivity is I'm going to layer an interface that actually Katie created for me. I really wanted the Star Trek, and I'm going to show you the Star Trek. So this is the 360 Star Trek, and you may have seen this in other portions of the MOOC. Because it's really a cool prototype to me. Here I'm going to show it actually in our academic innovation studios at the University of Michigan. And what really nicely worked here is how it mapped onto the physical world, and how I was just basically leaving the Star Trek bridge, now looking into outer space. And now I'm going back into the bridge, onto the bridge, and looking at the captain's chair. Actually looking at outer space again. This is the screen, on screen. And then here we look at the captain's chair. Well, kind of a walkthrough. In this case, I could actually experience it myself. So this was also kind of a walkthrough, but like quite literally, I was walking through that paper prototype. So I just made it interactive. It was just sketches on a 360 paper template. So in the physical prototyping aspects of this course, we talk about more how to do this kind of stuff. But you know, I just wanted to bring it back as an example of how powerful 360 prototyping could be. And these prototypes can be tested. Now, as I'm walking around with that thing in my hand, with a tablet, I could think aloud, like, what are the things that I notice? Did I expect this? Oh, this behaves in an interesting way. And I get a pre-visualization. Maybe you don't want to have that 360 thing, the final thing. Maybe this is a pre-visualization of what you are going to implement later. And you get early feedback even before you have made that commitment to now implement that in Unity or in Unreal, which could be the next iteration. And now I'm going to show you another example. So this is the Amazon shopping AR view that we prototyped. And we're just putting paper furniture in front of the user, basically showing it on the camera. And then here is our VR racquetball example. Katie actually implemented this using WebXR, and now we prototype this. We implemented this first to set a baseline, but now we prototype this together with a toothpick and Play-Doh as a tennis ball, and we had a virtual racket. So the way we prototyped this, Katie, my student, was actually in the Daydream, so this is a VR headset, and she was controlling the tennis racket on using this 3DOF controller. So not too much you could do with a Daydream, smartphone inside. Okay, and I was the tennis ball, and the way we did it was we used the 360 paper template, and I had a toothpick. Well, I don't have the exact Play-Doh here, so in this case we're going to have a little bit of an orange tennis ball, but basically I'm just recreating that prototype very quickly here. This is all we did. Where's my toothpick? Okay, we got it. Ta-da! And now we have our tennis ball. Then I had to follow the specific paper template that was printed, and I was moving up and down, or I don't remember exactly. Yeah, I was moving up and down, I think. Yeah, and I was moving up and down to let the ball bounce. And then I was watching, I had a live preview, and then I was watching whether Katie actually hit it or not. And then I could like bounce it somewhere here, or bounce it off or somewhere there. And that allowed Katie, as the VR user, to get a sense for, oh, yeah, okay, this could be interesting. And obviously, what I could do as, because I'm simulating the ball, and therefore the physics, we could do whatever. We could also play with a really, really big tennis ball. Some of the coolest games created by my students in my courses. Usually, there's always 1 or 2 tennis or table tennis games every semester, which is pretty cool. I like those that allow me to cheat because I'm not that good at tennis. So give me a really big, a really big tennis ball. And then we can play around with physics and actually have some fun as well. And you can play around with physics by simulating that, as I said, Wizard of Oz style, even way before you implement it. That's why I think these paper prototypes are so powerful. So let me quickly go over the roles. I just explained it. Basically, there's a facilitator that guides the process, introduces the tasks, and helps the user if they get stuck. Usually the interfaces are not that complex on paper, but if the user gets stuck, the facilitator prompts them to ask a question. It's really important that you don't just like go in there and tell them what to do because you're losing your temper, or you don't have enough patience. No, you can see whether the user is struggling, and as you see this, you actually think about, well, you prompt them. Is there a question you have? Could you formulate it as a question? And then you jump in as the facilitator. You give a short answer to the user, but you still keep it short so that the user's attention is still on the task, okay? And then if the user keeps asking, well, then something is wrong with the interface and the experience. And so as the facilitator, you can actually gradually provide more detail And then, well, as the facilitator and also you have an observer, together you can determine the piece of information that really gets the user unstuck. And that is key, because that will potentially help you refine your interface in the future. And then there's obviously this computer, in quotes, and this computer simulates system dialogues of both system input and output. So I was talking about the tennis ball example. I was the tennis ball, and that was my computer example here. And then there is the observer, the person that actually documents the study, very important. What did the user do and how did the facilitator actually help? That's really important. So in here again is a visual overview of our paper prototype testing method. And again, I'll invite you to read the 360 proto paper if you thought this was cool and fun. Definitely quite a lot of fun for us. And these are techniques we can do even in the early stages. Next, we're going to expand on some of the other techniques: usability inspection, usability testing, and then also automated usability testing. In this video, I'm going to talk about different types of usability evaluation. We have talked about different forms of evaluation before, with different kinds of metrics, and in this one we focus on usability. So we're going to talk about usability inspection, involving experts, usability testing, involving users, and automated usability testing, which we're going to keep relatively short because this is a new area and we don't have so much to talk about yet when it comes to using systems for automated, not automatic, but automated usability testing. So let's talk about different types of usability evaluation. So there are three main categories of usability evaluation. I would say usability inspection with expert designers, usability testing with target users, and automated usability testing with computer algorithms. That's what I say here. So these are the three main categories that we can distinguish when it comes to usability evaluation. So basically having experts do it for you, involving users and learning this way, and trying to involve systems. Now in practice you may combine some of these methods, doing the expert evaluation later, doing the usability testing maybe earlier and then maybe at the very end as well, and involving systems throughout. You shouldn't think of any of these techniques to be basically perfect, and all of them could actually contribute unique knowledge, and so you should think of ways of combining and incorporating some of these techniques. So there are many different factors for the choice of evaluation method. The stage of design, so again if you're early or mid or end stage of the project, the novelty of the project, depending on how much expertise might be there or how many users trained in this technology you may actually able to, or how many users of the technology you may actually be able to find. So think of an AR application, for example, that is designed for a kind of condition or environment that is very hard to access. So NASA, for example, has several competitions going on about lunar and Mars exploration, and so they're involving mixed reality is a thing, and so the nature of the project may dictate whether or not you can actually do this kind of testing. A big factor is obviously the number of users you're expecting your application to be used by, and also the budget and time. So if you don't think that the interface will be used by a lot of users, then I think the budget and time is probably also going to be relatively small. And but you really want to get it right the more users you have, and budget and time shouldn't be the main reason why you don't test. I do think that you should always try to make room in the budget and in your time for some kind of getting user feedback, for some kind of feedback from users. Finally, the experience of your team may also be a factor contributing to the choice evaluation method. So, for example, if you're leaning towards a different style, if you have an established process or workflow in the company in which you're working. So these are all kinds of factors that together determine which of these methods you might be using. Again, I don't think that any of the methods I'm going to show you today will replace user testing. In fact, we should actually focus our attention on usability testing and thinking more about ways of actually making this work for XR. So let's look at usability inspection first. There is the concept of heuristic evaluation, which is informal, holistic, and actually checks against established principles and guidelines. And it's usually done by experts really understanding the type of interface and the technology, in our case, AR and VR. So heuristic evaluation is something we can actually do in this course, since we are learning about the guidelines and the principles of designing XR interfaces. So we can look at each other's interface and provide some kind of expert opinion based on the experience that we have, both the things you've learned in the course, but maybe also some of your prior experience in terms of good user experience design. The second concept is the idea of a cognitive walkthrough. So the cognitive walkthrough is a procedural walkthrough of the system. It is usually task-oriented, so you're imagining tasks. You're actually picking tasks that you imagine your users will carry out with the system. And it checks if simulated user goals and the memory content at the time at which they are actually pursuing those goals can be assumed to lead to the correct action. In other words, if we are thinking like the users and we are just assuming the knowledge that we have from operating the interface at the time, so the flow so far, the screens and the scenes we have seen so far, can we assume that what they know at the time will lead to the correct action? And there is this idea of formal usability inspection. That is now something that I often do in my class. It's a combination of the above methods, and I'll walk you through it a little bit. So this is something I often do in classes. So the idea is to assemble stakeholders. So this could be different kinds of designers and also users, and then also product owners and all the kinds of stakeholders you can imagine for a project, and assign roles to them. Then you're going to distribute the design artifacts. So there is a team that is essentially reviewing the interface. And they will receive the design artifacts. So this could be the personas, the storyboards, or any kind of scenarios, so narrative storyboards. And also obviously any kind of interface prototypes, because that is what they're going to be looking at. So these could be paper prototypes or an existing kind of implementation in the form of a digital prototype or even a working interface on an XR device. And then they will inspect the design. So they will actually go through this and look at it from the principles and guidelines that they know about good XR design, and also things that may not be as good. So essentially they're performing a crit, a design crit of your interface. And then once the team has finished inspecting, there is a courtroom style meeting. So this is a moderated meeting, usually by an independent moderator, and there is a design team, those that have created the interface, and a critique team. And so the critique team will provide their critique, and the design team gets to defend and rebut some of the things. And it's usually supposed to be a constructive criticism and a constructive discussion, a lively discussion around some of the issues. Often design is about trade-offs and compromises, and so this is an interesting type of conversation that I think is very interesting. So I often do this kind of formal usability inspection in my classes. So we have like two teams. One is design team first, and then the inspection team, and then the other way around. So they review each other's designs, and then they meet in the classroom, and then they hold this courtroom style meeting and discuss their design choices and the rationale behind everything. And then they get feedback that way. Now the important thing after this is how to prioritize and decide on which of the defects to fix. This is really important. So after any kind of usability evaluation, in this case the inspection, you will get feedback. Now if this is done by experts, you can assume the feedback to be correct and valuable at least. And so, but independent of who gives the feedback, I would always take into consideration the whole thing. And not just like, okay, if you fix this, implement this, we change this, don't make all these promises. Listen, take it in, reflect on it, and then prioritize, and then decide on what to fix. You do not, most of the time you don't have the time to fix everything, and I don't expect that, but I do think it's very important to show that you have considered the feedback, you have reflected on it, and that's the way to work with feedback. So let's look at the next method, usability testing. So I said usability testing involves users, and here are common usability metrics: effectiveness, efficiency, satisfaction, learnability, memorability, and I say predictability here. So effectiveness means that users can complete the task accurately. Efficiency, users can perform tasks quickly and easily. Satisfaction, users will think the interface is pleasant to use. Learnability and memorability are not the same thing. So learnability is about the idea of accomplishing tasks the first time they see the interface, and memorability, it's easy to re-establish proficiency after not using the interface for a while. So most user studies usually don't look too much into memorability. There are specific user studies designed to look into memorability. So for example, there are experiments around gesture guessability and memorization. And those experiments then bring back users after a certain time, so maybe a day later or even a week later. And that way you can assess memorability. And then predictability, whether the interface responds as expected. Now these are relatively common usability metrics. For these, there are some kind of questionnaires that we are often using, some kind of instruments. Efficiency you can measure in terms of time, so we call this time on task. User satisfaction and effectiveness would be through subjective feedback, so self-reported, for example, Likert scale items, from strongly agree to strongly disagree with a certain statement. I thought this interface was pleasant to use, for example. So these are relatively common usability metrics, and then I thought, okay, what are the things that we should care about when it comes to XR? And so I add a few here, and you could come up with additional ones, but these are the ones that I came up with thinking about this. What is specific to XR? So I think when it comes to XR, we really have to think about the realism. So whether an interface, especially in VR, invokes feelings of presence. Now, I said presence and immersion, there are specific instruments, kind of like type of questionnaires for that, and that doesn't directly relate to usability. But there is this interesting trade-off between making an interface realistic and making it usable. Not everything in the real world is simple and easy to use, and so I just think it is an interesting consideration to add here. Safety, very important. You should really have as little as possible risk of physical or mental harm. So mental, really also emotional or psychological harm. So really those things are no-goes, and that's something obviously any kind of risk of that would really deter from the usability of the interface. Flexibility, now that's a little bit of a vague metric here, but I was thinking, in XR, we want to support different kinds of input modalities, so not just gesture, but also speech, or sometimes even multi-modal gesture and speech. So I think with XR interfaces, it's very important to support alternate modes of input. So provide that flexibility, and having that additional support, so these alternate modes of input can also increase the complexity of an interface, and that may again detract from the usability. Finally, comfort is something that we should somehow think about measuring, because especially with headsets, so both VR but also AR, extended use might actually be something that is hard to achieve. And again, if something is not comfortable, that may also have to do with usability. So for example, if you're requiring certain gestures to be performed or relatively long or complicated speech commands, then you will also see that the comfort levels are relatively low. So these are additional dimensions, and they're relatively unique to XR, at least the way I interpret these terms here. And together we now have a comprehensive set of metrics and things we can look at when it comes to usability testing with users. Again, it's on us to translate some of these into real instruments. I mentioned presence and immersion questionnaires, and I'll link those as resources. Then obviously Likert scale ratings and self-reported scales for several of the qualitative measures. And then we do have quantitative ways of measuring some things. You have to structure the usability test into tasks. And then there's this idea of assuming a perfectly solved task, so basically this model task, and using this model task you can also then determine the efficiency of users, how much do they actually differ from that perfect execution of the task, for example. Finally, I wanted to talk about automated usability testing. So automated usability testing basically comes in three main forms. There's this idea of custom logging and log analysis. So you basically add additional things into your interfaces when you're programming them. So to keep track of what users are doing and generate some kind of user-related events. And then you can collect those in a database and later perform log analysis. So log analysis is often used to figure out how users, for example, navigate through an interface. What are the common paths? And then you can think about how many sequences do they need. So how many steps in the path? And is there like an optimal path? And can we actually make it simpler? Should we remove some of the paths? Maybe there are too many options. And so these kinds of log analyses help you to actually, well, optimize an interface. They are platform-based analytics tools. In fact, Unity comes with a form of analytics. Now, these analytics are usually more about user retention or player retention and whether or not, how often users use an interface and where, and like the geography and basically a little bit of demographics, but not too much really about the internal usage of the interface. So this is really what you have to accomplish through custom logging and log analysis. And then there is a new set of tools out there. Dedicated XR analytics tools is what I say here. We have also worked on one in our own research on the mixed reality analytics toolkit. I'll talk about this a little bit later. But there are tools out there like Cognitive 3D and others. I provide them as resources to you. I don't have too much experience working with them. They are common in the sense that they are actually quite good in terms of collecting data and visualizing data. They produce nicely looking heat maps. The really hard part is the making sense of it. So that is just something that we still have to figure out. What are the best ways to actually assess the user experience in XR? Are there new kinds of metrics? Is there something we can do automatically? I think especially on the accessibility side, there are things we can look at more or less in an automated way. Just like if you think about web design, we have really good sets of tools from the W3C on web accessibility. We have relatively poor support on web usability. I mean, we do have tools that allow us to perform online user tests and things like that. So more like tools that wrap around user studies, but not really automatically determining a usability score. These automated tools can help so and so much, as I said, really on the accessibility side. So you can, for example, look at the contrast of elements. So especially in AR, that's very interesting. AR and against the sunlight with like a visor display, kind of display, like with a HoloLens, very difficult to see anything. And so you can find those things by doing simple color tests and checking for the contrast and the saturation and those kinds of things. So those things can be implemented, and there is also research on that. But that a tool tells you automatically whether your interface will be usable or not, well, no such thing. I must tell you though, in theory, it must be possible, because when I look at an interface, I have a certain intuition whether something is usable or not. I'm not always right, but it's just like this intuition that I wished we would develop. And that intuition you can develop, embracing the guidelines I talked about, doing more and more of your own extra projects and developing experience that way, which will allow you in the future to make some of these assessments. Again, none of this, you could be this perfect expert designer, like you could be Superman. You can never really predict the usability of an interface unless you really test it with users. So think of these methods as different kinds of tools that together will help you. And again, consider factors such as time and budget, or the experience in your team, or any kind of limitations that you have that will help you choose the right method. In this video, we're going to talk about creating your XR design portfolio. Now, if you've taken the course and especially worked on some of the honors content, you've actually more or less completed a project step by step by following all the assignments. Now, the cool thing about that is that this is really an important byproduct of this course. I mean, obviously this project helps you learn about the methods and tools because you practice them, but also it might actually be something cool that you can add to your CV. And the question is, what's the best way to build this portfolio, an XR design portfolio? And so this is what this video is about. I want to give you a few tips. Obviously, I've worked with a lot of students, and in my courses, I usually actually make it an assignment and an exercise to build out that portfolio. And I think it's always a good idea after every project to go through some of these steps and really properly document it. Now, the one thing I want to say before we get started, it is very important that even throughout the project, you do a really, really good job documenting everything and taking pictures and kind of like writing already some of these materials that I'll tell you about. This should not happen at the end, because at the end it's often too late. Often you don't have access to all the prototypes anymore, and you'll be very sad when something is missing. And so really, with this view towards building a portfolio, keep this always in mind even as you're working on your projects. But now let's get started. So an XR design portfolio starts from a problem. And we talked a lot about finding good problems, ideation and problem framing, and scoping, which are really, really important things to do. Otherwise, we're taking on something too big, too challenging, or actually not clear enough as a problem. So you want to be very clear about the problem. So then we actually need to describe our method or methods that we use throughout. Most of you will probably have followed the methods that I taught in this course here. And so this is a more traditional interaction design method, but applied or adapted for XR. And then also you should discuss your results. Yeah, you show off what you've done and you document the design evolution. So not just the final thing, but also the intermediary steps, your design concept initially, your personas, storyboards, all those are design artifacts. So not just the prototypes, not just the final prototype. Really, really important to keep that in mind. And now it's very important to connect these three things with a story. That story has to be clear from the beginning to the end. There has to be a red thread through your design portfolio. Now that story is easier to do if it's just for one project, and it's harder to tell if you're trying to describe multiple projects you've worked on as part of your portfolio. Now this is just something that I can tell you based on the experience of working with students. Now, I did not have to apply for a lot of jobs in the XR industry. I'm still a professor here at the University of Michigan, but I do work with a lot of people that want to recruit. In fact, several of my students have now landed a job, and that makes me really proud of them, obviously. That's really cool. And I think it is important that you take these application processes really, really seriously, and that you try to do the best job you can when putting together your portfolio. So what are the key components? These are the 5 key components. A problem statement. This has to be concise, it has to be clear, it has to feel important. I'll tell you more about it. Physical prototypes. You should really include those physical prototypes, because that's what you have done essentially as part of your project. Physical prototypes are really cool because they think without technological constraints. This is where you can demonstrate that you can think outside the box, which is really, really important. Be creative. And then digital prototypes are much more about showing that you master these technologies, that you can use the digital prototyping tools or tools like WebXR and then maybe A-Frame and Unity and Unreal. But this is really what you want to demonstrate here. And then every project and portfolio really has to translate to some lessons learned and some experience and skills gained. And I would spell those out. Really, it's important to say explicitly what you have learned, both about the problem and then the prototypes that you have created and the projects, and like you, obviously as a designer, how you have grown. That is something you should really, really tell in this last part. So I'll go over each of these parts now and, provide more detail for each of them. So in the problem statement, I think it's very important that you say, it's a significant design problem. So when it comes to the problem statement, it's very important that you have a design problem that you're talking about, not an information problem. So the problem shouldn't be like, what's the best way to find and compile that information? The problem needs to be a significant design problem. What's the best way to design this interaction? Okay, so I'll just say it like that. And if you run into this issue of not knowing what kind of information needs to go into your interface, then you're not working on a design problem, you're working on an information problem. And that kind of information dashboard problem is not always a good problem to talk about in these kinds of design portfolios. So you really need to be clear about the strengths of XR, and X here is really the placeholder because you need to be more specific. So why did you use AR or why did you use VR? What did you learn about AR and VR for this problem? Why do you think it is a good solution? What makes you choose AR or VR for this solution? And for problems where both an AR or VR solution seems feasible, and you probably just did one of them, you should really explain why you chose the AR or VR version of it. Maybe a lot of things were already explored in VR and you just wanted to see how much is possible in AR. Or maybe you have a different reason, but it's important that you actually state it. Next, when it comes to the physical prototypes, it's very important that you highlight the advanced use of paper prototyping. A lot of people want to see that you think outside the box. They want to look at these physical prototypes. They want to get a sense for a larger design concept that raises all kinds of interesting issues. In digital prototyping, we usually make a lot of compromises because of the technologies and other kinds of concerns like budget, time, and money. But when it comes to physical prototyping, you can do whatever. This is really the place where you can live out your creativity, and you should show it. And I want to emphasize here that from the physical prototypes, it should be clear that you are designing for an AR or VR environment. I actually want to see that. Now, often this is accomplished through some kind of color coding where I can see the physical world, mostly black, and then the augmented world, some kind of blue, green, or red or something. So this is often done to tell the story already in the storyboards, and then obviously also in the physical prototypes. Again, as a reminder, when I say storyboards, I mean the wireframes that actually form the foundation of what becomes a paper prototype or a physical prototype later. When I say physical prototype, I often think of this idea of bringing in additional media like transparency for AR, and then clay for 3D modeling and those kinds of things. And don't be afraid of just doing these methods that I teach here and just doing them well. That is already a really good accomplishment. Not everybody uses the methods here, and so I think this already should give you a little bit of an edge when it comes to portfolios. Be clear about AR, VR prototyping differences. So that's something that I think we learn more the more prototypes we do. But some things are just easier to prototype for VR and some things are easier to prototype for AR. So for example, because VR usually requires an entire environment, unless you are in an environment that is close to it, it's often a little harder. And the same is actually true with AR, but sometimes we can simulate it better. And AR, maybe the actual 360 or the skybox around the user doesn't matter as much. It's more like how the interactions relate to the physical world. And then AR, prototyping AR physically actually can become easier. And then when you move to digital, actually prototyping AR is harder. I find those differences very interesting. Now, this is not always true for every project that I've worked on, and it may also be different for different kinds of tools that I'm using. But this is more or less a takeaway from my past few years of prototyping AR and VR experiences. Next, digital prototypes. So let's talk about digital prototypes. When talking about digital prototypes, it's often hard to know how to get started. So often we tell this story from the physical prototypes and how our designs evolved into the digital prototypes. And then we kind of like get lost sometimes in some of the details, or we don't really do a good job explaining the strengths and the weaknesses of our digital prototypes. So the best way, I think, to structure a presentation of a digital prototype is to just break it down in terms of the key interactions that you've prototyped. So be clear about the interactions you chose to prototype. There might be many more things, but you chose to prototype those 3 key interactions. For example, everybody knows there is a login screen and you did not prototype the login screen. First of all, because Michael would yell at you, because that's what you really don't do, because we prototype the things we don't know so much about. We prototype the unknowns so that we learn more about it. That's what I told you, and that's this message that you should carry on and tell the other person as well. Explain why you chose each tool and what for. That's really important. So in digital prototyping, there's a lot of tools involved usually, not just Unity or not just like one type of tool. It's often some kind of patchwork process between these tools, some kind of workflow that is a little messy, but that's just how it is. And so it's important to demonstrate that you know the tools and that you understand their role and their relevance in the larger process, and that's what you should talk about. Obviously, there's often an opportunity to connect with somebody who has experience sharing the same pain points with an existing tool, so that could be a good opportunity as well to share some of these experiences. It's also very, very important to talk about the limitations of the tools and how you dealt with them. So every tool has a ceiling, we talked about that. And so it's important, if you felt that ceiling, then it's important. There are often very creative solutions around it, and I would stress and emphasize those. When it comes to emphasizing your skills with the tools, I think that's a really good approach. So now we have talked about the problem, we have explored the problem more through physical prototyping, and then we are nearing our solution with a digital prototype. After the digital prototype could be an actual development with some AR devices, platforms, and tools out there, but I'll just leave it here because at this point in the course, you would have concluded the course, and so you should talk about your lessons learned. And I think just from all that knowledge that you've gathered by building on your prototypes and doing the ideation and the problem framing, you've learned a lot, and there's a lot to talk about. So you can now already talk about the lessons learned. For example, what was hard, easy, or surprising to you? I would stress those things, especially the surprising part. But make sure that the surprising part to you is not straightforward to anybody else. So, for example, that prototyping VR or AR is hard with paper and that this is surprising to you, okay, that's fine. It's the first time you do it, maybe that's fine. But there should be something more specific to your project that you found surprising or hard to do. If something was easy, I wouldn't emphasize it as much. It's just much more interesting to talk about the challenges. And again, something surprising, if it's truly surprising, can actually be a really, really cool part of the story to tell in your portfolio. You should really also talk about what worked well and didn't work well in your team. Assuming that you've worked in a team, I think talking about those experiences working collaboratively on projects are very interesting. A lot of students come to my office hours to talk about issues and challenges they face with the team, and I usually encourage them and tell them, you know what, this is good that this happened, because now you have something to talk about in an interview, because you need to get out of this, you need to actually work with your team, and so then you have a story to tell, and that's what you should focus on. So all these challenges that you face throughout the project are the really, really important things to talk about, so keep that in mind. Finally, this is something that an interviewer or a professor usually asks at the end of a master thesis or bachelor thesis or some kind of research project. So if you could do it all over again, what would you do differently? And that's an interesting question because often you know better later. And so in retrospect or in hindsight, maybe you could have done things differently. And so it's very interesting to consider that and at least have this prepped. Even if you don't make it part of your portfolio, it might still be a question that comes up in an interview, so think about it. Finally, we're talking about the experience and skills. So the experience here, I mean your experience, how you have gained more experience from doing this project. And you should emphasize, again, any kind of advanced usage of techniques. I encourage you to even talk about just the physical prototyping techniques that we've learned in the course here, because I do think they are actually still innovative. They are not standard, they are not straightforward, and they are still improving and evolving. So yes, describe what you've learned from practicing these methods and applying these techniques. Also, what I often find very interesting is when a student that has previously done projects in interaction design or graphic design, and they have very sophisticated skills in really popular tools out there like Photoshop, Sketch, or InVision, and Figma, and XD, and all these prototyping tools out there, if they still exist by the time of this recording, well, these are popular prototyping tools, and they are not actually designed for AR or VR, at least not at this stage. So if you can demonstrate how you have used those tools to support your innovative prototyping, I think that is really cool. So for example, when it comes to 360 templates and 360 paper prototyping, there is the grid, the VR grid, and there are articles that tell you how to use Photoshop. And so I think that's a really good way to demonstrate how you transition and how you transform some of these tools, how you adapt your own knowledge and your own methods to XR. So this ability to transform your own way of working, I think that is super powerful if you can demonstrate that. And finally, when it comes to AR, VR specific tools, so I mean both like interaction design tools like Pro2IO that are starting to incorporate some support for AR, VR, and then more AR focused tools like Facebook's Spark AR Studio or Snapchat's Lens Studio. And then obviously really like broader platforms like WebXR, Unity, and even Unreal. So if you've used any of these tools as part of your projects, you should really emphasize what kinds of things you've learned with these tools and how you've grown your skills in these tools. Very important. These are the items that go into the portfolio. And in the next video, I'm going to tell you more about how I would actually tell the story. So these are the main ingredients that go into a portfolio, but not necessarily in this order. Also, when you do multiple projects, you don't actually have to do it in the order in which you have done the projects. No, you should choose the order that best fits the story. And so we're going to talk a little bit about how to present a portfolio, how to present a project in the next video. So in this video, we're going to talk about 5 common weaknesses of XR design presentations. Now, as a professor, I see a lot of presentations, and here are a few tips and things that I think we should change and improve. And then we're going to go through that effort together. We're going to put together an XR design presentation. First, we're going to use a normal structure, maybe the one that immediately comes to mind. And then we're going to make adjustments to emphasize tried and tested techniques. And this is really to emphasize my approach. You don't have to do it exactly like me, but I have had some good success in terms of presentations and coaching students that way. I think their presentations were very well received and I was very proud of them, so that's at least something. In this video, we're going to first talk about the trouble with XR design presentations. Now, as I said, I see a lot of presentations all the time. Obviously, as a researcher and as an instructor, we do a lot of XR projects. I participate in a lot of research and I see a lot of presentations and new projects and, you know, please invest into this idea kind of thing. And so, yeah, I feel like there are these 5 common things that I always find not annoying, but like so repetitive. I don't know who teaches it to do it this way. Is it our intuition that tells us to do it this way? Well, we'll figure it out. And I make a few adjustments here and there, and let's see. I encourage you to incorporate those into your own practice and try it out. You know, it could be a transition from the kinds of things that you're used to a little bit different. And so let's look at it together. So here we go. All right, so the trouble with XR design presentations. On the left, I'll start out with the issues that I see. Often the slides are designed to support the presenter, which makes sense, right? You feel like, I need to remember all those things, so you create slides to support you as a presenter. Now this is both you presenting a design project, but also you presenting a research project. I've seen this a lot. And all the time the slides are, well, designed to support the presenter, to help them remember, but not the audience. And so I'm going to talk about that in a second. Not really framing the work. You're not really telling me what the problem is. I really need to know what the problem is. I thought we talked about ideation and problem framing, so really motivate the work and frame it and scope it properly and tell me what it is about. A very concise problem statement at the beginning. Demo last. Yeah, a lot of these presentations, they come, I mean, if they're well done, they have a really nice story and they go on forever and they prepare us to finally, in the last slide before we wrap up, we finally get to see the work, the demo last approach. Very unfortunate, but so commonly done, so maybe we can do it differently. When we talk about implementation, we focus on the technical solutions. Like, oh, we used WebXR and A-Frame, and I used this and that package in Unity, and that was really what solved it. Fine, but solved what? What is the problem? What were the challenges? Ah, and now it's starting to make sense. And then there is this section usually in presentations which is called future work. And when I see those presentations, they often read like future things I have to fix. So future things I didn't get to implement. Future things I didn't get to do. Future things I still have to do, implement, design, whatnot. But that's not future work. It's not about your future work. So here are my suggestions. Okay? First of all, we do the slides and we design them to support the presentation, especially the audience, not just the presenter. Make it visual, not just bullet points. I mean, this is a really bad slide as an example, but you know, I need to get across the message here. And then, not really framing the work. Well, how about stating the problem using an example and choosing an example that a lot of people can relate to? Something simple, not too complex, and it'll be crystal clear. Instead of demo last, try the demo first. Really, like after a little bit of problem description, here is our demo, and then I'll tell you how we did it. This is a really refreshing way to actually approach a design presentation, so don't leave the demo until the end. Don't make me wait for it. Implementation focused on design challenges compromises, I think, is a much better way to do it than here is the few technologies we chose and we don't tell you why. We don't tell you about the challenges. We don't tell you how we had to make those compromises. So structure your implementation around that, not just like the buzzwords and all the tech, but really why. Why did you implement those kinds of things the way you did? Finally, instead of future work, aka things I have to do, things I have to fix, how about thinking about it this way? Future work, as in like future research and design that others could do, building on this knowledge. So you're telling others how to take this work further. That is really important. There's quite a difference. And so you should think about it this way. So this was really important to me. And now we're going to make it a little bit more actionable by actually looking at how to, well, fix the standard presentation format that I always get to see as the first draft. And so here we go. XR design presentation. Okay, we have an intro. We talk about our physical prototypes, digital prototypes. Maybe we do a demo, almost last, as I said, right? And then we summarize. We provide a conclusion or something like that. Yeah, pretty common, pretty standard. Okay, so what goes into the introduction? Yeah, how about you make it a motivation? Okay, so you make it a motivation and you use it in an example. And that example is designed to motivate the problem, and actually it needs to be to the point, like it needs to be very clear. You need to prep the problem statement. And the problem statement needs to be clear and concise. And you might even write it out. Our problem is, and then text, something short, not a really long, not a lorem ipsum lorem, but a short, concise statement. That would be great. So instead of the physical prototypes, digital prototypes, and then the demonstration, we're gonna do the demonstration next, right after the motivation. I've just motivated the problem, and here is what we have done. And now what would be super cool is if you gave a live demo, right? Run that thing, maybe using mixed reality capture so that other people can see better what's going on in the world, in the virtual world around you as you're like stepping into this virtual world. If you don't know exactly what mixed reality capture is, well, very briefly, it's like basically a view on you from the outside, but we can see how the virtual reality or augmented reality content actually relates to you. We basically see it from the perspective of the camera, where we see both you and the virtual content around you. Very cool way to capture this kind of things. And we have done this in the What is XR lecture, in the very first course, in the very first week. And I've used these techniques throughout the MOOC, and so maybe you thought this was actually pretty cool. Turns out it's not too hard to do. Okay, your backup is a recorded presentation, and you should always have that backup. It's very important. Have a backup, okay, and have it recorded. So on the day when usually everything goes wrong, on the day of the demonstration, and you're trying to do this live demo, if something goes wrong, if you're like anything like me, you'll probably get a little nervous and maybe even angry at yourself, and that's not good. So you have to have that knowledge, that comfort that you have this backup video, this backup recording, and then you just use it to switch it. Then you just use it and you switch to it, and you don't apologize too often. This is more like a note to self, because I keep apologizing all the time. But it's not a good use of your time. Okay, so instead of physical prototypes and digital prototypes, you structure this around design evolution, because that's why we did those prototypes, okay? And then you talk about the prototypes, but only a select few. Just the key iterations, the most important ones. Not like, what I see a lot in presentations is like people are trying to tell me how much work they did. So they're showing me all the prototypes they have done, and it's definitely impressive. It's cool, all the sketches and blah. But it's really difficult to follow and actually extract really how did this thing progress? How did the design evolve? And so it's very important to structure your presentation around a select few prototypes and then really spell out the decisions. So you do the prototypes to create choices, and then you make choices. And as you're making those choices, you need to provide a good design rationale for those choices. And those are the three key things that I want to see. The prototypes, the decisions, and the rationale. Very important. And now we have done motivation, demonstration, design, evolution, and then we're going to do the summary. And now on to the last part. Instead of summary, focus on the lessons learned. Really how you have grown, right? We've just discussed all the things that go into the design portfolio, and I said lessons learned and skills and those things are really important. You need to spell it out. So this is where this goes. Lessons learned, and then the limitations, so the compromises you had to make, and basically the assumptions you decided to make, and the limitations that result from this. And then comes the really key part, future work. And again, future work is not like things you have to do in the future. No, what can others do building on the knowledge of your work? That is, you're basically telling me what I can do with the knowledge. What could others do in the future, or what might you do in the future? I mean, that's fine. But the most important thing is don't talk about all the little things you need to fix to make it better. That doesn't help anybody, right? So you're so deep down in your project, and I understand how this happens. You just finished it. You're excited to give this presentation. You didn't have enough time to actually zoom out. But as part of the presentation, that project presentation, you really have to zoom out and you have to tell us this bigger story. And then there might be a questions part in your presentation, and the way you navigate the questions and how you're demonstrating this ability to go down into the detail, picking this design rationale, bringing it up, maybe even questioning it yourself, considering the other idea that the person that critiqued you had, and then not being too defensive, but like embracing that idea and providing an opinion about that idea, maybe suggesting another issue. While that idea sounds really cool, and I admit we haven't looked at it, there could be these other problems coming from this, because in my experience, what I've learned from this project, we had this problem. And sorry, I forgot to tell you this. No, you don't do this, sorry. We don't apologize. We don't apologize, okay? Now we should have all the things we need to do really cool design, and then also tell the story about those designs. Okay, so good luck. If you're using the materials from this course, especially if you're doing the honors track stuff, so I think there should be a lot of little things that you can add to your portfolio, and now combined with this lecture, you also can use it as a guideline or a set of guidelines to give a nice little presentation about it. And let me know how it goes. I'm always eager to hear how it's going with my students. Welcome. So I'm going to have a conversation with Katie Lewis. Katie Lewis used to work in my lab. We've actually worked together for 2 years. I got to know her in a design jam, in fact, and then, liked her a lot. She's a really great student, and now she's out there in the world, graduated. And so I thought, hey, Katie, can we chat? You and I had lots of discussions around portfolios, and you were so experienced. So we've done this actually before. I've invited her to a few of my classes. So I'm looking forward to having a conversation with Katie about design portfolios and how it's out there, working a little bit in the XR space. So, Katie, how's it going?
It's going well. So right now I work at IBM as a UX designer, but I also was working recently on a team working in XR for data visualizations. And so I've gotten some real world experience to apply my academic education towards. But everything, yeah, is good.
Okay, that's great. So, I mean, you know, you didn't have the traditional kind of like, I just do my bachelor and then I do my master's and then I don't even know whether that's traditional, but I remember your CV was a little unique. So can you tell us a little bit more about your background even before you joined Michigan?
Yeah, absolutely. I came from the fine arts. So my bachelor's is actually in painting and printmaking. And after school, I explored the world of being a fine artist and gradually adapted more of a digital approach to creating things, interfaces, websites. And so I kind of stumbled upon HCI and fell in love with the idea of using psychology to create interesting experiences with technology. And so I realized that I had 10 years of actual experience, but I really wanted a strong foundation in understanding all of those principles of HCI. So that's kind of what brought me back to grad school.
Cool. All right. So then we've worked together on a few projects. I mean, what have we done? So a few research papers together, I think. You did a master thesis. You obviously graduated from the program, and you took at least one of my courses. Or did you take both of them? I don't remember.
No, it's advanced AR.
Okay, so the more technical, so that would translate to the development-oriented course in our MOOC. So yeah, that's great. And you said originally you were a designer. And how would you describe yourself today? Are you a designer or a developer?
I would say I'm a designer, but having development skills has been very helpful for, you know, being able to ideate on concepts and create something that's functional to show people my ideas. So I would say I'm a designer that uses all the tools that I can get my hands on.
That's great. Okay. And well, so today we're going to talk a little bit about your portfolio. And I thought we could bring it up and share it. And then we kept it like at a version that is almost like when you graduated, but your CV is updated, right? So this is like what we're going to look at today. That's so Katie, you have worked now at IBM for like several months. Is it already a year? I don't know.
A year. It's been a year.
Oh my God. Okay, time passes quickly. All right, so I'm going to bring up your portfolio. Katie, so this is the first thing we'll see when we go to your portfolio. Did you submit this? This is the website that you usually use to submit with your applications?
Yes.
All right, cool. So then you say UX designer and researcher here at the time and have a little bit of a statement about yourself. And so I'm kind of like functioning as a reviewer a little bit. And I'm basically seeing a number of really cool projects. You seem to have paid attention to, you know, choosing some representative screenshots, but tell us a little bit about how you went about designing this portfolio.
So I wanted to pick a variety of projects that kind of spoke to my different disciplines. So I wanted to really focus on XR here because when I was doing the job hunt, I was really looking to work in that space. And so I wanted people that came here to see that, you know, I have experience ideating on, you know, AR, VR work. And I also wanted to show that I have strong UX design skills because I was hoping to translate those into the, you know, XR space. And so I've got development projects, I have XR projects, but I also have straight up UX research and design projects as well. So I really wanted to focus on those kind of three domains.
Yeah, so these are all projects that I actually remember mostly from your time here. So you made a decision not to include a lot of your earlier work. Why did you make that decision?
So I wanted to really focus on those three domains, and I felt like the language that you create during the master's program really kind of is standard across the jobs I was applying to, where my research methodologies and my development capabilities, they were just not as strong because I didn't have the foundation that, you know, the education kind of gave me. So I felt like, while I could create a story out of my previous projects, they didn't resonate as well as what I was able to do during the courses.
Okay. Yeah, I understand. Okay, so that makes sense. And so it is, I mean, still impressive, right? This is 2 years of work. And we've actually done even additional projects. So you've picked some, but yeah. So
this hasn't been updated in a year, so
I need a few more pages now. Okay, you've been busy. Okay, now so let's look at this kind of like at the time of your graduation. I think this is very relevant to our learners. So which one should we talk a little bit more about in depth? I think this is something that also happens in interviews. They let you pick, or I mean, you can tell us what it was like for you when you applied, but which one would you want to talk about?
yeah, absolutely. I would love to talk about AR Kitchen.
All right, so walk us a little bit through it, and I can scroll down a little bit as you're talking about it.
Absolutely. So this project, when I was putting this together in this portfolio, I really wanted to stick to the storytelling aspect that, you know, kind of lent itself to this project really well. So I was working in Michael's lab, and a kitchen manufacturer came to us to create a showroom experience that leveraged AR and VR technology. And so with that problem space, we had the opportunity to ideate around a few different concepts, which, you know, involved like a lot of sketching at first, and then we kind of iterated into the digital space where we created several prototypes. And so yeah, so you'll see some kind of initial concepts where we were looking into projected AR experiences. And so this was a really great opportunity for our team to explore research associated with projected augmented reality, as well as some like kind of commercial ideas. And so, yeah, so there was lots of cardboard and lots of using the lab to kind of mimic what a kitchen showroom might look like. And we're even able to leverage some of our paper prototyping skills that I'm sure Michael has talked about before. And so
Still preaching. I still believe this is the way to go. But yes, paper prototyping, cool.
But it helped us really iterate through a lot of ideas quickly to see what, you know, like what kind of interfaces we wanted to develop. And so if you scroll down a little bit, this is kind of where we landed on prototypes. So we defined that having a controller for a showroom host to then be able to operate and customize a kitchen cabinet projection for a customer was kind of the realm we wanted to stay in. And so we developed a VR version that could provide a 360 view of the cabinets, as well as an AR version that could show the cabinetry within the space for the customer, but then they also control the projected screens. And so with this, we developed like 4 different prototypes to then show the cabinet manufacturer like the possibilities that XR could provide.
Yeah, so 4, you said, okay, so let's talk about, so tablet, you talked us through mobile AR, so that's cool. And then here we have the projection, and here we have a mini kitchen projection. And we did a good job, right? We involved the stakeholders and everything throughout the project. And there was even a 5th prototype, which is like crazy custom display prototype.
Oh, yes. Mm-hmm.
That nobody liked. But okay.
The hologram.
The hologram. Yeah, I was very passionate about that, building my custom screen and trying to, convey that idea. But okay, so then you demos and interviews. Cool. So we have essentially, okay, so from a portfolio perspective, it seems like you're like picking really prominent screenshots and like photos, have a little bit of a teaser image, story, who is involved, maybe what kinds of tools you used, what kinds of skills and experience you gained. That's something I'll read when I read across your portfolio as well. And then it's very visual. So I really like how you made it visual and very appealing actually. So so from your experience, is this a project that you usually talked about at the time in some of your interviews?
Yes, it usually came up because it definitely leveraged all of the skills that I really wanted to show to potential employers. So it showed creative thinking, it showed using low fidelity to high fidelity prototyping, which is incredibly valuable in the workspace when resources are really expensive. It also showed my development capabilities as well as being able to like craft pieces for customers and then being able to demo those back to executive stakeholders. So I felt like it was a really like thorough project that helped leverage everything that I have.
Cool. All right, let's go back to your portfolio overview. Is there, what else should we talk about? Well, what do you feel? What else would you like to share about your portfolio?
Let's see. I believe that I could show a little bit more UX research work. And so maybe Together Chicago is a good example of that.
Okay.
And this is traditional like UX research and development work. I worked with a team from the University of Michigan engineering department. And and so we were, again, provided with a problem by a stakeholder, which was a nonprofit called Together Chicago. And they were looking to develop a mapping interface to help provide resources to the people of Chicago, connect resources that other nonprofits were providing to people that needed them. And so with this mapping interface, again, we were able to start at a very low fidelity and have many rounds of iteration and testing. And then we were able to develop different levels of fidelity and provide that testing back to the stakeholders, to users. And so we were able to gather a lot of data and then provide iterations on that. And so with this project, I really wanted to show my capabilities of not only development, but also being able to iterate and test on those developed interfaces.
Well, thanks, Katie, for that review and letting us see some of your portfolio items and pieces. And there's a lot of love in each of these projects, so I can see that, and great care. So one thing that came through is you wanted to build a solid foundation. This is my UX skills, and then here's some of my more experimental, the research that you did, and XR-oriented projects. Did you think you have to aim for that kind of mix of projects, striving some balance between the crazy XR and the foundational UX? What went into your thinking when you put that portfolio together?
I don't think it's entirely necessary. I think it really just depends on, showcasing your experiences that you've had and being able to use all the skills that you've created to then, get the jobs that you want. That just happened to be an experience that I had that really impacted the way I work with development, the way I work with stakeholders. And so I felt like that was a really representative project. But if that project had been XR, then that would have been the story I would be telling. But it was more around the experience of working on a multidisciplinary team that I really wanted to talk about.
Okay. So, and then how did the interviews go? Any kind of experience you want to share there with us? Did it go was the portfolio really helpful? Were you able to drive the conversations? How do you think about those things?
So I think the portfolio is just a visual representation of how you tell your story. So it helped me to define what those stories are, so that when I walk into the interview, I'm able to talk about in depth things that worked, things that didn't work. I'm able to recall those stories really well because I crafted them, in this place that a reviewer can go and look and be able to also get that experience. I feel like it's a great exercise to help you be able to tell those stories easier when you're under the pressure of an interview.
Yeah. Okay. Which I hope you're not at the moment, but
No.
All right, cool, Katie. So, well, there's this other thing I wanted to ask you. So, right now you've been working at IBM as a UX researcher and designer for a year, you said. And so, how did you translate or take some of these extra things you've learned into that job? Can you tell us a little bit about that?
Yeah, so you're right. So I'm currently working as a UX designer on a product that is not XR, but I have found a way to manage all of my interests in XR while still being a part of IBM. So I helped, with a coworker, I helped found the IBM Reality Lab, which is an interest group at IBM, kind of like a club, where we meet and we talk about XR, we do development demos. We're kind of like a make lab, but within the IBM space. So even though you don't necessarily have a role of XR, you can still impact the company you work in with your interests. So I found, being able to do that has really helped kind of balance my passions at work, and has also opened opportunities for me to be able to do XR on other projects with other people at IBM, which has been really great.
So are there any last thoughts? Our learners are like learning all this XR stuff at the moment, kind of like the way you did it as well. Obviously, everybody's unique. You had a very professional background in design. You could always sketch better than me. In fact, I show some of the things you've done, like the Star Trek. I show that, and I say it's Katie. So this is actually the Katie. But yeah, so if a learner asks you, what shall I do? Do you have some kind of advice for me? Should I pursue XR more, or should I do something else? Any last thoughts you have for our learners?
Yeah, well, I mean, it seems like you're in the right place. So, the internet has so many resources available, and, right now is like a wonderful time to explore and dive into all these new technologies. And so I feel like, just grab a hold of anything that you can find online, like this book, and, learn as much as you can. And any employer that you go after with, this educational experience will be really excited that they found someone that can teach themselves new skills.
Yeah, that's that's a really good point. Cool. All right. So, well, thanks, Katie, for spending some time with us today and looking at your portfolio together and allowing me to look at the older version rather than the latest. So that was very nice. So we have a snapshot of Katie in from a year ago. So, but we also had the Katie here. So thanks, Katie, again for speaking with us, and hope to see you soon again. Okay, stay healthy and safe. Congratulations, you've reached the end of the course. The second course is part of the XMOOC, the course focused on design. And I hope you've enjoyed it. I feel like we've covered a lot of ground, and I hope you feel like you've learned something. So let's review a little bit of what this course was about and what should be the main takeaways. So, well, we started out with this overview, and you have probably finished the 4 quizzes. to assess your learning. The first quiz focused on some of the what doing XR involves and how to get started and XR process questions. So I hope you finished some of the quizzes and learned a lot through doing the quizzes as well. But in terms of topics, we've covered what doing XR involves, how to get started, and finding your XR process. And then we've covered quite a bit on design thinking. So really starting out with the original method and then adapting it to XR. And then thinking about all the issues around design ethics, design guidelines. Then we did design critiques. And we also talked about design jams as a way of collaboratively solving problems through participatory or co-design with various stakeholders. And so that's like here. And that was only the first half of the course. And then we focused the second half of the course on physical and digital prototyping. And so we started with storyboarding first, then created paper, then physical prototypes, and we went into digital prototyping tools for AR and for VR, and also talked about immersive prototyping, actually using AR and VR for prototyping. So quite a lot of stuff. And so with those methods and tools in your toolbox, you should feel equipped for XR design. We haven't talked so much about the actual development, so programming with these technologies, but we have really well set our minds so that we can actually think about designing and actually doing the heavy lifting in terms of prototyping, already testing with users to some extent, and then prototyping both physically and digitally. And so that is really an important part of the process. It is not the entire XR process. We obviously still need to implement things, and that's where the other courses connect to this course. But before I get to that, let's quickly review. Obviously there was the honors track, and maybe you chose it, and that means you have completed all these exercises here. And these are important assignments. So from a design critique, looking at both the guidelines and the ethics of XR, and then storyboarding, your paper prototype, your digital prototype, and then also if you had the opportunity to do an immersive prototype. Again, as a reminder, immersive prototype means you're using actually AR and VR technologies and while you're designing, and so it's concurrent design and testing. As opposed to what happens a lot in development is like you're programming against these technologies, but on your computer usually, a desktop PC, and then you deploy. And I'll also tell you how to rapidly preview things, how to do quick deploys, and how to even avoid this by building on web technologies in some of the other courses as part of the XR MOOC. So let us review a little bit of what I think should be the key takeaways from this course. So if you remember, I started out with making an analogy to filmmaking. I talked about these various roles here on the left, director of photography, made the point that actually the person in charge of the camera is the XR user, talked about various aspects of design and who are the people involved, and then went into some of the more difficult topics where I think when it comes to creating new kinds of interactions, we still need to rely on developers and people who are okay with programming, because what you can do in existing tools is pretty limited. In existing prototyping tools, I mean. Because what you can do in existing prototyping tools is so far pretty limited. We talked about these different paths to being an XR creator, basically depending on your background, whether you are into web, game, or mobile development, you should have an easier or more direct path. And then if you are on the mobile development side, you can also continue developing against, and if you have a mobile development background, you can continue developing natively against the Android and iOS SDKs, but then also pick up specific AR versions, ARKit and AR Core for Apple and Google, so for Apple, for iOS and Android. Can develop for ARKit and AR Core, so for iOS and Android. And then can also develop natively against some of the virtual reality toolkits. And then we also have some kind of cross-platform approach through Unity and Unreal. We talked about that, which I think speaks relatively nicely to game developers, and then also mobile developers who are used to doing cross-platform development through PhoneGap and things like that. And then the web, and the role of the web, which I think is going to be even more in the next few years. But for now, we have a basic stack and set of things we can do in browsers. We are relatively well equipped on the VR side, and we're getting better on the AR side as well. And then I talked a lot about process. Need finding, brainstorming, storyboarding, and prototyping. And then we talked about development and testing, but we didn't cover that much in this course, but it's still part of the overall process. And together with deployment and analytics, that's something that we'll expand more in the third course as part of the XR MOOC. So the process was really actually one of the most important things for me to take away from this course. Obviously, we were looking a lot. Obviously, we were looking a lot into different kinds of methods for design and then also tools. But what is important is that you put the picture together. The puzzle pieces fit into a larger process. Now, that process is relatively standard. It's just an expansion from interaction design. So it's standard if you're used to user experience interaction design. But some of the methods actually need to change and adapt, which has to do with the fact that traditional need-finding methods, for example, don't really work because we don't actually have a lot of XR users at this stage. And we don't have a lot of problems directly in XR. We are more like figuring out which of these problems that we know from the world could actually benefit from a solution in XR. And that requires a slightly different approach. And so we talked a lot about that. We also spent time covering design thinking. So going through the 6-step method, empathize, define, ideate, prototype, test, and implement. So we covered all that. And again, I highlighted some of the things, if you remember from this lecture, that we cannot directly expect and translate. So because XR is different, we need to think about XR and design thinking for XR also a little bit differently. We talked about ethics, which I think was very, very important. And I tried to share a few techniques here and an approach, a design ethics review of XR applications. We did this in a scenario-based way. We looked at issues such as the context and situation, the sensory information and data that is being collected and processed, actually then the processing pipeline, which I think is really important to consider. And then also, once you have collected that data, how do you communicate first of all and get informed consent, but then also how do you maintain and even future use of this data is a very, very important topic. So we talked about all these kinds of ethical considerations. The one thing I want to say here is that this ethics topic is still evolving. It's very important, and not enough people actually embrace it in their approach. And so for me, it was very important that we get this right into the design course, that we don't have it like a future issue or some, I don't know, issue, afterthought. No, it has to be incorporated somehow. Now, when you teach this stuff, it's difficult to do both the ethical stuff and the guidelines, and then learning about the methods and the tools, and you know, elevating the ethics and the ethics standards. But I hope that having a dedicated lecture relatively early in this course raised at least your awareness and encouraged you to think about this more. And well, we will see what happens in the projects. I'll keep monitoring. I keep taking a look. I'm curious what kinds of projects you are designing as part of the honors track, and to which extent we raise interesting ethical issues. We are in this together. We are figuring this out together. So even if we make a mistake, well, we can still learn from it. So that is really, really important. And then I covered another important topic to me, which is ideation. Because XR is really the space where we seem to be trying out a lot of things, and not always in a very progressive way. So I tried to cover 7 techniques to help you innovate. I talked about, I drew parallels from research. I talked about, for example, that everything has to start from an idea, and that even the prototyping out of that idea, that helps you better understand the problem. Normally, probably you think about prototyping as learning more about the solution, but that's only partially true. It's true, but really prototyping to better understand the problem, because you can try out these prototypes with users. And obviously, this is you're already starting in the design process. So we looked at all these 7 techniques: ideate, implement, inspect, iterate, a design cycle. You know, the killer app problem, and you know, novelty versus creativity, they're not the same. And I talked about this quite a bit. The problem, promise, premise approach. emphasizing obviously the promise of XR technologies and then also the assumptions that you're making. One that is more inspired from research, but I think it helps, this idea of writing the intro first. Like before you write the rest of the paper, before you do the rest of your project, figure out what this project is about, what your contribution is, and that way you get to motivate the problem better and understand the problem better as well. We did talk about the idea hexagon. That's really something from Ramesh Reska that came out of one of his talks. And I really like it, and I wanted to cover it here because I do think it's a cool idea to think about how to take existing ideas further. As I said, everything starts from an idea. And then we talked a little bit more about some of the more interaction design oriented object control design matrix, this idea of rapidly brainstorming different kinds of ideas around objects and how to control them. We did the snow boots example or the ice scraper that can be shaken example, for example. So here we had really from the obscure to the really futuristic kinds of ideas that can come out that way. And I think it's an interesting way to innovate. And finally, we also talked about threshold and seeding and tool design, because a lot of us are thinking about creating tools in the XR space. And so I think it helps actually to have some metrics, talking about the threshold, the barrier to entry, and then the ceiling, what you can accomplish with that tool. Which I think you really want to set these nicely, and not everything should be like Unity or Unreal, which actually both have relatively high barriers to entry, which we haven't explored so much in this course, but that's what the third course focused on development is really dedicated to. So you'll feel the pain. That's what I usually say. Alright, and throughout this course I heavily emphasize storyboarding and prototyping, so a lot of storyboarding and wireframing, physical prototypes and digital prototypes. And then I drew out these different quadrants, and how do we actually increase the fidelity. So increasing fidelity and which of these methods are easy and which of these methods are hard. And I did this for storyboarding. Well, I talked about traditional paper-based storyboards, 360 storyboards, a 360 photo story, and then also 3D storyboarding. Still, which is immersive prototyping essentially, but you're doing it for this purpose of storyboarding. And I think this is one of my favorite new techniques that I definitely want to increase the usage. And that's one of my new favorite techniques that I definitely want to get better at myself. I talked about physical prototyping, how we can still start from paper, but then how we incorporate other media like clay, like Play-Doh for 3D modeling, and how we become more physical and build a diorama to actually, create these scenes that you have in mind, not just envision them, but actually prototype them out physically. And we also talked about a specific set of techniques that developed in my research, but also a lot of practitioners are looking at this, which is 360 paper prototyping. And then we went into digital prototyping. And here I talked about the different techniques distinguished between digital and immersive authoring. Digital authoring usually happening on a desktop computer, it's like desktop publishing. And then immersive authoring usually happens in AR or VR. So basically on a tablet or on a phone for AR, and then usually in a headset for VR, and then also specific versions of mixed reality also on a headset. We then also talked about some of the higher fidelity, harder to do, but really good approaches, web-based development, cross-platform development, and native development. So these approaches do, however, require programming skills, and we will focus, and as I said, the third course will be dedicated to taking the digital prototyping ideas further and really learning more about development using these three approaches. So I think throughout the course I wanted to make it clear how important prototyping really is. It does help us ask a lot of questions and find some answers. And in the process of finding some answers, we even create things. Like we establish requirements for sensing, tracking, for displays, and we produce assets. Even though they might not be the final assets, they might already be early placeholders, early props that we might use later in our prototypes and refine throughout. And we learn about user needs and skills, which is really, really important because we can test these prototypes already. And that's really also the last topic that I covered, which was designing a usability test or user study. So we talked a lot about evaluation. We talked about what goes into designing these kinds of things and preparing things in terms of goals. So what are the goals of your evaluation? Kinds of tasks. Who do you recruit? How do you recruit? What kinds of devices do you want to use? Any kind of metrics? And how do you actually do the analysis? So definitely quite a lot of stuff. And I feel like you should be well prepared with this knowledge to approach your next XR design project. Again, I hope you did participate in the honest track and actually chose to do some of the exercises. I think you'll learn a lot there as well. And what I'll do now in the last part is just telling you about some of the other courses and how this course relates to the other courses. Here we go. We are in the XR MOOC specialization. You have just finished the second course on XR design. And then in the first course, which you probably took already, but just a reminder, it's really an intro to XR. So if you had some issues with some of the terminology in this course, then the first course really sets all these basics and fundamentals. We talk about applications, concepts, technologies, really how AR, VR works behind the scenes. What does it actually make a virtual reality? And how does this really work? And then also the issues. And there are also honest track exercises and a lot of content. So for example, you do classify applications along the reality virtuality continuum. So basically figuring out whether an app is AR, VR, MR, or XR. And you should choose the most specific class. And then we did, or you would do an exercise on technology selection, which I think is really cool, going through some kind of XR decision tree. That I have a mental, basically this XR decision tree is a mental model of all the kinds of XR options you have when it comes to technologies, devices and platforms. And then we also talk in depth about the issues, the ethical, social, privacy, security, accessibility and equity issues. So lots of issues to talk about, and there are also exercises focused on that because it's important that you experience these things for yourself. Now, if you have just finished the second course, again, congratulations. And then the third course would focus on development. So there you would learn more about development methods and tools. You would actually create your first 3D scene. So taking something existing from a book or a movie, recreating it in 3D, and that way learning about 3D, making that jump from 2D to 3D really, really important. And then we are expanding our knowledge into the VR space. So we're learning how to create virtual reality scenes, basically the environmental design, but also things like physics, and then obviously interactions. And then we talk about AR, both marker-based and markerless AR, and how to design for both. And in each of these two last courses, there will be a project throughout, going through these stages, and then they will end with a peer review in each of these courses. And I think this peer review is really, really cool, really important. You get to hear from other learners what they think. Obviously, I also chime in and give you some feedback. And we do have some ideas in the future for actually coming together in some kind of exhibition. There might still be something that we will add to this course and also to some of the other courses. Now, this is a topic that I'm very active in terms of research and also teaching. So you can expect updates to this course. There's always something going on. And I will keep refining and revising some of the contents over the next few years. And I hope we'll learn and continue to learn together more about XR. So, thanks for taking this course. Again, I invite you to look at the other courses. It would be great to see you again. But otherwise, well, good luck with wherever you are. And I wish you the best of luck. Welcome back to the honest track. So you are now actually towards the end. Congratulations for making it that far. And I hope you've been working on these exercises and not just like looking at ahead and you really want to see what's happening in digital prototyping. Well, I understand digital prototyping is also very, very exciting. It can be challenging. This is really the part where it becomes tricky. It depends on a lot of factors, like what kind of equipment do you have available? Is your, for example, if you have a smartphone, is it compatible? Can you do AR with it? Do you have any kind of VR equipment? And so I will treat this exercise as let's just do it broadly. As long as we somehow move digitally, ideally this would work. Your prototype would work on an AR or VR device, something that you would call XR device. That would be perfect. Okay. So that's where we want to get to, and why are we doing this? Well, we are finishing up. We are like on track to this minimum viable product, the MVP, our final prototype. It's like with everything in life, there's a deadline, and then you have to be done. And obviously you could iterate and go crazy and expand. The main point here is to really just learn about the methods, playing around with some of the tools along the way. What comes out at the end? Well, if you follow the methods, it can't be that bad. And one thing I feel I should emphasize at this stage is we are entering the final stages of the honest track and the project that we are developing as part of the honest track. And there will be a peer review. So you will get to review other people's projects. You've already been looking at some of them as part of the activities along the way. You've been looking at various examples in the galleries. But now we're actually formally going to review each other's prototypes. Not now, that's after. Now we're going to do the digital prototype. But keep that in mind as we kind of like get ready for this final stage of the honest track. So in this exercise, the task is to create a digital prototype of an Expeditions-like XR app. Okay, so you know the rules. I'm not going to repeat it. We're still keeping with that app, and usually in the residential program, there are questions like, can I change my project? Can I work on a different kind of, solution or problem even? And I normally say, depending on where we are in the project, it's not a good idea. So when it comes to the digital prototype, it is not a good idea to now kind of change it, given the progress that you've made regarding storyboarding, wireframing, physical prototyping. So I feel like, well, why not just, make it through? Maybe you come up with something cool here and you like your idea again. Again, as part of this course, the whole idea is to just have one new idea. We're gonna mostly focus on what's existing. It helps us also do a digital prototype, kind of like recreating more or less that Expeditions-like XR app that we're using, that we're modeling our work after. So your goal is to prototype one of the key interactions of that existing app in and I'm now going to be very flexible here, 360, 3D, AR, VR digital tool. So there's a couple of key things here. It should be digital, okay? We're moving away from paper. Yeah, finally getting there. And we are going to use tools. There are tools focused on 360 prototyping, or you could even just do Photoshop with a 360 template. That would be acceptable. There are 3D modeling and authoring tools, and you would be digital. But I think, so don't do the just 3D modeling. But if that's what you want to learn, and you want to use a tool like Model Viewer or Sketchfab that actually bring things into AR VR, that is also kind of still playing by the rules. It's okay. I'll show you what I had in mind. I was working with A-Frame actually. So that required a little bit of development, but I was also playing around with immersive authoring tools for VR and for AR. So I'll show you what I've done. In the second step, you should really sketch, sculpt, or model, whatever the language is of the tool that you're using is a digital tool now, 2 to 3 main characters. So this will bring us closer to the story, to a digital version of the story. In step 3, I want you to think about that environment that we're actually designing for, and to which extent should that environment, that physical environment, should that be represented in our digital prototype. So I'll say make a virtual copy of the target physical environment. Really capture the context. Don't just like sketch into like thin air and just focus on the virtual content. No, make it clear, even from your digital prototype, what kind of experience is this supposed to be? So in my AR prototypes that I'm doing in VR, I actually sketch out the table to define the scale of my AR experience. So then the next step is to actually record a video and narrate the interactions. So I want you to, as much as possible, record your prototype. And different tools have different means to do that. A screenshot is usually not sufficient since we are focused on interactions. A video would be good. Maybe you can learn how to do screen capture on whatever type of operating system and computer you're using, or you're getting one for your mobile phone. So I've used a number of different tools throughout this MOOC, yeah. I'm not here to make really the recommendations. That's something we can figure out in the forum. But anyway, the goal is to record a video and narrate the interactions within that digital or immersive tool. In fact, optionally, I would like you to try out a different digital or immersive authoring tool. I make this optional just for workload reasons, but I do think actually you should. You should really try out a few different digital tools. So rather than go deep in one and like go crazy, I'd rather have you try out 2 to 3 quickly and then choose the one that you like, and then in this 5th step maybe come back to one of the other ones that you had previously. Well, not discarded, but like not focused on. So what do we have at the end of this? We should have a lot. So we actually then have a final prototype. That is an MVP, a minimum viable product, if you do it right. So it's as close as possible to the real thing. We might even be able to test it with users in a VR or AR headset. So that could be interesting. You went broad, so you really have this understanding of the environment, the 3D characters, the interactions. You prototype them multiple times in different fidelities. Now this is the last time you prototype them, now using digital tools. And you went deep. So you, at this stage, you will actually find out about AR VR specific requirements and development needs. So that is actually quite important. So these digital prototypes can really be function, if they're done well, function as a specification that you can give to a developer, an AR VR developer, or if you have obviously the skills, or if you want to develop the skills, I'll invite you to take the development-oriented XR MOOC course. But yeah, so there could be a handoff, and this if you don't do it yourself, there could be this handoff, and the digital prototype might actually very well provide this template for the developers. So I'm still doing this solar system. I never got bored. I've actually been playing around quite a bit. It's been fun. So this is a little bit of, going back in time when I started out doing the design critique. You probably did a different expedition or expedition-like app. Anyway, let's stick with mine. So the prototype, various prototypes from before, so various physical prototypes. I had a paper prototype that I was then playing around with. I created the 3D models along the way using Play-Doh or some kind of clay, and I played around with them, so that was really important. So playing with these 3D models in the physical world, but then also capturing it a little bit digitally and getting some kind of sense for how this might feel in an AR or VR experience. So that was cool. And then I did this diorama, and I was actually playing around with more of these objects and composing them together, and even using AR captures with my little AR camera, and then bringing in even still some of the physical objects. So really flexible use of both physical, captured virtually materials, and then bringing back in physical. So yes, I'm just advertising again for the physical prototyping parts, but now we are doing digital prototyping. I don't know, always get excited when I see physical prototypes. But I'm also going to get excited about the digital prototypes if they are done well. Now the problem is you could actually spend a lot of time and it doesn't look like anything in the end. So that is something that we should all be aware of. So especially when you look at others, each other's solutions, don't judge just because it doesn't feel like, wow, you didn't do a lot or something. No, maybe we struggled, maybe we had technical issues, maybe we just couldn't commit the time, maybe we just wanted to learn superficially about this process without going too deep. Like, we wanted to have this overview, and that's totally fine as well. So we're going to do digital authoring. We may do immersive authoring. So digital, as I explained in the lecture, is really more like with 3D tools on a desktop, and then you do previews, deploy to a device, or you somehow stream to a device. Immersive authoring means you're actually doing it directly on the AR or VR device. So I want you, if possible, if at all possible, to try this out. And then we can actually think about some of these platforms and approaches that are more development oriented. We can also think of some of their tools for digital prototyping. So A-Frame has an inspector, and I'm pretty fast with HTML, CSS, and JavaScript, so I think of A-Frame as a prototyping tool. Not everybody may agree, and that's fine. But Unity that I put here under cross-platform, or Unreal, these are some of the examples I'll spend more time on later. These are acceptable, actually relatively high fidelity, even complex AR, VR platforms, if you will. I mean, they have support for them. They are traditionally game engines, actually. And in any case, what I'm aiming for is, like, we're picking something that may be not as heavy as Unity and Unreal, because in the third course focused on development, you can spend more time in these tools. So try some. So here is me playing around with Immersive AR on the iPad, and I was using Adobe Aero, which I'm not sure whether it's free or not. I have an education license, and I can just play with it. It was a little limited in terms of how I could represent my planet, so I just had to choose from these predefined 3D objects, and that's a limitation of the tool. So just admit, not admit it, but just mention it. If somebody is like, hey, you didn't do a proper sun, earth, or moon, well, this is what I had to work with. Also, working with these more abstract representations is fine as long as it helps you learn something about, for example, the composition, the scale of the experience, or just like this mere fact of being in AR and doing an immersive authoring session is just cool. And the main thing is I want you to try it out. And well, so I'm doing it with Aero here, and then later in the video that I'm going to share with you, I'll also play with Reality Composer. And so Reality Composer, obviously Apple on the iPad, at least I could put in a few primitive shapes in there, and it's just good enough for planets. I really like that I chose the solar system and nothing more complicated. This was hard enough, okay? So don't make it too difficult on yourselves. You just want to learn about the methods and the tools, and you can work on the complicated project that you've always wanted to solve and do. You can do that later. It doesn't have to be in this course. Go through this course, take everything with you along the way. You know, build your toolbox and then apply it to your own project. And if you do, please let me know. It would be cool if any of this was helpful in whatever you wanted to do. That would make me proud. In any case, I was then also playing around with the Immersive VR authoring tool. Here I'm using blocks. And, you know, funny enough, because I'm doing a solar system and most tools actually have these relatively basic shapes in there, you just can play around. Here I have color, so that was cool. And later in the video, I'm going to go a little bit forward. I'm grabbing the objects and playing around with them and trying out different compositions. And I hope I'm just taking the moon. Maybe you missed that part. I like my little hand there. It's really quite cute. Zooming in and zooming out. Okay, I'll show all that obviously, but here maybe, yeah, this is the part that I wanted you to see. And you check out the video later in more depth if you want. But this is why it's cool, because now in immersive authoring I can actually play around using my tiny little blocks hand there. Can't get over it. And you know, do it. Experiment and play, and that's well, this you can't say that this is a final experience, okay? So I'm just doing immersive authoring. It'll get a little better. I'll increase the fidelity by one more bit, whatever the unit is. And here is our one more bit. So I'm showing you, and I'm going to share this whole video with you as well. proudly present to you our A-frame based, so WebXR based solar system. Now this is something that I've started, and then I had a few students also contribute to it. It's also the kind of exercise and example code I will share with you, and it's also something that I share with my residential learners. And it's it's not too complicated. It's a few spheres in there. They all textured nicely, so we got the right NASA pictures, public domain, of the planets, and then we added a little bit of interactions here, and some text. Text doesn't work so well in AR or VR, but whatever, we're trying that out. This is not supposed to be the final design. This is where you feel like, okay, if I write a lot of text above the planets, that may not be the best experience. And that's what this is for. So that's okay. I'm going to jump ahead because I also later run it in AR. Oops, that was like right in there. It is directly here in the studio, and I was just like, also talking a little about the tracking and how the tracking doesn't work so well sometimes, but this was pretty cool. And yeah, so if you feel like it, at the end I'll also show cardboard. It feels like a step back, but this is my target device if you want. So I didn't do too much for the Oculus Rift. I mean, teleporting in space seems like an interesting concept. VR teleporting. I know that in Star Trek they have. So I know about Star Trek. Don't worry. I know that they have beaming there, but no, teleporting in space just doesn't feel right. But I wanted to think about different locomotion techniques. Again, this is just our digital prototype. So again, when it comes to digital prototyping, keep in mind we can also create multiple versions of our digital prototypes. You don't have to, cover everything that you had in mind. I want you to be selective. I said one key interaction, and yeah, it should be important to your project, not just a login or whatever. No, it's something key, and you can do it in 2 versions and maybe add more to it. You don't have to go all the way. I mean, ideally, we would get there at the end. We would actually have our MVP, but that doesn't have to be the scope of how you go through this exercise. You can work with one tool, and if it's too limited or you feel like you want to add a second tool, you don't have to prototype the same thing with both tools. I'll talk about prototyping strategies just as a reminder in a second, but you could also just fit in another tool because it allows you to just create that 3D model that you need, and then you can import it into that other authoring tool, and so that would be cool too. So here are the digital prototyping strategies I talked about in the lecture. So you can do parallel prototyping. That's especially when you work in teams is very effective, but even just you prototyping the same feature with different tools. So if you are don't know which tools to use yet, you could choose a very simple feature or a particularly hard one and prototype it just a little with a few different tools. You could prototype different features with the same tool. So that's iterative prototyping, because ultimately you create this entire set of features in one tool, and that may actually then be your prototype. You could do the divide and conquer and actually prototype different features in different tools. Now for this activity, I would recommend strategy 1 or 2. Probably go with just iterative and just use one tool, but then in an optional 5th step, I want you to try out a different tool. You don't have to prototype the same thing again, so it could be that you parallel prototype, or it could be that you divide and conquer at that stage if you make it to that 5th step in the current task. So what that would mean is if you have followed through in the honors track, you have done your design critique, your storyboarding, physical prototypes, and now actually a digital prototype with an immersive tool, with a digital or an immersive tool. And so that means you have some subset of all of these deliverables. And I say deliverables because at the end of this, we will actually do a peer review. And that is something where both you will actually get feedback, but also provide feedback to others. And so this peer review activity requires a little bit more explanation. And so I have more information actually in depth in writing for you. Don't worry so much about the grading. We're still here to learn, but we do need to establish some basic rules so that we treat each other fairly and with respect, which is really, really important to me. So I'll talk about that. Just getting ready for that part, as you can tell. No. At this stage, don't think too much about the peer review. I just wanted to mention it. I didn't want to bother you before, but you saw it in the syllabus. It was mentioned, but it's not the main thing. We don't do this to be graded. We do this to learn. And so in this last step in the honors track, the digital prototype, I think you'll learn a lot. Don't just keep these other steps very short and then spend like forever on the digital prototypes, or spend too much time and running out of energy on these lower fidelity ones and then don't do anything almost on the... No, all of these are important. None of these replace each other. They're all here to learn. I wouldn't skip too many of these steps. I wouldn't do every single type of storyboard or type of physical prototype, or using all kinds of tools when it comes to the digital prototype. I wouldn't do that in a project. I usually have, at this stage, I've developed an intuition which tool to use, or I'm just stuck and do everything with A-Frame or Unity just because I feel like I'm fast, which is not always true. Okay, so don't get me wrong there. But so the point of this was that we are developing this picture book style approach to XR prototyping. Doing it by the book is fine first, and then later you can cut corners. But don't cut corners and not understand the whole thing. That would be a bit, wouldn't provide the right foundation. So that's why we're doing it this way. And I hope you will have some fun in this final week of our digital prototyping activities, and I'm looking forward to seeing a lot of the prototypes coming together from this course, and I'll see you again for the peer review. Again, welcome to the honors track. This is the XR design critique. This is the exercise that is going to get us started as part of the honors track. So for every exercise, I'll provide a little introduction video. The specific instructions regarding the exercise will be shared through the MOOC, the readings that we have. But this video provides an overview and talks about some of the main steps and why this exercise actually exists. So, design critiques are very important. I'll talk about that in its dedicated lecture. It's a ritual. In fact, in my course, when I teach this residentially, every student has to critique an existing AR/VR app, and it's really cool because when you bring together all these students and they critique these existing apps, everybody learns about existing apps, and also we practice our skills of doing a thoughtful, productive, but also with constructive criticism, a rich critique, something that we can learn from. And so that's what we're trying to exercise here. So I'm going to walk you through the main steps of this exercise. So the task, should you choose to accept it, is to critique an existing expedition-like XR app in 360 VR or AR. So I say this so that we have maximum flexibility. You don't necessarily have to have VR or AR. You can just do it on a smartphone with 360. So, and I say expedition-like XR app. I'm thinking Google Expedition, and I'll tell you a little bit more about Google Expedition in a second. But also, it could be your favorite museum if it has an app, or something for the city, or something that feels like you can go on a tour. I want it to be not too complex an app, but the activity is really to critique it. And if it's too complex, it might probably be one of the main criticisms. So, what I'm thinking in the task should be to record yourself describing the XR experience using Think Aloud. It's very important. So the Think Aloud part is really important. Yeah, you should play around with it, and then you play around with it one more time, and then you record what you're thinking. Even your most often the first time impressions are really the ones that are really, really cool to capture in this Think Aloud. But maybe we're not used to this idea of thinking aloud as we're using something. And that's something you have to practice. And so And I'll show you an example of me doing a think aloud while playing around with an existing Google Expedition. I chose the solar system one. I want you to describe the context of your XR experience. So I want you to, well, basically share, when you share the results of your critique, whether you have operated this app in 360, in VR, in AR, have you been in a private or public setting. So if you were, you don't have to be too specific, but I think it may have impact on how you critique the app. Maybe it was not designed for the context in which you used it. And so that's then something that we could also discuss as well. I want you to critique the expedition using the template, the I like, I wish, what if template, okay? So I introduced it in the lecture and I'm gonna briefly mention it again in the next few slides. I want you to analyze the expedition in terms of guidelines. So really design guidelines first, and I provided some examples of guidelines. I mean, as you know from my lecture, I'm never really happy with all the guidelines we have. We don't have enough guidelines, and those we have are not good enough. So anyway, this is a starting point. I want you to also articulate ethical, social, or privacy concerns one might have. I mean, you might have them, you might not have them, but users could have them, and so I want you to think about that. So the expected results of this activity and this exercise are that you have now provided a balanced critique of positive and negative design aspects. So really start with the positive, remember. You have developed initial ideas for how to change and improve the design. That will be very helpful for you as you're continuing to work on this and go into the next stage, which is storyboarding. And as part of storyboarding, we do brainstorming. And you also have a better sense of what to look for in terms of design guidelines. So that would make me really happy if you achieved all these, if these were really truly the results. So that would be cool. But that's what I'm hoping we get out of this. And if you practice critiques and you really think broadly about some of the concerns, then I think this will be very valuable and might be a lot of fun to also discuss with your peer learners here. So please, we'll have forums available and we can chat. So I said the expedition that I had in mind, the actual app is Google Expeditions. So now Google Expeditions comes in VR and in AR, and it's actually popular in classroom environments. So Google is targeting education scenarios, and I thought this is a good app for us. But I say expedition-like. It could be really anything, but I don't want it to be too complicated. Ideally, it's publicly available so that others can actually also try it out. So you should be clear how you obtained the app if it wasn't Google Expeditions. So here's an example of me running the World Cities Expedition, and I've covered that in the lecture. And here is a video of me trying it out, actually here in the studio, the solar system app.
All right, I'm going to do a design crit, an XR design crit of the Google Expeditions, the exploring the solar system, and we're going to start it in AR. So initially, I think this works quite well. Detects the surface okay, and then the problem is that the planet is like really big that we're getting, and any attempt to resize doesn't work. I can just raise it, but I have not figured out a way to resize or rotate. And that is actually something that I would normally expect from an app. Then you can learn more about the sun, and what we're going to do instead is we're going to look at Earth. So Earth is obviously smaller than the sun, but it's still definitely quite big. And same issue, but I do like the inner planets. So that's like kind of cool when they then appear above the keyboard here. So there's Earth, and we can look at some of the detail, maybe even find parts. Well, maybe you can find where you live, and that could be interesting. And tracking works. Tracking is really robust, obviously, so that's kind of nice. And then the moon, again a monster, boom. And it's just massive. And we have the outer planets. So that's also pretty cool. And so it would be nice to have labels on these. I really like the look of the planets, but like having labels would be very useful. And so that you're actually learning something. I mean, right now it's kind of cool. The asteroid belt. It kind of looks cool and nice. The dwarf planets. But then you would really want to learn a little bit more. And the interactions here are definitely pretty limited. It does look cool though. I must admit that. So I would say I like the look of the planets. That's pretty cool. And I like how I especially like the inner planets, and I like how they've broken down the solar system. Although it's harder for me to build the relationships between the different kinds of views that I have on the different planets and the asteroid belt and the moon's normally obviously going around Earth, so would have been nice to see that. I wished I were able to rescale, resize. So this, I just don't understand why I would want to raise it like crazy. It does make sense when I put it on, when I relocate it, but I also can't relocate it. So I don't know how to do that. Can send feedback. Yeah, so what if you were allowing me to scale it once, and then also, like, I think the other thing is the distance. When I then switch, I'm sure it's gonna just be again. Oh, it does keep in mind what I wanted in terms of distance. Oh, it does. It does not rotate and scale. That's really my biggest complaint here.
And so here is what you just saw, at least a subset of it. And these are all the screens. So this is the download screen, obviously. Then you enter it, you place it. I didn't have a screenshot for the placing part. And then once you have placed it, you have like this card interface down there. And this edge is really, really key. It suggests that there is more. So you swipe to the left and then you get to see Earth. You can swipe up and you get to see some of the information about Earth. And then you swipe to the left again, you bring up this screen and so forth. And this is how the Expedition works. And I want you to critique the Expedition app, the Expedition-like app that you chose. I want you to use the I like, I wish, what if template. So what you like about it, important to start with something positive. And there should be two positives, okay? What could be improved? And here really try to be specific, try to be objective, not subjective. And what could be improved is one thing, but how would you improve it? How could it be improved? This is really the hard part. This is what we're after here. This will help us develop some new ideas as we are going to improve upon the app. So here are some examples. The look of the planets, that's pretty cool. I think that's something I said in the video. How they have broken down the solar system is something that I liked. I could resize and rotate the planets. I really wished I could. And I could better understand the relationships between planets. It was really just not enough. Like the scale was really unclear. I could adjust the scale and rotation using pinch to zoom. Yeah, that was very confusing to me. I remember the going up and down part. That was weird. Like, why does it only change around the Y? And so how would I improve it? Well, using pinch to zoom, for example, which is a very common gesture. And how could I adjust the distance to the planets? And then the other idea is to adjust the distance to the plane using drag and drop. So that was referring to the fact that once the expedition was placed, I basically had to restart the app. I couldn't figure out how to move it to a different plane. Maybe it is somewhere in the app and I just didn't notice, but then we need to improve upon that aspect. That is called bad usability. If people cannot discover what you can do with the app, then yeah, we have a problem. So this was a review based on the design guidelines using the I like, I wish, what if template. The next thing I want you to do is also to perform an ethics review. And I was talking about design ethics review as part of the XR Design Ethics lecture. And I was describing these 4 main steps or considerations as part of the review. So the context and situation, the sensory information and data, the processing pipeline as much as you understand it. I mean, clearly you will not have developed the app, but maybe you are developing an intuition for what goes on behind the scenes, or the app informs you. And this informing part in terms of terms and what you consent to, this is also really key that we want to look at for data ownership and governance. So in my example, that would be that I was using the AR version in the studio here. I was actually the only user in the device vicinity. I mean, my bunny was probably in the background, but we don't know. The sensory information, well, it sees mostly me. It sees the furniture. It does see expensive equipment here. Keep in mind that this equipment is on loan from the University of Michigan, so this is not my own equipment. The surface area of the table and the floor. So altogether, you can obviously you can actually make some sense of this information, both for tracking and registration, but then also maybe in a negative way. And so that goes more under the ethics part, obviously. The processing pipelines, I think it's a pretty naive application. It does standard surface detection, doesn't do a lot with spatial mesh. In fact, it doesn't have a spatial mesh. There's no scene understanding. It may build anonymous usage statistics. I don't know about that, but it keeps a library. It keeps track of the different kinds of expeditions I was downloading. There is a teacher mode, which I think is a bit more advanced and multi-user, and that has potentially a more complex processing pipeline and actually will raise additional concerns. Expeditions app manages the downloads, as I was just talking about. There's this library tab. So that's the kind of information that I know. I don't know what they collect, and I also don't know, because these expeditions were actually developed independently. So there are some Google ones, but there are also ones developed by others. It would be interesting to understand the expeditions framework a little bit better and understand what kind of data is actually being collected and shared with those third-party vendors. That's it, right? So we're going to learn a lot about ethics by actually thinking it through, but we're also going to do a design critique more broadly, thinking obviously also about the social and ethical concerns as I was just talking about, but also thinking a lot about the design and design guidelines. And so pay attention to whether you're doing an AR or a VR expedition or something in between, like 360. Share that with us and fellow learners so that we actually understand your critique better. Let us know how and where you used it and what you found confusing. And well, we should get a first indication of the kinds of things you think you would be improving as you keep working in this honest track on the next steps, which would then be storyboarding and wireframing, really brainstorming new ideas and fleshing them out.